Welcome to this exciting compilation of machine learning projects for 2024. As we move further into this era of technological advancement, machine learning continues to be one of the most sought after skills in the job market. From AI-driven innovations to data analysis, machine learning is shaping industries and creating new career opportunities. If you are looking to kickstart your journey in this ever-growing field, you are in the right place. This video is packed with hands-on projects ranging from easy to intermediate levels, perfect for beginners. Working on these projects not only helps you to understand key machine learning concepts, but also boosts your portfolio, increasing your chances of landing a job in this competitive field. We have got a diverse range of topics covered in this video, starting with an introduction to machine learning and exploring how models learn, including supervised, unsupervised, and reinforcement learning. We will dive into popular algorithms like k-nearest neighbors, linear regression, naive Bayes, support vector machines, random forest, and more. You can expect demos on decision trees, regression analysis, and logistic regressions, alongside fun projects like Marvel superhero analysis, fake news detection, and predictions for car rentals. Let's get started and level up your machine learning skills for 2024.
Machine learning is one of these concepts which form to be the most important aspect of data science that there is. When you think about how you can get to artificial intelligence, right? Artificial intelligence and data science go hand in hand because AI is the biggest application of data science there is. But to get from data science to AI, you require machine learning in the middle. That is why it is the most important stepping stone that adds so much value, right? So what are we doing with machine learning? With machine learning, the goal is very simple. So we make sure that, we get the machines to understand data on its own, to learn on its own, and eventually give us a solution without us having to intervene during this entire process. Now, it is very, very easy to say that, hey, machines are very intelligent. They understand a lot of things. But as I've been mentioning in the previous modules, your machine can only understand zeros and ones at its most functional level. Everything apart from that is just added for our convenience of how we can communicate with the machine better, right? So if you show a picture of a cat or a dog to your machine, there is a very good chance it will not understand anything unless it is trained or unless it is told that, hey, what you're seeing is a picture of a cat, what you're seeing is a picture of a dog, right? So what is the goal if it is naive at this level? Well, the goal is to make sure that our task in many cases can be simplified to its most easiest way possible by getting the machine to do work for us, right? So making the machine think like us, making the machine think like human beings is the primary goal here. Now, again, if you've been wondering about where the machine learning data comes from, where it learns, again, there are numerous data sets to, singleton problems, customized problems. There's so many ways where you can collect data, as I've been already telling you since module number 1. You can collect data from multiple places and then have work on it, right? So here in the case of machine learning as well, the same thing applies. Data comes from a variety of places, it gets stored, and eventually then, a solution is derived based upon the data at hand, and after it goes through an algorithm and all of that. So the first question you really should ask yourself is, why is machine learning required in the first place? Why is it, the biggest thing in today's world, right? First of all, you have to understand that there's hundreds and hundreds of reasons. We can have a discussion hours together just talking about the advantages of machine learning. But to give you a clear and a concise picture of what, you can expect, well, here are some of the important pointers. First of all, the most important thing is that it will help reduce production cost to a very, very big extent, right? Now, it is not only just production cost, it is everything right from production till delivery of of a product to the customer, right? Machine learning can sit in all of these different phases of product manufacturing and delivery in a way where you thought it was not possible before, right? From material procurement, right from actually processing it, quality control to delivery, supply chain analysis. You can do everything when it comes to production here. The next reason why it became really popular is that you already know we generate a huge amount of data every day, right? With machine learning, the advantage here is that you can process all of these very, very easily, very in a simple fashion where you do not have to break your head to go through a lot of data, right? That's the advantage. The next thing is individuals, startups, multinational corporation, whoever you are at the end of the day, you can derive some key insights about your business in a very clear and a concise way if you go on to make use of machine learning. It simplifies your tasks not only in a way where it tells you that you've gone wrong here based on the past data, but it can also use past data and present data and give you a forecast into the future. It can tell you, hey, down the line, your company can sell these many products. It is forecasted that you can sell all of these products. So imagine, probably a couple of years before, maybe 20, 30 years before, if someone told you can use your computer to predict the future, they would still treat it as a joke, right? Now it's not so much of a joke. Data is the new oil. It is packed. It's a treasure. You can use it to derive all of these insights. And it's a beautiful thing to do it as well. Again, we're going to see all of these practically in this module. The fourth point is what I just mentioned, right? You can find out hidden trends that are present in data. Now, let's say data, think of data as maybe a bowl of rice, right? If you just look at a bowl of rice, you really cannot make any sense out of it. But let's say that there is little snippets of gold hidden inside this bowl of rice. So if you put your hand, dump in, if you churn through the rice, and if you put in your hand, do the hard work, and then you can pick up these tiny figments of gold which was not visible to the naked eye, right? This is exactly how data is. It's like playing treasure hunt with the data. You will know that there is something at the end of the tunnel, but to get to that, you have to work. That work takes extreme amount of processing, and that is why we require machine learning. So I hope I was clear with why you guys should definitely look at learning machine learning, right? So next up, we're going to check out how a machine learning model actually goes on to learn. What is the procedure that a machine learning model uses to learn, right? Now guys, you see a term that I'm using here, machine learning model. It is very different from a machine learning algorithm. See, once you have the data, you create an algorithm. You use this algorithm along with the data to get your result, right? But after it has seen the data, after it has learned and trained, it is no longer called as a machine learning algorithm. It is called as a machine learning model. So whenever someone says model training, model has trained, they never say algorithm has trained. Algorithm will be used for training. That's it. So after something gets trained, it is called as model, guys. Make sure you keep this in mind. Right. So how does a machine learning model learn? First of all, for a machine learning model to learn, it requires data, right? Again, I'm going to give you a real life analogy here, but let us talk about machine learning aspect first. You have certain data, one chunk of data that which you're going to use for this particular solution. You're going to split it into two actually. One batch is called as the training data. The other batch is called as the testing data. Training data is everything that you push to the machine learning algorithm so that it learns, so that it uses it to understand what is going on. Next, to verify if the machine has learned anything or not, you are going to use another set of data which the machine has never seen before to eventually, go on to see if it has learned something, if it can do things in the correct way or not. So training data is used to train. Testing data is used to verify if it has learned or not. So usually in the common usage, data is split into 70% of training data, 30% of testing data, or 80% of training data, 20% of testing. There's a very good balance here in a way where majority of the data gets to the training, because more the data the machine can train better. And of course, you can get away with a small amount of testing data to verify if it has learned something or not. But then again, this depends on the type of solution, the type of algorithm, the type of learning that eventually has gone on into usage, right? It's not always the case where, if you just use 70% of training data and 30% of testing data, that you will get the correct solution. This is open to experimentation. Sometimes you'll use 70 on the same data set. If you go on to use 85% of training data, it will give you an exponentially better solution because it might have learned something new in that aspect of data which you hadn't given it before, right? So it's very important. Now, coming to the analogy, this is literally like how you would write an examination in school or college, right? First of all, you would have been given a textbook or any other study material where you're going to use it to learn nicely. And after that, there's going to be an examination where people are trying to evaluate. They're trying to verify if you've learned something or not. Well, training data, testing data, exactly the same thing, right? Now, I hope you have complete picture on the data side of things. But to talk about the entire life cycle of machine learning, right? Well, here it is. Whenever you are solving any problem, be it a real life problem, a hypothetical problem, whatever it is, what is the first thing? The first thing you have to understand is that there is a problem that you have which machine learning can be used to solve it. The next thing is you understand the problem itself in a way where your thoughts are aligned towards using the domain to solve the problem, right? So once you understand the problem statement, once you understand the business problem completely, then the second step is, okay, so now I understand the problem. Next, I need data to go on to teach my machine learning algorithm and use it to train, right? That is exactly what goes on here as well. After you understand the problem, you start data acquiring, you start gathering data from multiple different places. Data can be stored on your server, on your cloud computing platform. It can be on your pen drive. It can be social media data. It can be competitor data. There is no end to bringing in data from any different source of choice, right? So it's very vital that you understand that you can bring in data from multiple ways and eventually use it. Now, the third thing which we already discussed in the module number 1 is data cleaning, right? I have been mentioning so much that data cleaning is very important. If you do not clean your data, if you feed incorrect data, your machine learning algorithm is going to learn things wrong. If I show it a picture of a cat, but if my data that I've given it says it's a dog, your machine learning algorithm is going to say, hey, it's a dog. Well, as soon as you look at the image, you're like, okay, that's not a dog, that's a cat. Because right. You've been taught right from your childhood. Your machine learning algorithm, that's not the case. If the data is incorrect, it will definitely lead to a very inaccurate result, which is going to be a huge waste of time. So it's very vital that data is cleaned. Now, once data is cleaned, you can actually hunt into the data even before applying machine learning algorithms to get, a good amount of insight. It's called as EDA or exploratory data analysis. Exploratory data analysis is very, very, very popular because, again, no matter where you can think of it, right? See, you have data which can give you so much insights. If you're exploring into it and picking out insights out of it, that is literally nothing but exploratory data analysis. Again, it's completely a domain of its own. It's a module of its own. We're going to be discussing it in detail. But for now, you have to understand this, right? You can get a chunk of information, right, without even performing any machine learning operations. But once you go on to have this basic analysis done, you want to delve deeper into teaching your machine learning. That is when you will bring in a machine learning algorithm. We already saw the 3 types of learning. What were they? Supervised learning, unsupervised learning, reinforcement learning. So you're going to use one algorithm or one or more algorithm with this particular type, whatever you think is the right for the solution. And eventually you're going to apply the machine learning algorithm on the data. It is eventually going to train and it's ready to be verified. You fit the data, you verify if the machine learning algorithm has learned anything or not. That is the step where I'm saying predict your model accuracy. To see if it's accurate or not, first of all, you have to find what's the correct thing, and eventually, what you predicted would be right. So once you mix and analyze the differences that exist between what you predicted versus what actually is the reality, you will get an accuracy difference. That accuracy difference will eventually tell you how well your model has learned or not. You can repeat step 2 to step 3 again. You can repeat the entire process to make sure your data is better, it is cleaned better, you're using a different test train split. You can do a lot of different things until you get to the last step, right? So once you experiment, you will have different models which will use different sets of accuracy to learn. So you will have this idea. After which, right, the last thing that you will do is deploy the model. When I say deploy the model, it means that I have the solution for the problem ready, and now I'm putting it out there so that I can actually and eventually solve that problem, right? That's the process of model deployment. Maybe it is going on a server where you're trying to implement ML on your website. As I told you, right? Amazon, Netflix. So when they code it in the background, they've done until predict your model accuracy step. After that, as soon as they put it on their website, as soon as things go live, that is when they have deployed it. That is when it is actually working to provide a solution, right? So that is something that you should know about. Right, so guys, this is the entire architecture of how a machine learning model learns and works. I hope I was completely clear on this aspect. Python is the most important programming language we have whenever we're working towards machine learning, right? It is very, very, very vital that you, of course, you can use multiple different languages for machine learning, but you have to find the simplest and the easiest way to do it so you don't break your head about complex syntax, but rather use your time effectively to eventually drive a good solution, right? That is where Python comes into the main picture. Python is a very, very powerful programming. As we have discussed already, it is the most popular language out there. But for machine learning, it is the number one language. It is always preferred no matter what. Why? Because it gives you a high level syntax where you can again spend time on logic rather than the syntax itself. It's very easy to work with. And personally, if you ask me, the biggest reason why it's popular is now when you think about machine learning, if you've never looked at machine learning code, there's a good chance you might think, okay, so if I have to teach my machine, train it and get it one step closer to artificial intelligence, it might take a huge amount of code. Guess what? With Python, that's not the case. A tiny amount of code that you write can have a huge impact, as I'm going to show you practically now. It's a very important thing, right? So you don't have to write 100 lines of code to see a tiny output. You write the tiny line of code to see a huge output. That is the power of which Python adds to this field of machine learning, guys. So that's an important thing. And of course, working with Python is amazing. You have multiple ways. You can install Python from the Python website. You install it via Anaconda. You can have an IDE, an integrated development environment like PyCharm, or you can use a very simple Jupyter notebook on the Google Cloud platform called as Google Colaboratory. Again, all of these are free to use. So eventually at the end of the day, working with it, setting it up and starting to use is easy, as we have already discussed in the previous modules, right? Here are some of the important libraries which you're going to require for machine learning as well. First of all, to store data, to array processing data, manipulate it, and eventually work with complex numerical computations and data manipulation operations, you require NumPy and Pandas. NumPy and Pandas we covered in the last module to a good amount of depth to show you all the operations which you're going to require, right? Again, we're going to use all of these now as well. But then one important library that is very, very important for machine learning is scikit-learn. Scikit-learn is a beautiful library which is meant for machine learning, which is built so that machine learning can be worked around with in a very, very easy fashion. Right, guys. So after this three libraries, again comes data visualization libraries. You have Seaborn, you have Matplotlib. We're going to discuss all of these in the data visualization module in depth again. Right. Now, whenever you're taking a look at the traditional way of how one can go on to program versus how a machine learning algorithm learns, there is a huge difference which you may or may not know. So when you compare traditional programming, how does it differ with machine learning, right? Here it is. It's a very, very important difference. Look at the left of your screen right now. I've put in traditional programming, right? In the case of traditional programming, what usually happens is you have data and you have a program. Your program uses the data, it's a compiler, whatever it is, and eventually gives you a simple output to work with, right? You have input, you have the computer program, input goes into the program, eventually what you get is an output at the end of the day. With machine learning, that is not the case. You have data and your machine learning algorithm already knows what the output is. It will know where it has to get to. It's not like there is no light at the end of the tunnel here. It already knows that, hey, using this data, I have to get to this output. So how can I get from this data to this output is how machine learning works. The entire process of it learning to to go from understanding the data to get to the output is where it's called as a machine learning model, right? So every time, we talk about machine learning, it can be very confusing saying, hey, you have an input, you have a program, you get to the output. No, with machine learning, you already have the output and the data in the previous stage itself, and the process is what is, it's what we are after basically when we look on to this domain as well, guys. So this is a very, very important difference which you should know about if you're looking towards learning machine learning, no matter what level, basic level, intermediate level or advanced level. This is a foundational concept which you guys should know about, right? Now, the next thing after you understand why machine learning is that you have to look at the different types of machine learning, because if you do not understand the fundamental concept of how machine learning is divided, it becomes very difficult later down the line. So guys, there are three different types of machine learning of, how a machine itself learns in this domain. It is supervised learning, it is unsupervised learning, and it is reinforcement learning. Now, these three learning methodologies, right, they work in very, very, very different ways. Each has its own application, each has further subdivisions and a lot of things, but these are extremely important. These are foundational for everything. Make sure you're putting an ample amount of concentration for these slides, guys. Right. The first one that we are going to check out is supervised learning. Now, think away from data science, think away from machine learning for a second here. When someone says supervised learning or that you're learning with some supervision, what's the first thing that comes into your mind? Because for me, it's probably a child who is studying for an examination and there's a parent who is supervising and making sure that, the child is not playing games but is actually studying. Supervision, right? Keeping a control. Now, in the case of machine learning, things work similarly to the analogy that I just mentioned to you. Here, however, it is not the machine itself governing. It is the data which is governing. It is the governing entity in a way where the machine itself knows what data it is seeing. It is, not literally being supervised, but it understands the data as if it were supervised. That's the difference here, guys. So, you have three images on your screen right now. Let me use those examples to explain supervised learning for you. You have the image of a flower, you have some dumbbells, and you have a car here. Now, you as a human being is probably taught from a very young age to see not one, not 100, but 1,000 pictures of flowers to say it's a flower, right? You will not see a flower and call it an aeroplane. You know that is wrong. You have been trained over the years again and again and again. You see a picture of a dumbbell, right? There's a good chance it can be slightly confusing because you might have never used a dumbbell, or if you have, it is very easy to spot it, right? Now, car is definitely a popular thing that you've seen, you've known. You would have seen thousands of cars in your lifetime, hundreds of colors, hundreds of models, all of these. So as soon as you look at the picture that I've put in here, there's a good chance that you can say, hey, it's an orange color, it's this brand, it's a coupe, it has this brand, sport wheels, it comes with this engine. You can actually go on to tell the model just by looking at that image. But if you show the image to a computer, no, it will not understand any of these, right? You have to be very clear about that. So to bridge this gap of us telling the machine what it is seeing, right? The advantage of supervised learning is we give the labels for the data. If the data is the image of a flower, we give a label. We tell, hey computer, here is the image of a flower. We specifically mention that it's a flower and then give the image to the machine learning algorithm. So at the end of the day, the machine learning algorithm already knows what it is seeing. So it uses that to learn and later predict other images which might be of the case. Now, this is just one example of supervised learning that I'm giving to you. But having these labels below that says this is a car, this is a dumbbell, this is a flower, right? That is very important for supervised learning. Now, with unsupervised learning, you don't do this. I'm going to explain that in a second. But before that, here's another important concept that you definitely should know about when it comes to supervised learning. See, supervised learning is a very simple form of how we can have an input. How can we apply a function on the input to eventually transform and arrive at a solution, right? So if your input variable, as we call it, is considered as x, applying a function on it becomes f of x. if you assign this to another variable y is equal to f of x is what we get. This is the foundation of supervised learning. We are trying to map the output as a function of the input, right? So we have the input, you're doing some transformation on the input, which eventually takes you to the output, right? So whenever there is a common discussion, y is equal to f of x, now you know what y is equal to f of x means. You have an input, you apply a transformation, you apply functions on it, you do a lot of things to the input to take it from its raw form to a processed form, and the processed form itself is considered as y, which is the output variable in this particular case, guys. So this is a very, very important thing about supervised learning that you should know about. But then, did you know that supervised learning is further branched into two things called as regression and classification? Now, first of all, machine learning is divided into three things: supervised learning, unsupervised learning, and reinforcement learning, right? Now, supervised learning branches into two, where it's called as regression on one side, classification on the other. Now, if you've been wondering about what regression means, again, regression is a concept which I have already discussed previously, where you take in data from the past and you try to predict what might happen in the future. Or let's say you take data from the past and you understand why we are at this point in time today, right? We're going to be discussing a regression use case practically as well. So make sure you stick around till the end of this module. So regression is a very simple concept. Again, we're going to discuss it with an example. But if you're looking at classification, right? Classification is a simple concept which you've already used. Regression is something which you might have used in a casual conversation, but classification is something which you have done. Let me give you an example. If I give you, a ripe apple versus an unripe apple, or let's say I give you 3 apples or 2 oranges, I mix it and I give it to you. I say, hey, based on the shape of the apple, based on the shape of the fruit, why don't you split it out and classify it differently? Well, an orange is a round fruit, right? So you just take it and you move it to another place. On the left, you keep an apple. The apple has a very unique shape, right? So you put it on the left. Now, if I said, hey, why don't you classify it now based on the type of fruit? Now, there might be a case where there's a defect in the apple and it is now round, right? There are certain chances that it is almost round, you can get confused. But if I say, classify it based on the fruit only, you will know no matter what size or shape the apple is, push it to the left. No matter what size or shape the orange is, push it to the right. That is a simple way of classification here. Now, let us take a look at supervised learning. Unsupervised learning is one of these types of learning which is a direct contrast to supervised learning. Here, the entire goal of the machine learning algorithm is not us telling what the data is, but it figuring it out on its own. So the entire usage of unsupervised learning is based upon how the machine learning algorithm itself can find some sort of hidden structure or pattern that is present in the data without us specifically telling it, right? Now, take a look at the same 3 images I have on your screen. Flowers, dumbbell, and car. But this time I have not labeled it, right? That is done on purpose because here in unsupervised learning, you do not label the data. You just give it an input variable and let the machine learning algorithm figure out on its own. Now, there is a very, very good chance that now there's a question in your mind saying, okay, so if you're not helping the machine, is unsupervised learning a complex procedure compared to supervised learning? In many cases, the answer is yes, because here, it is not just cross-referencing what it has learned to what it already knows, but here it has to, first of all, learn in a very different way and then work on cross-referencing. So it definitely takes a good amount of computing time, computing power, and of course, the way the machine learns, the way it uses algorithms to already know that it only has the input to get to the output and find a structure is very, very different compared to supervised learning. So I hope I was clear in that point, right? Now, if you're looking at grouping, another very important thing that you have to know in unsupervised learning is that there's 2 groupings just like how we had for supervised learning. But here, instead of regression and classification like how we had in supervised learning, in unsupervised learning, we have clustering and association. Now, clustering is a fantastic example, which again, you would have used in your real life anyway. If I give you 3 erasers, 2 pencils, and 5 pens and say, can you group all of these things separately and keep it into 2 or 3 piles? Can you or can you not do it? You can do it in a very simple way because you know what a pen looks like, you know what an eraser looks like, you know what a pencil looks like, and you know how to club it and group it and keep it separately, right? Does the machine know this? No. But if you train it, can it understand this? Absolutely yes. That is the entire point of using unsupervised learning, right? So that is a simple example of clustering. Now let us take a look at a simple example of association. Again, association is something which you have used, but you might not know you've used. Maybe you're on the Amazon's website. Maybe you're buying your favorite thing. Maybe you just bought a new mobile phone. Now, as soon as you buy a new mobile phone, as soon as you add it to the cart, there's an option below which says people who have bought this mobile phone also bought this. It may be a screen guard, it may be a case, it may be an earphone, whatever accessory, right? So it is recommending something to you. It is saying, hey, people bought this. No, people who bought this also bought this. So it is trying to map something. People who buy this phone have a good chance of buying the protective case for it, tempered glass for it, all of these things, right? That is association. Here's another example. Every time you finish watching a TV show on maybe Netflix or Amazon Prime, at the end of it, there is a good chance it recommends a very similar TV show for you. Now, if you watched a horror movie, the next recommendation is going to be a horror movie or a thriller or something like that. If you watched a comedy, a situational comedy, sitcom or anything like that, after you finish an episode or after you finish the TV show itself, the next one it's going to recommend to you is something similar, because here, Amazon, Netflix and all, they're trying to understand what your preferences are, what you like watching, and eventually customizing their platform so your viewing experience is amazing, right? That is association. If you've been wondering, association is used not only in these 2-3 cases, but almost everywhere that you can think of. Everywhere where there's customization, where there is a goal to make sure that customer retention is high, will use association, and even in fact a concept of clustering very popularly as well. So it becomes very, very vital that you understand that unsupervised learning is among the most popular algorithms or the types of learning there are in today's world. Right. Now that we checked out supervised learning and unsupervised learning, let's get to the third type of machine learning. Here we're going to take a look at reinforcement learning. Now, reinforcement learning is a very, very fun algorithm because, again, here's an analogy in real life to simplify what it means. Okay, so how many of you guys have either pet cats or pet dogs at home? It works better with dogs and less with cats because I personally am a owner of both. So I know that it just works amazingly well with dogs. Right, here's the example. Have you ever had your dog trained professionally? Right now, a simple training, it usually starts out with sit, stand, give me a handshake, all of those instructions to your dog, right? Now, your dog does this. Your dog is trained in a way where if it gives a handshake, it gets a tiny reward. It gets a biscuit. It gets a treat, right? So your intention here is to get the dog to give you a handshake. The dog's intention is to train itself in a way where if it gives a handshake, it gets a treat. It gets a nice thing to eat, right? Your happiness lies in getting the handshake. The dog's happiness lies in getting the biscuit. It's two different things. But at the end of the day, your purpose of getting a handshake is being solved, right? So that's the thing. With cats, I've seen that if you ask a cat for a handshake, they just meow and run away and they don't care absolutely. Or I don't know, just is it my cats or something like that? But that's the most common thing that I have seen, right? So there's a reward which is waiting at the end of learning. Now, if the dog does not give a handshake, and if you say, hey, give me a handshake, and you extend, you try, but it runs away, it is not getting the treat. It is missing a treat. It is intelligent enough to understand that it has to work towards something, be it a handshake, be it sit, stand, roll over, whatever it is, to get that treat while it is being trained, right? Exactly the same thing here in machine learning as well. When a machine learning algorithm learns, here we are trying to make sure that it is learning based on its own feedback. It will use its feedback in a way where either it has to work towards the rewards. In case, if it is learning right, it will be given a reward every position of the way. If it is going away from the solution, if it is doing something which does not add value to the solution, it is punished or it is penalized. Of course, guys, this is is just an example with machine learning. There is no penalization or there's no punishment with real pet dogs. It was just an analogy, so that's an important thing you have to note, right? In machine learning algorithm, the penalty or the reward is just mathematical numbers. It's +1, -1, all of these things which will eventually not hurt anything, right? So keep it at that. What happens here is exactly that. If it's going towards the goal, it is given a quick reward and it knows that it has to maximize the number of rewards it gets. If it is learning something which is not useful to the reward, it gets to the goal, it gets penalized and the rewards keep coming down. So the goal is to maximize the number of rewards, and it does this by looking at its previous steps, previous learnings, previous iterations. So that is how reinforcement learning works. It's a really fun way to work with machine learning. I absolutely love working with reinforcement learning. But again, in the most simplest way, it is okay to implement for a simple solution. But if you have very complex solutions where you have to use reinforcement learning, the implementation does become tough, guys. So that's one thing you should know about. Next, we're going to take a look at the KNN algorithm. KNN algorithm has a full form. It's an abbreviation. It stands for K nearest neighbor algorithm, right? Now, let me give you an example to explain what KNN algorithm means or how it works. Let's say you want to visit your friend's place, who stays nearby to you. Is there only one road ever that you can take to get to your friend's place? There's a good chance that you can take very inefficient routes to eventually get to his house. You can take one route, two route, another crossroad, whatever it is, right? If your friend stays in the next street, the most inefficient way to go to his house is probably fly to America and fly back and directly go to his house, right? That's a possibility. It is stupid, it is meaningless, I understand, but it is a probability still, right? You cannot say it's stupid in the case of machine learning because it does not understand that it is stupid. You have to teach it that, correct? So here what we're trying to do is we have certain data. As soon as we put new data there, we try to index it based upon whatever data points are nearby to it. And from then we map an association saying, okay, so it is closest to this data. It may be the same data or similar data as well, right? So again, that's a very important thing. KNN algorithms are a type of lazy learners. It means they do not really take a lot of time to execute. They do not want a lot of computing power to go on to learn and execute as well. But then to go on to practically check it out, first let me give you a theoretical example to make sure you understand these things properly, right? Now, what we're going to actually do is we're going to try to predict if the person is a male or a female based on their height and weight. Now, it's usually a common survey or a statistic saying that, male or guys weigh more and they are usually taller than the female population. Of course, it might not be the case in every single country or every single place, but the usual statistic is somewhere like this, right? Guys are taller and they are heavier in the build because that's how human bodies eventually work. In that particular case, can we predict if we just have height or weight of a person to see if they are male or female? Well, here are some of the things. I have heights of, these many people, 7 people. I have weights of 7 different people. And eventually I have the gender also, that if you have this height and weight, that person is a male. Now this is accurate data. This is the data that I've collected from 7 or 8 different people. Now if I have to teach my machine learning algorithm using KNN, saying can it predict if it's a male or a female, here's a graph. This graph is very simple. You remember seeing this chart, right? This chart with just its height and weight in the X and Y axis, we have just put the data out there. As you can see, we had 7 data points, right? 3 of the data points are female, as you can see in the pink rectangle, in the pink triangles. Then 4 male data we had based on the green circles you see on your screen right now. As soon as you look at it, you can sort of say that height and weight of the females are slightly less compared to the height and of course the weight of the male population in this example, right? Now, what I will do is there are 7 people here. I'm going to add another 8th person. I'm not going to tell if it's a male or a female. I just know that this person has a height of 190 centimeters and a weight of 100 kilos. If I put it and map it in the graph, the blue color rectangle you see right now is where that person will be put if the weight and height are matched with what everything else is put, right? Again, you as a person can look at this graph and say, okay, this new guy, this new person added here is very similar to the guy's weight and height, so that he might be a guy, right? If it was somewhere here, you would see that there's a good chance it's a girl. But for our machine learning algorithm to do it, we have the value of k. K is us saying that, use the 3 nearest neighbors to map a pathway to the new person who was added. If k is equal to 3, as you can see, these 3 green dots are the nearest neighbors to this particular rectangle, to the new data, right? So if k is equal to 3 and if all 3 are pointing to the same guy and all the 3 closest points are guys, your machine learning algorithm can say, hey, I have a 90%, 95% accuracy of saying that the new person you added is a guy. That is how it learns, right? Now let's put k equal to 5. If we put k equal to 5, we are finding out the 5 nearest neighbors, right? 4 of them are guys, 1 is a female here. Now, 4 of them are guys, but 1 is a female. Can it still say it's a female? No, right? Why? Because the majority of the neighbors are still male population, right? So that is how we accurately say, hey, the data we have here, the new person you added is a male, right? Now, if you've been seeing, I took k equal to 3, I took k equal to 5, both are odd numbers. Why did I only pick odd numbers? Well, you can use even numbers also, but the general way of working in the KNN algorithm is that if you pick the k value as an odd number, the number of neighbors that you have to track and index, you will use it as an odd number if you only have 2 classes in comparison, right? Here we only have 2 classes, male and female. That's it, right? We're only considering these 2 populations for this example. So since it is only 2 classes, it is vital that we go on to use this value, which is, an odd number, guys, right? The next thing we're going to check out is, again, as I told you, right, we're going to be checking the same Boston data housing data set. With linear regression, we got an error rate of somewhere around 5.4 or 5.5. But what is the error rate we're going to get if we use KNN algorithm, right? So let me quickly minimize the naive Bayes algorithm and let me open up KNN algorithm. Perfect. So again, this code is the exact same thing that we checked out while we were working out with linear regression. All we try to do is import the data set, import the data, import the libraries, print out the first 5. Next, we're going to be removing all the NaN values. As I told you, the data is already clean. Again, this was the exact same thing that we checked out. We're going to be splitting the data into 70-30. We checked out the exact piece of code. But the next thing is what we didn't check out is where we are trying to load the KNN model and use it, right? These 4 or 3 lines of code that you see is where we're actually going to use the KNN algorithm, right? So again, 3 lines of code. But if you see in the bracket here, I've put a parameter 3 for KNN regressor, right? This is me telling the machine learning algorithm, hey, use k equal to 3, right? As I showed you, as soon as I run this again, it's going to use the training data to learn. It's going to use the testing data to see if it has learned and all of that. 3 lines of code. Now, the next thing is, how do I know for sure that for the Boston housing data set that k equal to 3 is the most accurate value? K equal to 10 may give me better solutions, right? To make sure that I'm tuning all of these values and tweaking it to get my model to learn accurately, I'm going to do hyperparameter tuning. In hyperparameter tuning, what happens here is that I just print, since it's a small data set, I can just get the machine learning algorithm to work for multiple k values, which is exactly what I've done here. I have got the k value from 1 to 49 to see where the k value is, the error is the lowest, right? So k equal to 3 is what I said it will be the lowest. It's 7.01. But hey, check out k equal to 4. K equal to 4 has an even lower error rate. So what it's trying to tell me is, for this data set, for the Boston housing data set with this algorithm, you will get the most accurate output. You will get a lesser error rate if you use k equal to 4. I wouldn't know this until I did it, right? Hence the eventual purpose of mapping out all the k values out here, guys. And of course, the last step is for us to always print the mean squared error. In this case, the mean squared error is 7.014 for k equal to 3, correct? It was 5.5 for linear regression. For the exact same data set, it is 7.01 here. What does that mean? It means that our machine learning algorithm for that particular Boston housing data learned better in the case of linear regression rather than using KNN on that data set, right? Now, once you use multiple algorithms, this is the clarity that you get, which is a beautiful thing. now that we looked at a lot of things, it is high time we check it out all practically, right? So here are some of the machine learning algorithms which will add a ton of value to not only your career, but to your entire learning in the field of data science as well. Of course, all the algorithms that I'm about to discuss right now are the most popular ones out there. They are the trending ones for this particular year. People who are hiring, right? Companies who are hiring right now for machine learning jobs or data science jobs will ask in the job description saying, you may or may not know one or two algorithms, but all the algorithms that I'm about to discuss usually are in that list which says it's a compulsory requirement for you to understand. So when the recruiters themselves say that you require these many machine learning algorithms, the knowledge of it, well, it becomes vital that we cover it and teach it for you, right? So here are some of the algorithms that we're going to be discussing, guys. First of all, there are many different algorithms that you can look towards and work with. There's linear regression, logistic regression, again, regression, right? We already discussed this in supervised learning. You have the naive Bayes algorithm, you have the KNN algorithm, you have SVMs, support vector machines, you have random forests, and you have many different types of algorithms, which eventually has its own way, uses its own protocols, uses its own way of learning to eventually get to the result. But to simplify things down and not pick up all complex data sets, let us work one by one into the top machine learning algorithms that you have to learn, guys. We're gonna keep it very simple. We're gonna take a look at simple data sets. I'm gonna explain what each line of code means so that you completely understand, right? So first of all, we have linear regression here. Again, what is regression? To roll back on the same concept we checked out, we are trying to model an input variable by applying a function on it and eventually calling it an output, right? An output is a function of the independent input variable. So when I say input variable, when I say independent variable, it means the same thing. When I apply a function on the independent variable, it becomes a dependent variable on the outside, and that is your eventual y is equal to f of x. Y is the dependent variable, x becomes the independent variable, right? So there's another question which I'm usually asked a lot when I talk about linear regression, no matter where I go, is why is it so popular? Why do I have to know machine learning if I'm if I'm looking towards machine learning or if I'm looking towards data science as well? Well, the first thing that I can tell you, it is extremely popular because it will give you this cause-effect relationship which the real world requires a lot, right? Now, to simplify things, just let's look up at the sky right now if you're sitting outside or something, or maybe just look outside right now. How is the weather? If I ask you a question, what will you do? Right? You look up at the sky, you look at if there are clouds, if it's not cloudy and all of that. If there are black color clouds and you know that there are possibilities of rain, you might get a hailstorm, you might get snow and all of these things, right? If there are a good amount of clouds, right? Of course, weather changes rapidly. That's not the point here. The cause of the rain is what? Clouds. But what is the eventual effect? The effect is rain, right? Clouds cause rain. The effect is rain, the clouds is the cause, right? So that relationship, I just give you one example. You can think of hundreds and hundreds of examples like this. So this is eventually what is, used in today's world as well. That's why it is very popular. So what we are going to do is we're going to head to Google Colab. We're going to practically check out how we can implement a simple linear regression model by using a very popular data set. It is the Boston housing data set, right? Now, with this data set, what we're trying to do is, this consists of all the details of the houses in a locality in Boston. We're trying to see if our machine learning algorithm can predict the prices of the houses based on a multivariable assessment going on. It's called multivariate analysis. We're going to use multiple variables to see eventually to train a machine learning algorithm saying, hey, do you know why the prices are like this and how accurately can you detect these prices? That is the question we are going to get an answer for right now. Alright guys, we are now here at Google Colab. As I told you, free Jupyter Notebook hosted on the Google Cloud platform. You can just type in your Python code, hit the play button and you're done. You do not have to install a lot of these popular libraries that we're going to be working with, right? So again, the first step is to make sure we import all of these all the data sets that we're going to be using for algorithms. Of course, you can do it step by step, but to simplify everything, let me quickly go on to import all of these. There's a simple upload button here. With the upload button, all all I have to go on to do is just put in our data sets that we're going to be using. It will upload it one by one, and so that we don't have to do it every single time here, right? Again, let the circles finish. It means that it is uploading. All right, perfect. So all of my data is now uploaded. Let me zoom in on my screen to the max where you can see all the data. Right. Now, guys, with linear regression or any algorithm that we're going to use, the first step is what? We're going to be importing all the libraries that we have to use, right? Look on your screen. We are importing NumPy, we are importing Pandas, we are importing sklearn. NumPy and Pandas, I told you it's going to be very important for machine learning. We are using it right now. Scikit-learn or sklearn as it's called is a very important library for machine learning, right? So after importing the libraries, the next step is to import the data set so that, we have a workable data set that we can work with, right? So here, as you can see, pd.read_csv means pandas, where we're trying to read a CSV file, calling it the housing.csv, where all the data of the Boston housing data set is present. Let me go on to hit play, and it prints us a lot of the row and column values that are present, right? It's printing us 5. Let's see if we can print 10. Now, boss1.head, boss1 is of course a variable that we just created. .head is a method. If you do not pass any parameters to it, it's going to only output 5. Now in the bracket, if I put 10 and if I hit execute, it's going to give me the first 10 rows worth of data, right? Now there's so many different things here that are talking about the prices of the house, the crime rate that's present, right? What is the age of the house? So whenever you're trying to find the value of a house, what will you look at? How convenient it is from the nearest supermarkets? How old is the house? What's the tax ratio? How many floors does the house have? What is the area footage? You look at a lot of different things, right? So all of these are, each of these columns that you see here are eventually individual attributes that contribute to the price of a house as well, right? Even crime rate. Crime rate is a very important thing that you look at whenever you're buying a house. You'll see if the area or locality is shady or not. If it is shady, maybe the house is worth a lot less, correct? So that's an important thing here. So all we are trying to do at this point is to import the data set, import the libraries, print the first 10 for your reference, right? The next step after importing the data is to clean the data. Now, to clean the data in this particular data set, all of what we require is numbers, right? For example, look at the age column. If I ask you what your age is, will you say my age is orange, my age is apple? No, that's a nonsensical answer to a question, right? If I ask you your age, I am 100% certain that the answer you're supposed to give me is a number. Now, sometimes it so happens that in the data set, right, it will not be a number, it will be something else, something meaningless. You have to remove all of those, because if you do not, your machine learning algorithm is going to use those nonsensical data entities to learn everything wrong, as I mentioned, right? So the next step we're going to be using a function called as isNA. Is basically a function which says, is it a number? We're going to be basically using this method to see if we have any characters where we have to have numbers, right? NaN stands for not a number. We are trying to find values which are not numbers, in the sense they are characters, string and all of that, right? Thankfully, this is a data set which is already pre-processed and cleaned. So no matter which column you take a look at, all the values are 0. It is saying that, hey, everything here is a number. There is no character or there is no data which can throw your machine learning algorithm off. This is a good thing. The data is clean. It is already pre-processed. The next step of the way is a very simple one, where we actually try to split the data, as I mentioned, right? We're going to split it into training and testing. That is exactly what we are doing with these 3 or 4 lines of code. But here, I've mentioned that, I want to split it 70% of training, which means that 30% of the data is going to go for testing. How do you know? What do you see on your screen that says it has to be 70% for training, right? Look at this variable which I use for test train split methodology. It says test size is equal to 0.3. Now, when it says test size is equal to 0.3, I'm telling it, hey, what I want to use for testing later is 30% of the data. 0.3 means 30. So what is the remaining? If you have 30, it's 70, right? That becomes training. What if I put testing data as 20.2? If it is 0.2 or 20%, it means 80% of the data is being gone for training purposes, right? Now, if this is 0.5, it means 50% of the data for training, 50% of the data for testing, right? However, I have found the sweet spot to be somewhere around 70% for training for this data set. So let's check out what goes on. The next thing we're going to do is, since we are checking out linear regression, right? LR equal to linear regression and LR fit equal to X train and Y train. So what we're trying to do here is we're trying to model, get the model to understand the data that we have been checking out in terms of the training data. Now, if you were a person who thought you required 100 lines of code to train a machine learning algorithm, you have 3 important lines where the machine learning algorithm actually does the learning process, right? The model fitting, when you say fitting the model, it means to actually use the data to learn. And later you're going to be predicting it based on the testing values which I mentioned. As you can look at it, the parameter we send for predictions is also the testing data set rather than the training data set, right? If you just send the training data set again, what happens is that it already has seen the data. It will tell you 100% accuracy because it knows everything that it is seeing. If I give you a textbook and if I ask you, hey, write an examination based on this, where there are direct answers in the textbook, you do not have to spend a lot of time to learn it. It doesn't make sense. You can get 100 out of 100, right? But if I give you something else where you have to use your processing power to do it, that is exactly what we're trying to do. So with these 3 or 4 lines of code, our linear regression algorithm has learned everything it has to learn. Next, we have to see if it has learned or not. That is where we use error rates to actually go on to see if it has learned something. Now, there's an error rate called as MSE or mean square error, which is again a concept of its own, which we are going to use to predict if the machine learning algorithm has learned anything or not. So let's see what error we get here, right? So it will be somewhere around 5-ish. Okay, yeah. The error that we see for using linear regression is 5.54. Now, if you are wondering about what this number means, hold this number in your thought for a second, because we're going to use the same data set for another algorithm. That way you will understand what happens if you use the exact same data but 2 different machine learning algorithms, right? Which one learns more accurately? Again, we're going to be checking this data set out, in the next machine learning algorithm that we will discuss. Of course, not the exact next one. We're going to be checking out the third one. But now, moving to the second machine learning algorithm that we're going to be checking out is naive Bayes algorithm. Naive Bayes algorithm is a very, very popular algorithm that is, again, not just popular just because how it works, but rather the usefulness of naive Bayes as well, guys. Now, naive Bayes is an algorithm which works based on the Bayes theorem. Now, Bayes theorem is completely based upon the concepts of conditional probability, right? Conditional probability talks about the probability of one event occurring if another event has already occurred, right? P of event 1 occurring given that P of E2 has already occurred. That is Bayes theorem. So naive Bayes uses the concepts of conditional probability to work. It is again a type of supervised learning, just like how linear regression was. And here it is called naive because there is no codependency in between these attributes. So each attribute does not use itself or use the other one to get to the output. So since you don't have the dependency, it's more like a loner entity which sort of learns to, which sort of tends to not learn efficiently. But it's not efficiency, but it's the way it learns. That's why it's called as naive in real life, guys. Again, it's a funny way to name it, but yeah, it does work. And now, it is very, very popular for 2 important things: is social media marketing and product management. So whenever you have a supply chain analytics problem, or whenever you're trying to market something on social media, you want to analyze the impact of your marketing, right? Naive Bayes is very, very, very popular in those cases. Again, there's many types of naive Bayes algorithms that we're going to be checking out. There's the multinomial naive Bayes, there's Bernoulli's, there's Gaussian. We're going to pick up one of these to make sure that you understand naive Bayes in detail. Of course, to do that, we are going to be using the social network dataset, guys. So let's quickly get back to our Google Colab. Let me minimize linear regression and check out machine learning with naive Bayes algorithm, right? Perfect. Again, guys, what is the first step whenever we go on to work with anything? We import all the libraries, NumPy, Pandas, and scikit-learn, right? As soon as I click play, all of the libraries are done. The next thing is we're going to be importing the data set. In this data set, right? The salary data that we're going to be working with now, I have already pre-processed into training data and testing data separately myself. So I do not want the machine learning algorithm to again split it. Of course, I can manually define and get it to read and input two files. Salary data underscore train is the training data set. Salary data underscore test is the testing data set, right? So as soon as I go to hit play, let us check out what the data set itself is. So here there are a lot of different columns of how the data is working with, right? So whenever you're looking at salary data, we're trying to see what adds the most value to the salary, right? The working class of the person, the age of the person, education, marital status, occupation, relationship, the race, the sex, the capital gain that they're holding. Does that have an impact on having a high salary? So what value, what attribute here adds a lot of value to eventually having a high salary is what we're going to check out, right? So as you can see, we're trying to check out all the education that the person has and the eventual salary that the person might have. What is the salary range that they're getting? Which country are they native of? How many hours per week they work? So all these data we're going to be using to teach the machine learning algorithm, right? So to go on to use naive bias, the next thing we're going to be using is a concept called as a label encoder. Now, all of these values that you see, right? Relationship, not and family, husband, white, male, female, married, spouse. All of these are what type of data? Categorical type of data, right? But to make sure our machine will not understand husband, wife and all of that unless you teach it, right? To simplify all of these things, we're going to convert every single categorical variable we have into a numerical data, and just to do that, we're going to use something called as a label encoder. That's the entire process. All we're trying to do is convert categorical data into numerical data here. Once that is done, all of these get encoded into a numerical data format. It becomes variables of its own. Then we actually go on to assign it testing phases and training phases. That is literally what we're doing. 13th column is the last column for salary, right? So we're trying to add these encoded variables and assign them, saying, hey, what is your impact on the salary, right? As I told you, there's three types of naive bias classifiers that we're going to be, that we actually have, which you can use depending on your application. Here we're using Gaussian naive bias. Gaussian naive bias is mostly used for continuous data, right? Now the data is continuous here. Salary is a continuous thing which will change based on your experience, right? The first salary which you might have got after graduation is very different from the salary you have after 10 years of experience. It's a continuous graph that rises up and up. So if the data is continuous like this, you're going to be using Gaussian naive bias. But if your data is, let's say, binary data, if you want answers such as yes or no, true or false, up and down, all of these answers, which there are only two possibilities, binary outcomes, you're going to be using the Bernoulli's naive bias classifiers. And there's another one which is called as multinomial naive bias. Multinomial naive bias is extremely popular for text classification, speech recognition, all of these things. We're not doing any sort of speech recognition here, nor are we having a binary outcome, right? Hence, the reason we're going to be using Gaussian naive bias. Now, as you can see, as soon as I ran one line of code, model fitting is actually done. The next thing all I have to do is predict by passing it the testing data to see if it has learned something or not. And since that is done in 2 lines of code, the next thing I'm going to go on to do is print a confusion matrix. Guys, a confusion matrix is a very important concept which we already checked out in statistics, right? True positive, true negative, false positive. All of these values, as you can see on your screen, the most concerning numbers will be the true positive values and the false negative values. These has to be the highest. Because at the end of the day, if these are the highest, it means your model has learned really well. We do not want false positives, or we do not want false negatives, because these are sort of the values which your machine predicted wrong based on all the values out there, right? Now, if you do not understand confusion matrix, again, I have an accuracy metric here at the bottom which says, hey, I have an 80% accuracy rate of detecting things correctly and making sure it matches up to what we predicted at the start as well. So for every 100 elements of data it sees, it can predict 79 or 80 of it perfectly. That is what our machine learning algorithm is trying to say to us, guys. Right, that was naive bias. So right, guys, next up we're going to check out support vector machines. Support vector machines are very complex entities in the world of machine learning, because here the way that they learn itself is very, very different. They use multiple unknown parameters, and they use a technique which is called as a black box techniques, because there are so many unknown parameters, so many things going on in the background that it uses to learn, right? But then there are certain basic things that it has to work with is linear data and non-linear data. So in the case of non-linear data, since it is very difficult to train, it actually separates this data by making use of something called as kernel tricks. And all of these parameters which eventually come after kernel tricking is usually tested and tuned by making use of kernel functions. Now, there are multiple kernels that we can use as the polynomial kernel and the RBF kernel, the radius basis function kernel. Each kernel has its own way of working, right? So what happens with the polynomial kernel is that with the polynomial kernel, the data gets transformed into a higher dimension and eventually it works into its nonlinear classes. But with the case of radial basis function, the RBF kernel, here we have a parameter called as gamma, and we continuously tune this parameter rather than changing any dimensions, which eventually gets us to our results. That is how we're going to be using SVM, guys. So until we keep scaling these gamma values, RBF will go on to give us different outputs, and we find the best one and we usually hold it there, right? Now, coming to the advantages of SVMs, the most important thing is that it is very, very flexible to work with a variety of data, be it unstructured data, structured data, semi-structured data, whatever it is, right? Unstructured data is images, music, videos, and all of that. Structured data is everything that we checked out, right? A nice CSV file with rows and columns worth of data. Semi-structured data, there's again multiple types of data based on the usage as well. So one advantage with SVMs you have to understand is that overfitting is not present, or it's very less here compared to all of the other models out there. So overfitting is a situation where your machine learning algorithm is learning so deeply with so much focus that it starts picking up noise in the data rather than useful stuff. So using its noise, it will not learn anything at the end of the day which is accurate, right? The data is going to be completely inaccurate because it hunted so deep into the data, it found noise rather than useful information. That is overfitting. In the case of SVMs, overfitting is less. But to talk about the disadvantage of SVM as well, one thing is that the training time will be a lot more if your data is huge. All the data sets we've been using now are very tiny figments of data, so it's working beautifully well. There are some cases where your machine learning algorithm can train for hours together, if not days together as well, if you use SVMs, right? The reason why SVMs are popular today is because they have a huge impact in the world of healthcare and in the case of banking sectors as well, guys. So it's a very popular thing. Let's actually check it out practically now. Let me just minimize KNN. Perfect. Let me open up SVM. And what's the first step in SVM or any algorithm? I can zoom in a little more. Perfect. Is to import all the libraries, importing NumPy, importing Pandas. Now here I have another library called Matplotlib. Matplotlib is used for data visualization to create beautiful looking graphs, right? Done. The next thing is to import the data set. Here we're going to be using the social network advertisement data set. So what we're trying to do is, if you advertise something, right? If you're advertising a pen or a pencil, and you know the salary of the people who may or may not buy the product, right? What is the probability that a person will buy the product if their salary is somewhere around that, right? So using salary to see if a person of this salary can afford your product or not. Now, if there's a very expensive car like a Ferrari or a Rolls Royce, there's a good chance the common man cannot be able to afford it, right? So advertising that to a common man might be considered as a waste of money as well. So to check if the person of this salary band can afford a product like that is what we're going to try it out. But with this data set, as you can see, we have a user ID, we have the gender and age, estimated salary and purchase. Now, what are we concerned about? We're using the salary to see if a person purchased or not. So we do not require the age. We do not care about if a male bought it, female bought it, or whatever it is. So we can drop all of these columns, user ID, gender, age. I do not want. I just want salary and purchase, right? So I'm going to filter all of these columns out with just 2 lines of data. The next thing, again, we're going to be splitting the data. This time not 70-30, but 75-25. 75% goes for training, 25% goes for testing, right? As soon as I click this, that is exactly what I did. Now the data is split up. Next, we're going to be using a scalar called as a standard scalar for normal distribution. The normal distribution is a bell curve, which will add meaning to the data so that we can plot it and derive some meaning out of it, right? So by using a standard scalar, all we're trying to do is we're trying to use the training data, map it and verify it against the testing data by using normal distribution. Again, distributions coefficients are a very important part of statistics, the concept which governs the world of data science, guys, right? Next, as I told you, there's polynomial kernel and there's RBF kernel. In this particular case, we're going to be making use of the RBF kernel, 3 lines of code. Your model, the SVM has learnt it completely, and at the end of it, if you're trying to print the confusion matrix, again, confusion matrix, we discussed this in the last module: true positive, true negative, false positive, and false negative, right? So again, I didn't see it in order. There's an order of which the values goes on. You guys are supposed to tell me the order because we covered it in detail. The values I am concerned with are 64 and 29, that they're high. That's perfect. We have 4 and 3, which the model got incorrect, or it predicted in the wrong way, which is absolutely okay. Again, here is where statistics come into the picture, right? You remember we calculated precision, recall, F1 score and all of that. Guess what? We calculate it here again. Of course, we're not doing it manually anymore. We have classification report which will give us all the details. So we have the precision value if the person bought the product, the recall value if the person bought the product or not. We have the precision, recall, and F1 score if the person actually bought the value. 0 means the person didn't buy it. 1 means our prediction based on if the person actually bought it, right? Pretty simple when you look at it, but it's a beautiful concept of how support vector machines work. Right, guys. Next up, coming to the 5th algorithm, is the random forest algorithm. Random forest. When you say forest, what is the first thing that comes into your mind? It's a group of trees. It's a collection of trees, right? Here also it's a collection of trees, but not just trees. It is decision trees. Hence, once you have multiple decision trees, you just call it a forest. In this case, it's called as a random forest algorithm as well, right? One thing you have to know about these decision trees is that they have very high variance and very low bias. This is the exact opposite of what we need. We need low variance in our data and very high bias of learning, correct? To make sure that we solve this problem, we just group all of these trees and create a forest. That is how we solve this problem of decision trees having very high variance and very low bias. So what we do here is we take in data just like a real tree. A tree is going to have branches, it's going to have multiple branches, it's going to have leaves, right? So one important node will be our input. From there, we create all our branches, and every single leaf at the end of the day, or the end nodes, are called as leaves. They will be the output in this case, guys. That's why the name random forest algorithm. So how do you go on to pick data when you're working with random forests, right? If you are considering 2 samples here that we've represented by 2 colors, the red and the blue color that you can see, we have multiple columns, right? In the concept that we have called bagging, we compulsorily pick data from all the columns out there to train the machine learning algorithm and to teach it. As you can see, all the pink ones, everything is picked, blue ones, all the columns are picked. But in the case of random forest, what happens is that we do not pick up all the columns. We just randomly pick up, a couple of columns to actually go on to build decision trees and eventually get our, model to learn, right? So that is exactly what we are going to check out here. The advantage of random forest algorithm is that it works amazingly well for classification problems and regression problems, which we already checked out. But if your data is not clean, and if you're a person who doesn't like to clean data, again, it's a very hectic task. Guess what? With random forest algorithm, sometimes if your data has missing values, random forest algorithm has the capability to automate it and fill it with zeros, ones, or whatever it is that it thinks will not hurt for learning. So it can automate itself, learn, and fill in data wherever it is missing automatically too. But then one disadvantage of random forest here is that it will require a lot of computation power if you are looking to build very, very, very complex trees and forests, guys. So that's an important thing that you should know about, right? So let's quickly check it out practically now. So with random forest, again, the first step is pretty simple. Import the libraries, import the data set, print the first 5 elements of the data set, right? Now, let me actually go on to print 10 instead of the first 5 because I want to show you something here. Right, now that you see the data, I have 3 tabs here, 3 columns: position, level, and salary, which I think is self-explanatory, right? A junior consultant is a level 2 employee who gets an average salary somewhere around 50,000 rupees. A CEO is a person who's a level 10 employee, the maximum level you can obtain, and he gets a salary of somewhere around 10 lakhs per annum, per month, whatever basis, right? We're not concerned about the duration of this particular salary. But look at the growth with the level. A person who's a business analyst is a level 1, junior consultant level 2, senior consultant level 3, manager 4, country manager 5, region manager 6, senior partner 8, 9, 10. right? So what I will try to predict is the average salary of a person who has the level of somewhere around 6 or 6.5 based on all these data. Again, to do this, I only require two columns, level and salary. I do not require position, right? So I'm just going to remove the position column, use only the level and the salary here. Here, I'm going to be using 10 different trees. As I told you, a random forest is based upon multiple trees. Here, I'm going to be using 10 different trees. N estimator is equal to 10 means that I want 10 trees to create one forest, right? As soon as I go on to click this, the model has actually learned the creation of the forest is done. So the next thing we're going to do is predict the salary of a person who has level greater than 6.5. So instead of just telling you that in a verbal way or to show it to you in a number, I want to show it to you in a graph. Now here is a very beautiful visualization, guys. What is the, as you can see, the salary, I have it on the y-axis, the position, I have it on the x-axis. The position we're trying to find is 6.5. So it might be somewhere here, right? Now, if I go to the left of that point, the salary is somewhere around 0.2. Hey, the salary we were checking out was in the thousands. What is this 0.2? Look at the legend on the top. It says 1E6. 1E6 literally means multiply that number, whatever you get on your salary, by 10 lakhs. 0.2 into 10 lakhs is what? 2 lakhs? 2 lakhs for a person who has an average salary of 6.5. Let's take a look. See, for a person who has a salary between 6 and 7, the average salary can be considered as 2 lakhs as well. This is what our machine learning algorithm learned and predicted for us. So when you have a result in a graph like this, which is very nice to look at, it adds a lot of value to your learning, guys. So this was the top 5 machine learning algorithms that you have to learn.
In this part, we are going to do this diabetic prediction on Pima Indian diabetes dataset using Naive Bayes. But before start with this, we will have a look at about the database. Right? So let's go to this particular link. We will get this dataset from Google. This is open source and anyone can use this. So if you click over here, it will redirect you to Pima Indian diabetes dataset. So let's have a look at what are the things we have in the dataset before do the prediction using Naive Bayes. So here, if you can look at, you will get the dataset, that Pima Indian dataset. If you want to download it, you just click on to download. It will automatically start downloading your dataset. And if you want to see the context of the dataset is originally from National Institute of Diabetes and Digestive and Kidney Disease. The objective of the dataset to diagnostic predict whether or not a patient has diabetes based on certain diagnostics measurements included in the dataset. Several constraints were placed on the selection of the instances from the larger diabetes. In particular, all the patients here are females at least 21 years old of Pima Indian heritage. Right? This is the context of the dataset. I mean, on the basis of what are the things that we can predict that particular person has dataset or not. And also, this Pima Indian dataset is basically has total 9 columns. So first we will have a look at the dataset, and from there we will see what are the predictors we have and what are the dependent and independent variables we have, right? So whenever we are going to use any classification technique, as we talk, that the dataset should be categorical dataset, right? And let's have a look at what are the columns we have. So first we have pregnancies, so it will denote that number of times the patient got pregnant. Then glucose, the plasma glucose concentration, that's obvious. Then blood pressure, the diabetic blood pressure. Then we will see about skin thickness, the tricep skin fold thickness, that actually depends on the diabetes as well. Then insulin, and then we will talk about body mass index, then diabetes pedigree function, and then we will have a look at age. Then whatever the column we have talked about still so far, according to that, we will have an outcome column. This outcome column is nothing but it's going to provide us the information based on these particular columns and those attributes, this person is diabetic or not. So you can see till age, right? If we look at this till age, this is the independent columns you have, but outcome columns is dependent upon all these columns, right? Because this outcome is nothing but that person has diabetic or not, based on these 8 columns. So this is the thing you have to understand about the data set. Now we will look at the raw data set, and then we will start doing the data analysis, data pre-processing, and lastly we will do the classification model using naive Bayes. Now, as we have talked about the data set, now we will start working with few libraries in Python. So these libraries are Pandas, NumPy, Matplotlib, and Seaborn for data pre-processing and data visualization. And for machine learning, like using naive Bayes and machine learning libraries, we are going to use scikit-learn. So here you can see I am going to import Pandas as PD and then import NumPy as NP. Now, if you see for the data visualization, we have used matplotlib.pyplot as PLT and import Seaborn as SNS. Now, I will show you how to basically start with importing your data set and then just to read your data set using Pandas. And then we will have a look at the raw data set as well. So, as you can see over here, there is a square symbol over here as we are going to use Google Colab. So in this case, you can see over here, if you just click over here that upload a session storage, right? If you just click over here, wherever your data is got downloaded, suppose for my case, Pima Indian Diabetes, and then enter, right? So I have two data sets with me. That is, one is Pima Indian Diabetes and one is diabetes.csv. Both are same. So you can see this, your data set is already here in the storage session. Now, if you want to see the path, if you just click over here, you will get the option of copy path, right? Now, just to read the data set, that is read CSV, using Pandas, we just need to write data equals to pd.readcsv, and in the quotation, you have to provide the what? You have to provide the dataset path. Now, if you just click over here, you just execute your code, you can see it's already executed. Now, if I just look at the code, what actually it has, so here, yes, let me make it a little big. Just you can see what is the raw data set we have. So you can see we have pregnancy. That particular person is pregnant for 6 times. Glucose is 148. Blood pressure is 72. Skin thickness is 35. Insulin is 0. That cannot be possible. We will talk about that. BMI equals to 33.6. Diabetes pedigree function is 0.627. Age equals to 50. Outcome 1. That means this particular person is nothing but diabetic. If we look at the next person pregnant for 1 time, glucose is 85, blood pressure is 66, skin thickness is 29, insulin is again 0. That cannot be possible. We will need to handle those problems. Then BMI is 26.6, diabetes predictive function 0.351, age is 31, outcome is 0. This particular person is not diabetic. Right? So whenever we have data set, this is the class, right? When your person comes under 1, this is diabetic. When your person comes under 0, this is non-diabetic. So basically you have 2 classes. One is diabetic class, one is non-diabetic class. So whenever you have in your data set, you have class and you have a outcome column, not particularly outcome, the column name is no. If you have a column, dependent column, which is dependent on the like other independent columns you have, that time your data set is nothing but is a categorical data set. But in the case maybe you have a independent data, right? You have independent data and columns, and you have dependent columns as well, but the dependent columns is in nature is a continuous value column. So that case you have to go for regression. So these are the basic things you have to understand when you are to start working with the data set, right? So this is your data set description for the raw data set. Now, as we have, you can see we have actually read the .read CSV function, and this CSV function is nothing but it reads the comma separate value data set, right? Now, if you want to just look at the first 10 rows of your data, how to do that? You just need to write data.head. So basically, if I just clear this part, if I just write data.head, it's going to provide me the first 5 rows, right? In default, it's like actually returns first 5 rows of your data set. So here you can see you got 0, 1, 2, 3, 4, right? So now if you just write 10 over here, you will get the first 10 rows of your data set from 0 to 9. Can you see you got 029? From the first itself you will get. Now if you want to see the last part of your data set, that time you have to use a function called .tail function. In default it returns the last 5 rows of your data set. You can see 761, 766 and so on. And again, if you just do the same thing the way we did with head, so data.tail, that is tail 10, you can see 767, 766 till 758. Right? So this is how you can visualize your data, the first 10 rows or the last 10 rows. I mean, it's up to you how much you want to see. But in default, if you don't put any number in the parenthesis, then you will get 5. Right? Now, if you just look at the shape of your data, how many columns you have, how many rows you have. In this case, you have to write data.shape. It's going to return you first how many columns, how many rows you have. So in this case, you can see total you have 768 rows and 9 columns. Right? Now, it's already head part is done. Now we are going to start with missing value detection. If you have any missing value, that time you have to treat them. Otherwise, if you're going to make a model on this data set without do the data pre-processing, your model will not give you a good prediction, not even a good accuracy as well. So in this case, first we are going to look at the blank values, the NaN values, the null values, and if you have some continuous columns, they might have 0 that can be counted as a missing value. Now to check the missing value for the very first time, what you need to do, you need to call the function called .info function. This function is going to return you what are the null values you have in your data set plus what is the type of your columns. So pregnancy is glucose. For all the columns you don't have any null values, but you don't know if there is any continuous value which is consist of 0 or not, because it's going to check this info. Basically it's going to check if you have any data like that is right as NaN or the blank. But if you have something in that place, it's not going to count that. So in this case, the record shows for all the columns in 768 that indicates there are no null values. Now, if you look at the data.description, so there is one more way to check the null values. You can write data.isNA. Right? So if you just call .isNA function, it's going to return you if you have any null value or not. So if you want to just see the summary of this, then you just need to write .NE. If you look over here, if you can see, you got pregnancy, glucose, blood pressure, skin thickness, insulin, BMI for all the columns. Right? For all the columns you get false. Why? Because there is no null value for this particular data set and for these particular columns. So in this case, you can see that data.isNA.NE is going to check for each and every column and each and every rows you have in your data set. Is there any null value is present or not? So if it's not, then it's going to return you false. If it's yes, it's going to return you true. It's basically the Boolean value. Now, if you just look at the data.describe, this describe, it's nothing but to help you understand the data description. So in this case, this pregnancy is glucose. If you look over here, what are the rows you, what are the rows you got? You got count, mean, standard deviation, minimum value you have in your data set, then 25% IQ, that interquartile range, then 50%, then 75%, and then lastly we have max, right? So if you look over here, for glucose, the minimum value is 0. It cannot be possible a person has 0 glucose in their body. Then there is one more, that is blood pressure, there is 0 is present. Then skin thickness, that is 0 is present. That cannot be possible. Then insulin, again, that 0.00 we have seen that is present. That's not possible. A person without body mass index, that is also not possible. So these are the things, this is nothing but these are the columns have basically the null values, right? So these are the column have the null values in the term of 0. So how to use this, how to remove this missing values? So from the above description of the data, we can see columns pregnancy, glucose, blood pressure, skin thickness, insulin, BMI have minimum values of 0. Right? So it makes no sense to 0 pregnancy. It makes sense to 0 pregnancies, but it did not make sense for 0 glucose, blood pressure, skin thickness. Right? So we can understand that these are the columns have with missing values. Now, how to actually handle these missing values? So here we are going to replace 0 with np.nan. For that, if we go for using .isna.any function or .info function, we can understand actually how much we have with the null values. So if you have a big number in your data set with the non values and missing values, basically that time that data set is not perfect to work for. So in this case, we are going to use dot replace function, replacing 0 with np.nan. So for that, we have imported from numpy import nan. So you have written data of glucose, the data you have, the data of glucose, the particular column equals to data of glucose dot replace 0 comma np dot nan. So for all the column we have that missing value, we are going to do the same thing. Now if we just write data dot head, you can see for glucose, there is no nan values, but for insulin there is 3 back-to-back nan values. For skin thickness also nan values are there. So the first 5 rows of your data. Now if I just write data dot head dot is null, right? So it's just saying, but it's going to check is there any null value you have or not. Now I am just going to remove this head part because I don't want to see for particularly for first 5 rows. I want to see for the whole data set. Okay, I will get an error dot. Here you can say after replacing zeros with nan, so in that case data dot is null dot is any. So now you can see your glucose has missing values, your blood pressure, skin thickness, insulin, BMI, right? These are the columns with the nan values. Now if you just want to see what are the numbers, like dot is null dot any is going to check is there any column and any rows is there with the nan values. And here we are going to check data dot is null dot sum. What is the total number of records you have in your data set with the null values? For glucose, you have 5 records. For blood pressure, you have 34. For skin thickness, you have 227 records without any number or without any kind of information. For insulin has the highest, that's 374. So this is how you can understand your data. These parts we are doing basically to have a good idea about what data set we are going to use. Right now, if you just need to, if you find out the missing values, now you have to use some techniques to remove the missing values. But how to do that? So missing values, it's like can be treated with the median, because median is the most least affected by the outliers. Now you will ask me, what are the outliers? Maybe the error in the data set. You can for time being you can understand outlier is nothing but your error in the data set. If you just write data.median for all the columns, it's going to give you the median, right? For pregnancy, glucose, blood pressure. Now we are going to use one particular function which is known as .fillNA. So .fillNA is going to fill the NaN data you have wherever with the median of that particular column, right? So for that we have written data.fillNA and data.median, then int is equals to true. Now if you want to see the data.isNull.sum, after replacing your NaN values with median, you can see it becomes 0 again. So this is how you can treat your missing values. Now if I just look at the outlier detection, outlier is nothing but your error in the data set, right? So outlier detection, for the outlier detection, the best way to do the box plot. So box plot is help you to detect the outlier in your data set. In this case, we are going to write plt.figure and then fix size. The figure size we want that is 20,15. Then subplots. For one particular frame, you will get different box plot. That's why we use subplot. So for box plot, pregnancy, glucose, blood pressure, we are going to use cbond.boxplot, right? Skin thickness, everything, right? Let me just execute this. Yes. So if you look over here, if you get these dots are nothing but the outlier you have in your data set. So for pregnancy, you have outliers. For glucose, you don't have any outliers. For blood pressure, yes, you do have. For skin thickness, for all the cases, you have outliers. In the case of insulin as well, you have outliers. Now you want to handle these outliers. But how to handle these outliers? In order to handle these outliers, you just need to use or clip your data with a lower range and with a higher range. So clipping your data is nothing but to help you to sort out the outlier problem. So apart like from the above itself, you can see from apart from glucose, all the other attributes shows the presence of outliers. So this is with the lower level and the upper level of the outliers will be replaced by 5th and the 95 percentiles respectively. So here we are going to clip our data with the first 5% and the 95% percentile. So in this case, in order to do that, how to do that? We have written dot clip lower equals to data pregnancies and dot quantile is the lower part, you have written 0.05. For the upper data, you have given data pregnancy dot quantile 0.95. So this is how we actually handle our outlier. This is a very basic part. Now if you just plot the same plot whatever we have done few minutes before, you can see for pregnancies, glucose, blood pressure, skin thickness, these are the things is actually without outliers. There is no dots in the data visualization part. So you can see or you can say it fact that yes, we are actually able to come out from the outlier analysis problem, right? So this is how we have done this. And for skin thickness, age, insulin. But for the case of insulin, there is outlier is still there. In this case, how to do that? In this case, again, we are going to do this change the, if you can look over here, we have changed the quantile from 0.5 to this is 0.21, right? And the upper quantile is 0.80. So this is something we need to tweak our quantile range to get out of the outliers, right? So this is how we can actually go for using box plot to understand, do we have outliers in our data set? Because if your data set have missing values and outliers both, it will not work properly whenever you are going to make a model, right? Now, if you just look at the data visualization part, you can go for checking your data. So in this place, you can see for the data visualization, I am going to use SNS.count plot. This plot is nothing but automatically count the same data, like maybe we have two class over here, class 0 and class 1 for diabetic, class 0 for non-diabetic. In this case, it automatically count the 0 and 1, it will make the two particular class, that is 0 and 1. So 0 is non-diabetic and 1 is diabetic. From the data set itself, you can see we have a patient in our data set with non-diabetic features the most, right? Now this is how we can actually understand our data set. Now what we are going to do, we are going to make the model. But how to make the model? In order to make the models, if you just want to look at the how many columns and what are the columns you have in your data, you can just write data.columns. You will get all the columns you have in your data set. Now to use the scikit-learn, we are going to use train, test, split. So why? So you can know that for the machine learning purpose itself, we need to divide our data set for training and testing. But why? Because training parts, whenever we are going to train our data, we are going to give the data set of trained data set. And the test data set will, like the machine will have no idea about the test data sets. So basically we will understand how our machine is working after getting trained with the data set. Whenever we are going to give a new data, how it's going to give us the predictions. Right? So for X, we have dropped the outcome. So for X, we have total 8 columns, which are the independent columns, and Y will have the outcome. So we are going to divide our data set into two particular part for not two particular, for four particular part. For one is for training training part for X and training part for Y, and then for test as well. Yes, for one for X training, one for Y training, one for X test, one for Y test. Now we are going to call a function called train test split, and we are going to provide X and Y. X will have all the independent columns and Y will have the dependent column. Right? And the test size will be 0.2. This is nothing but your 80% data will go for training your model and 20% for checking your model, how it's going to work. Now we have written random state equals to 0. So now if you just write random state equals to 40, it will haphazardly will start taking your data for training and testing. There is no proper way that you can say, hey, this random state, if I just don't write random state, so in that case, you will get the first 80% of your data for training and the last 20% of your data for the testing, right? So now if you just import the naive from scikit-learn itself, you just need to write from sklearn.naive import Gaussian NB. So now if you just create a Gaussian classifier, there's nothing but naive classifier, you give a variable model and you have called Gaussian NB. Now we are going to use model.fit. So model.fit basically we are going to use for train our model. So .fit is used for training our model. So xtrain comma ytrain, right? We are going to give that xtrain and ytrain. So in the case of xtrain, we have passed all the values for eight particular columns, and for ytrain we are going to pass the outcome, right? So if I just execute that, after that, let me do that. I don't even execute this part, right? Okay, so here what we are going to do, if you can see that Gaussian NB is nothing but your model got trained. Now for the prediction, what we are going to do, we are going to write model.predict and then we are going to provide our test data. Now this time we are going to predict the class, right? The class we have that 0 and 1 based on all the independent columns we have. So we have passed that model.predict then xtest, right? Okay, now if you just print predict value and if you just see the predicted value, what the prediction is, you can see all the classes you got depending upon the independent columns you have, right? So now if you just import metrics to understand what's your accuracy, particularly for naive Bayes, you can see your accuracy is 0.75. So it's pretty cool. It's not bad, but you can, using some more data analysis techniques and data pre-processing techniques, you still can improve your accuracy.
Now we'll head on to the demo part where we'll be implementing the decision tree classifier on top of the iris dataset. So before we actually build the model, let's actually go ahead and import the required libraries and the required dataset. So to work with this data frame, we would require a library called as pandas. So I will start off by importing the library. I will write down import pandas as PD. I'll hit on run. So we have successfully imported this library called as pandas. And this pandas library is one of the most widely used libraries in Python, and it helps us with data wrangling and data manipulation. And this also helps us in working with data frames. So if you don't exactly know what a data frame is, you can just consider that it is analogous to a table. So if you have worked with SQL or Excel, you would understand what a table is. So in simple terms, a table is a two-dimensional entity which has rows and columns. And if you'd want to work with tables in Python, you would have to convert those tables into a data frame. And for that purpose, we would need this library called as pandas. So we have successfully imported this library. Now, with the help of this library, we can read CSV files. So what is a CSV file? CSV stands for comma separated values. So whatever Excel files you have, either they have the extension of .xl or .csv. So it is again essentially your 2D entity with rows and columns, which has the extension of .csv. And to read a CSV file, we would need the pandas library. So I will write down pd.read_csv, and inside this I will give in the name of the file. And since I would want to work with the iris data frame, I have this file called as iris.csv, and I will go ahead and store it in this object called as iris. So I have also loaded the required library. Now I will go ahead and have a glance at the first few records of this data frame. And by default, if I would want to have a glance at the first 5 records of any data frame, I can use the head method. And here I will write down iris.head. And as you see, these are the columns which I have. I have sepal length, sepal width, petal length, petal width, and species. So I have 5 columns in total. And this also has 150 records. So this iris data frame is one of the most commonly used data sets in machine learning. And over here, we have 3 different species of the iris flower. We will have the Setosa species, versicolor species, and the virginica species. And as you guys know, when it comes to decision trees, it is used for both classification and regression. And in this demo, we'll be performing classification. And for classification, it is important for a dependent variable to be categorical in nature. And that is why here the species column would be our dependent variable and the other columns would be our independent variables. So what we'll do is, before we actually start off by implementing the model, we will do a bit of exploratory data analysis where we'll find some interesting observation from this data frame. So let's say if I would want to look at the distribution of this sepal length column, and if I would want to make a simple histogram for it. So for that purpose, I would need a library called as matplotlib, which is used for visualization. And this matplotlib library has a submodule called as pyplot, which I'll be using to create different geometries. So here I'll write down the command from matplotlib import pyplot as plt. I have loaded the required library. Here I've given the alias plt for pyplot. Then I'll just go ahead and make the plot. So first I'll assign the figure size. So there is this method called as figure. So I'll have plt.figure. Inside this I'll have the parameter fig size, with the help of which I can just set the dimensions of the figure which I'd want to make. And let's say I would want to set the dimensions to be equal to 5,7. Now, to make the histogram, the command is pretty simple. So all I have to do is write down plt.hist. And inside this, I will give in, first I'll start off by giving the name of the data frame. Inside this, I'll give in the name of the column. So here, the name of the column will be sepal length. So I'm creating a histogram with the help of this plt.hist method. Now I'll hit on run. So this is what we have. Now, if I want to make it more aesthetically pleasing, so first I do not want this metadata. So if I do not want this metadata, I'll just write down plt.show and I hit on run. You see that all of that metadata has been removed. Now I would want to add a title and a X label to this plot. So I'll have this method called as plt.title, and inside that I'll just write down distribution of sepal length. Then I would want to set the X label. So here I will write down plt.xlabel. And here I will set the X label as sepal.length. So now as you see, I have removed the metadata, I have added a title to this plot, and I have also assigned an X label to this plot. So let's try to get some inferences from this plot over here. So when it comes to sepal length, so as you see, we've got these 3 peaks over here. So it would seem that there are around 23 or 22 records whose sepal length would be somewhere between 4.5 to 5. Then again, we have more than 25 records where the sepal length is between 5.5 to be 5.8 or 5.9. Again, the similar case, we have around 25 odd records where the sepal length would be between 6.2 to 6.5. Now, if you go above this, you would see that as the sepal length increases, the number of records decrease. So you can say that On an average, the sepal length of all of these flowers would lie in the range of maybe 5 to around 6.5, and there are very few species of setosa flower, or there are very few records of iris flower where the sepal length is actually greater than 7. So if you go beyond 7 over here, you would see that there are very few records whose sepal length is actually greater than 7. So this is quite an interesting observation, isn't it? So this was with respect to sepal length. Now similarly, if I would want to understand the distribution of petal length, I can just go ahead and draw another histogram over here. So I'll follow the similar procedure. What I'll do is I will write down plt.figure, and inside this I have the parameter called as fig size. So I'll set down fig size over here, and I will set the figure size to be equal to 5,7. Then I will just go ahead and make a histogram. So here it will be plt.hist, and inside this I would have to make a histogram for petal length. So it'll be iris, and inside this I'll give in the name of the column, which will be petal.length. And then I'll set a different color to the bins this time. So I'll set the color of the bins to be equal to green. So if I just give in G over here, that would mean that this is of green color. Then I will write down plt.show to get the result without the metadata. And this is what we have. Now after this, again, as we did with respect to the sepal length, if I would actually want to add the X label and the title, what I'd have to do over here is I need to add two more methods. So I'll just write down plt.title, and I will set the title as distribution of, this is petal length. Then I'll also set the X label over here. So this will be plt.x label, and here I will set the X label as petal.length. And this is the final result. So we have the title, distribution of petal length, and this is the X-axis label, which is petal length. And if you look at these particular bins over here, you would see that we have very contrasting bins over here. So there are more than 35 records where the petal length is between 1 to 2. So we have this particular peak. It's not even 1 to 2, it's only between 1 to 1.5. So more than 35 records where the petal length is between 1 to 1.5. Then again, you have a peak over here. So there would be around, let's say 27 or 28 records where the petal length would be somewhere between 4.5 to 5. So here you have one peak, here you have another peak. So this is quite interesting when it comes to the petal length. So this was some basic exploratory data analysis. Now we will go ahead and build our decision tree classifier on top of this data frame. And as I have told you, species column would be our dependent variable. And what we'll be doing is we will be using the sepal length column as our independent variable. So for this purpose, I would have to extract the target and the independent variable. So let me go ahead and do that. So let me just add a comment. Machine learning starts now. And I will start off by extracting the target and the independent variable. So target, I'll go ahead and store in y. So it'll be y is equal to iris. And I would have to extract, what do I have to extract? I'd have to extract the species column because that would be our dependent variable. So species column is our dependent variable and that I'm storing in this variable called as x. Similarly, I would have to go ahead and extract the sepal length column. So sepal dot length, this I'm extracting. Let me keep it in small case. So this I'm extracting and putting it in this variable called as x. So we have these two variables over here ready. And after this, now once I have my dependent variable and the independent variable, the norm is to divide the data into training and testing sets. And why is that important? So let me give you guys a very simple analogy. So let's say you are appearing for an exam and someone, maybe your friend, comes up to you and tells you that the paper has been leaked. And let's say if there are 5 questions in the exam and all of those 5 questions have been leaked and your friend gives you that question paper. Now, if you actually go ahead and learn only those 5 questions, and if you go to the exam the next day, and if exactly those 5 questions come up, well, then you're in luck and you'll get 5 out of 5 and your accuracy is 100%. But what if maybe your friend got a fake question paper and none of those questions actually come up in the exam? So what happens is you prepared only 5 questions, but none of those 5 questions come up in the test. So what happens over here is you will get 0 out of 5 and your accuracy is 0. So that is why training is especially important before you actually go for the test. So you have to implement the same sort of philosophy with respect to machine learning as well. First, you'd have to train your model. Now, once you train your model, once your model learns all of the features associated with the training data, that is when you would have to go ahead and predict the values on top of the test data. And that is what we'll be doing now. So to divide the data into training and testing set, we will need this library called as sklearn. So from the sklearn package, we have this submodule called as model selection. So what I'll do is I will write down from sklearn.model selection. I would have to import train, test, split. Again, let's just wait for this to load. Right, so we have imported this method called as train, test, split from the model selection submodule of sklearn package. And now we will go ahead and pass in the parameters inside this. So I'll have train, test, split, and this takes in the independent variable, dependent variable, and the test size. So independent variable is present in X, the dependent variable is present in Y. Now I'll have something called as a test size, and I will set the test size to be equal to 0.3. So what does this mean? Well, this means that 70% of the records go into the training set and 30% of the records go into the test set. Now this returns 4 objects. And what are those 4 objects? Let me just tell you. So we will have something called as xtrain. Then we will have something called as xtest. After that, we will have ytrain. And then we will have ytest. So what are these 4 variables? So xtrain is your training set for the independent variable. Xtest is the testing set for the independent variable. Ytrain is your training set for the dependent variable, and ytest is the testing set for your dependent variable. So this is something which you would have to remember. So we have these 4 objects being returned by train, test, split method. Now, once that is done, since we have our training and testing sets ready, let's go ahead and import the decision tree classifier. So decision tree classifier is a part of the tree module. So here I will write down from sklearn.tree import decision tree classifier. So I have imported decision tree classifier from sklearn.tree. Now, since I have the decision tree classifier, I'd have to create an instance out of this. So I would just have to write down decision tree classifier And this I would have to store in this object called as DTC. So this is just an instance, and this is just a simple name which I'm giving to this instance for this decision tree classifier. So now that we actually have the instance ready, with the help of this instance, I can fit the model on top of the training set. So I'll have dtc.fit, and I will be fitting this model on top of the training set. So the training set will be xtrain and ytrain, and I'll hit on run. And we have successfully built this model. And as you see, the split criteria over here used as Gini index. So we have built the decision tree. Now it's time to predict the values. And to predict the values, I will have something called as dtc.predict. And I would have to predict the values on top of the test set. So it will be x underscore test. And I will store the result in ypred. So ypred will have the predicted values. Let me just show you what is actually there in ypred. So when I run ypred, you will have these predicted values on top of the test set. So now I would want to see how many of these values are actually correctly predicted. And for that purpose, we have something called as a confusion matrix. So let me actually first import confusion matrix, and then let me tell you what it is. So confusion matrix is a part of metrics. So I'll write down from sklearn.metrics import confusion underscore metrics. So now that we have imported confusion matrix, what I'd have to do is I'd have to use this method. So I'll write down confusion underscore metrics, and inside this I would have to pass in the actual values and the predicted values. So our actual values are present in ytest, which is the testing set for the dependent variable, and these are the predicted values which are present in ypred. So actual values and predicted values. Now what exactly is this? So here, consider these on your rows to be the actual values and on your columns to be the predicted values. So your left diagonal will be all of those values which are correctly predicted. Now let's say if we have Setosa over here. So let's say if we have Setosa, versicolor and virginica. Then again we will have Setosa, versicolor and virginica. So this would mean that out of the 14 records of Setosa, 13 have been correctly classified as Setosa, 1 has been incorrectly classified as versicolor. Then after that, we have this record for versicolor. So here you have 8 plus 4, 12, 12 plus 3, 15. So of the 15 records for versicolor, 8 have been correctly classified as versicolor, 4 have been incorrectly classified as Setosa, and 3 have been incorrectly classified as virginica. Then again, similarly for virginica over here, so out of those, so you have 7 plus 7 plus 2, which is 16. So of the 16 records for virginica, 7 have been correctly classified as virginica, 7 have been incorrectly classified as versicolor, and 2 have been incorrectly classified as Setosa. So now if I would want to find out the accuracy in prediction, the left diagonal indicates all of the correctly predicted values. So if I divide the left diagonal with all of the other values, that will give me the accuracy. So what I would have to do over here is, it will be 13 plus 8 plus 7 divided by, so now I will have 13 plus 8 plus 7 plus 1 plus 4 plus 3 plus 7 plus 2. Let me change it to 2 over here. So here when I hit on run, you would see that we get only an accuracy of 62%, which is not really great. So it seems that if we use only sepal length as our independent variable And if we would want to try to predict the class of the species, then the accuracy which we get is not actually much. So now what we'll do is we'll do something interesting. So instead of using sepal length, maybe we use a combination of something else. Maybe we actually go ahead with sepal length and petal length, and let's see how that actually goes. So this time what we'll be doing is, so what I'll do is maybe let's actually work in the same notebook. So I will write down model 2 over here, and when it comes to model 2, again I would need to extract my dependent variable and the independent variable. So dependent variable obviously would be stored in y. So here I have y is equal to iris. Inside this I will have the species column. So species column again is my dependent variable. Now I'll be doing something different over here. So here for the independent variables, so first I will have sepal length. So let me write down sepal dot length over here. Then I will also have petal length as my independent variable. So this time what I'm doing is multivariate classification, where I have more than one independent variable. So here sepal length and petal length are two of my independent variables, and on the basis of this we are trying to predict the species of the iris flower. So we have dependent and independent variables ready. Now again it's time to do the same stuff. So we'll have to import train test split. So I'll have from sklearn dot, so this will be model selection. Let me write down model selection. I will import train test split, and inside this I'll pass in the independent variable, the dependent variable, and after that I need to set a test size. So I will have test size, and let's say this time I set the test size to be equal to 0.4, which would mean that 40% of the records would be in the test set and the rest of the 60% of the records would be in the training set. So we seem to have an invalid syntax over here. Let's see what exactly is that. So here we have from sklearn.model selection import train test split. Let me actually see what is the error over here. Right, so here when we are actually importing it, I do not have to write any of this, so I'll remove that. And also I would not require this. So now that I have actually imported this, then I can go ahead and use train test split. So I'll write down train test split. Inside this I'll give in x and y, and after this I will give in the test size. So I will have the test size to be equal to 0.4, which as I've told you would mean that 40% of the records would go into the test set and the rest of the 60% of the records would go into the training set. And this would return 4 objects. The first object is obviously xtrain. The second object is obviously xtest. So now that we have xtrain and xtest, then we would need ytrain and ytest. So this is ytrain, then we have ytest. So what is xtrain? It is the training set for your independent variable. What is xtest? That is the testing set for your independent variable. Then you have ytrain and ytest. And what are these? Ytrain is the training set for your dependent variable, and ytest is your testing set for the dependent variable. So I have divided the data into training and testing sets. Now again, I would require the decision tree classifier. So from sklearn.tree import decision tree classifier. Let me write the spelling properly over here. And after this, let me create a new instance of this and let me call this DTC2. So DTC2 would be equal to decision tree classifier. I'll hit on run. So we have an instance for decision tree classifier as well. Then going ahead, what I'd have to do is I'd have to fit the model. So it will be DTC2 dot fit, and obviously I'll be fitting this on top of xtrain and ytrain. So I have fit the model. Again, the split criterion is Gini index over here. Now I would have to predict the values, and to predict the values it will be dc2 dot predict, and inside this I would have to predict this on top of the test set. So this I will go ahead and store in ypred2. So I have my actual values and the predicted values. Actual values would be stored in obviously ytest, and the predicted values would be stored in ypred2. And to find out the accuracy, I need to use the confusion matrix. So let me write down confusion matrix over here. And the first parameter would be the actual values which are present in ytest. And the second parameter is ypred2. So let me write down ypred2, which has the predicted values. And this time, as you see, when I have included a combination of sepal length and petal length, the classification seems to be much better. So here, out of the 15 records of Setosa, all of the 15 records seem to be correctly classified as Setosa. Then for Virginica, out of the 21 records for, this is actually versicolor, so of the 21 records of versicolor, 19 of them have been correctly classified as versicolor and 3 of them have been incorrectly classified as Virginica. Then out of the 23 records for Virginica, 21 have been correctly classified and 2 have been misclassified. So to get the accuracy of this, I'd have to divide again the left diagonal with all of the values. So this time it will be 15 plus 19 plus 21 divided by 15 plus 19 plus 21 plus 3 plus 2. And now when I hit on run, you would see that we get an accuracy of 93%. So the difference in accuracy is extremely clear and visible for you folks. So when we only use sepal length as our independent variable, we get an accuracy of only 62%. But when we use sepal length and petal length as our independent variables, we get an accuracy of 93%. So this is a huge jump in the accuracy of the model. And this brings us to the end of the demo. So now we'll go ahead and implement a demo on random forest in Python. So this will be a comprehensive demo where first we'll start off by doing exploratory data analysis on top of the COVID-19 dataset. Then we will go ahead and implement the random forest algorithm. So first we would have to import all of the required libraries. So I'll just go ahead and do that. So we would need the pandas library for data manipulation. Then we would need matplotlib, which is for visualization. So I'll write down from matplotlib import pyplot as plt. Then we will also need seaborn, which is another visualization library built on top of matplotlib. So here we would need, I'll write down import seaborn as SNS. Then in our current data set, we have certain dates in it. And by convention, the dates which are there, they would be present as categorical labels and not as a date column. So we would also require the date time library. So let me import that as well. So here I'll write down import date time as dt. And I would also require the numpy library. Import numpy as np. I'll hit run and let's just wait for all of these libraries to load. Now, in the meanwhile, these libraries are loading. I would have to load up the required file. So the file is in CSV format. And to read the CSV files, we have the read_CSV method, which is part of the pandas library. So while these libraries are loading, I'll just write the next command over here, which will be pd.read_csv. And inside this, I need to give in the name of the file. So the name of the file is COVID-19 India.csv. And as I've said, there's a date column over here. So I will write down parse dates is equal to, and here inside parenthesis, I'll write down date. Then I'll add another parameter where I'm just setting the day first to be equal to true. So I'll write down day first is equal to true. This I will go ahead and store in an object called as df. Let me do this right over here. Now I'll have a glance at the first few records of this data frame. So to have a glance at the first few records of a data frame, I need to use the head method. So this will be df.head. And as you see, we have all of these columns. S number, which is just the index number of this particular record. Then we have this current date. So as you see, this is 30th of January 2020, 31st of January 2020, 1st of February 2020, and so on. Then you have the time over here, state or union territory. Then you have confirmed Indian national. Then you have confirmed foreign national, cured, deaths, and confirmed. So these are all of the different columns which are present. Now out of all of these columns, I would need only certain columns, which would be the date column. So I would not require the time column. I would not require the S number column. I would require state, union territory. I would not require this. I would not require this. Then I'll also take cured, deaths, and confirmed. So what I'll do is I'd have to extract all of these columns. Let me go ahead and do that. So here first I need to give in df, and inside parenthesis, what I'll do is I would have to give in all of the columns which I'd want. So I would need date, I would need state, union territory. Let me write down properly over here. So it is state / union territory. Then I would also need the cured column. After this, I have the deaths column. Then I have the confirmed column. So I have extracted all of this, and I will go ahead and store in this object called as df. So it's just that this is the original data frame. From the original data frame, I'm extracting only these columns, and I'm storing it back to the original data frame over here. Now I'll again hit on run. So we seem to have an error over here. So I need to give in proper indexing. So we have date, state, union territory, cured, deaths, and confirmed. So state, union territory, we seem to have a problem over here. Let's just actually see if I've given the, so there shouldn't be a space over here. Now let me hit run. Right. Now I will have df.head again. And as you see from the original data frame, I have only extracted date, state, union territory, cured, deaths, and confirmed. Now again over here, so state and union territory. So this is the column name over here is very big, and I would want to rename this. So again, what I'd want to do is so you have capitals over here. So it's better if I have the starting letter of all of these columns small. So I'll also change them to be small. And it's instead of having state / union territory, I'll just have the column name as state. So let me go ahead and do that. So for this purpose, what I'll do is I have this columns method. So I'll just write down df.columns, and inside the list, I will give in the new names. So first I'll have date, then I will have state. After that, I will have cured. Then I will have deaths, and then I will have confirmed. I'll again hit on run. Now let me again show you the first few records of this df.head, and as you see, I have renamed these columns. Now after this is done, so as you see, these are all of the columns which I have, and the date, as you see, it starts from 30th of January 2020. Now if I actually show you the tail, that will give me the final date. So this would be in ascending order. So when I have df.tail, so here you would see that we have all of this data till 17th of July 2020. So starting from 30th of January, so this is the first record which we have for Kerala. So in Kerala, there was the first confirmed case was found on 30th of January 2020. And as you see over here, so as of 17th of July 2020, in West Bengal, there have been 36,117 cases. Similarly, in Uttar Pradesh, there have been 43,441 cases. So this is quite interesting over here. Now, what I want to do is, I would want to extract all of the cases which have been there till today, or in other words, I would want to extract only the date. So here, as you see, this is the current date, or this is the latest date, which is 17th of July. So I would want to extract all of those records where the date is equal to 17th of July. So let's see how can we do that. So again, this is our original data frame, which is df. So from this, what I'd have to do is df.date, because this is the column. So df.date needs to be equal to 2020-07-17, and this I will go ahead and store in an object called as today. I'll hit on run. Now I will have today.head, and let's see what do we get. So as you see over here, so I have all of the cases with respect to different states as of 17th of July 2020. So as of 17th of July 2020, there have been 180 confirmed cases in Andaman and Nicobar Islands. Similarly, there have been 38,000 cases in Andhra Pradesh, 543 cases in Arunachal Pradesh, 19,000 cases in Assam, 21,000 cases in Bihar. So this is something interesting, isn't it? And now after this, what I'd want to do is I would want to sort this with respect to the number of confirmed cases. So as you see, I would want to know which state has the maximum number of confirmed cases. So since this is a numerical column has this method called as sort values. So what I'll do over here is I will write down today dot sort values, and inside this I would have to sort this data frame with the help of the confirmed column. So I'm basically sorting this data frame by the confirmed column, and this has to be in descending order. So I will set ascending is equal to false. So I'll basically have that particular state which has the maximum number of confirmed cases at the top. And this I will go ahead and store in an object called as max confirmed cases. So let me write this down properly over here. And then I will have a glance at the head of this. So it will be max confirmed cases dot head. And as you see, so as of 17th July 2020, Maharashtra has the maximum number of confirmed cases. So Maharashtra has 284,281 confirmed cases as of 17th July. Then followed by Tamil Nadu. So in Tamil Nadu, you have 1,56,000 confirmed cases. Then in Delhi, you have 1,18,645 confirmed cases. So you see that the difference between Delhi and Karnataka as of 17th July over here, it's almost 50,000. As 17th July, there have been 1 lakh cases in Delhi and 50,000 cases in Karnataka. And similarly, if you see the difference between these three, so between Maharashtra and Tamil Nadu, there is a whopping difference of 1,30,000 cases as of 17th July 2020. So again, an interesting analysis which we have directly found out by looking at this data set. Now, what I'd want to do is, so as you see over here, I have only the top 5 records. Now I would want to make a simple bar plot for this. So to make a bar plot, I would need the first 5 records. So what I'll do is, I will only take the first 5 records out of this. So I will have, let me take this, let me paste it over here, and I would need the first 5 records, and this I will go ahead and store in an object called as top states confirmed. Let me put a hyphen over here. Now let me print out top states confirmed. Let me write this down properly over here. And as you see, we've got the top 5 states. Now what I basically want is, I would want to make a bar plot, which means that I would want the state column on the x-axis and the confirmed values on the y-axis. And for this purpose, I would need this library called as Seaborn, which we have already imported. So for this, first I'll go ahead and set the figure size, or maybe we can do that later. So what I'll do is, I will directly write down sns.barplot. So this is how we'll be creating a bar plot. And on the x-axis, what I'd need is, I would need the state column, and then I would need something on the y-axis. So on the y-axis, I would need the confirmed column. And where are these two columns coming from? These two columns are coming from top states confirmed. So data is equal to top states confirmed. Then let me just hit on run, and I'll have plt.show over here. Let me just write down plt.show so that all of this metadata is not there. And as you see, we have this simple bar plot over here, which tells us the maximum number of confirmed cases as of 17th July 2020. So this tells you clearly that Maharashtra has the maximum number of confirmed cases. Then you have Tamil Nadu, then you have Delhi, then you have Karnataka, then you have Gujarat. So this is quite interesting over here. Then, as I've told you, let's say if I would want to change the figure size. So I have the set method inside the Seaborn library. So I'll just write down sns.set. I have this parameter called as rc, and I will set the figure size inside this. So here I will have figure.fig size, and so this I'm basically giving as a, this I'd actually have to give as a dictionary. So let me put this inside a dictionary and not inside a list. So I have figure.fig size. This is the key, and the values would be, I would just have to give in the dimensions of the image. So let's say if I set it as 15,10, now if I hit on run, so you'd see that the dimensions have changed. Let's say instead of 15,10, if I only keep it to be 5,5 and then hit on run, you would see that again the dimensions of this plot have changed. So this is quite interesting over here. Then going ahead, what I'd want to do is, so this was the maximum number of confirmed cases. Now similarly, I would want to find out the maximum number of deaths. So to get the maximum number of deaths, I would have to just take the same command as you see over here, and instead of sorting this with respect to confirmed, I would have to sort the data frame with respect to deaths. So let me change the by to be deaths, and this I will go ahead and store in an object called as max death cases. And once I've stored it inside this, let me have a glance at the head of it. So I'll have max death cases dot head. So here again, it seems that the most number of deaths have been in Maharashtra as of 17 July 2020. Then you have in Delhi, you have 3,545. In Tamil Nadu, you have 2,236. Gujarat, you have 2,089. Uttar Pradesh, you have 1,000 deaths. So quite interesting over here. Now, if I'd have to make a same plot out of this, like we have made a bar plot above, so what I'd have to do is I would have to extract the top five records again out of this data frame. So let me take in the same command over here, and instead of max confirmed cases, this time it will be max death cases, and this I will store in an object called as top states death. So now that we have this ready, again I would have to make the plot for this. So again, making the plot as similar, we just have to use the same command over here. So as you see, sns.set, with the help of this we are setting the figure size. Then we have sns.barplot. On the x-axis it will be state, and on the y-axis instead of confirmed it will be deaths, and data is coming from top states death. So let me change this to top states death and plt.show. That is how we are just showing this out. So this has to be top states death and not deaths. And this is our result over here. So as you clearly see, most number of deaths in Maharashtra. So let me actually compare this particular plot with this plot. So this tells you the most number of confirmed cases, and this tells you the most number of deaths. So the most number of confirmed cases are in Maharashtra, and also the most number of deaths are in Maharashtra. But if you look at the confirmed cases and deaths of other states, so you see that UP is not among the most number of confirmed cases, but over here, as you see, UP is listed at number 5 when it comes to the most number of deaths. So this is quite interesting over here. So again, Delhi, which was at the 3rd place for most number of confirmed cases, but when it comes to deaths, it is at the 2nd place. And again, if you talk about Karnataka over here, even though Karnataka has the 4th number of confirmed cases as of 17th July, but you see that Karnataka is not listed among the top 5 states where most number of deaths have happened. So all of this was basic data visualization which we have done. Now, similarly, I would want to do the same stuff for states where we have most number of cured cases. So for this purpose, I would have to again sort my data frame. So I will take this particular command over here. I will paste it over here. And this time what I would have to do is, so it will be today.sort values, and instead of deaths, it will be with respect to the cured column. And then I will go ahead and store this in an object called as max cured cases. And let me just have a glance at this. Max cured cases dot head. And when I hit on run, you would see that these are all of the columns which I have. So most number of confirmed cases were in Maharashtra, and also most number of cured cases are in Maharashtra. Then you have Tamil Nadu, Delhi, Gujarat, and Telangana. So you see that when it comes to Telangana, this is quite interesting. Even though it wasn't listed as one of the states as most number of confirmed cases or most number of deaths, but it seems that people who've been confirmed in Telangana, they've been cured more in Telangana. So quite an interesting analysis over here. Then going ahead, what I'd want to do is make a similar plot out of this. So to make a plot out of this, what I'd have to do is first take the top 5 records. So this time I would, this will be max cured cases instead of max death cases, and I would need the top 5 records, and I will store this in an object called as top states cured. Now I would have to just create the same plot for this as well. I will take this command, I will paste it over here, and this time the data is coming from top states cured, and on the x-axis I will have the state column. It's just that on the y-axis I will have the cured column, and when I hit on run, you would see that this is how the plot looks. So again, a very pretty and informative plot which we have made over here. Now going ahead, what I'd want to do is I'd want to analyze individual states. So till now we have understood that Maharashtra has had the most number of cases and most number of deaths as well over there. So that is why I would want to understand what exactly is the trend when it comes to the state of Maharashtra. So what I would want to do is from the original data frame, df.state is equal to Maharashtra. So I would want to extract all of the records from the original data frame where state is equal to Maharashtra. And I will go ahead and store this in an object called as Maha. Then I'll just show you the head of this maha.head. So as you see, it seems that the first case in Maharashtra was on 9th of March. So on 9th of March, there were 2 confirmed cases. Then I will have maha.tail over here. And when I have maha.tail, you would see that as of 17th July, there have been 284,281 cases. So from 9th March to 17th of July, from 2 cases, the number of confirmed cases have gone to 284,281. So this is extremely interesting over here. So now what I'd want to do is how I'd want to understand how have the number of confirmed cases increased from 9th of March to 17th of July over here. So for this, I would want to make a line plot where the date column will be on the x-axis and the confirmed cases will be on the y-axis. So for this, I would have to create a line plot. So I'll write down sns.lineplot, and on the x-axis, since I would need the date column, I'll just put in date over here. And on the y-axis, I will need the number of confirmed cases. So here I'll write down confirmed. Then going ahead, I'll give in the state. So here the state will be equal to Maharashtra. Then I'll just give a color to the line. So here the color will be equal to green. And then I would just have to print this out. So it will be plt.show. So seems like we have an error over here. Let's actually understand. String object has no attribute get. So why do we have this? So let me give in green over here. Let me give in an entire color and let's see if this works properly. So seems like we again have the same error over here. X is equal to date, Y is equal to confirmed. So this has to be data is coming from Maharashtra, color is green. So all of this seems to be fine. So what I'll do is I'll actually copy paste the same command from above. That will be easier. So let me copy this and let me paste it over here. And instead of having this as a bar plot, I will keep it to be line plot. And here on the x-axis, I would need the date column. On the y-axis, let's actually see what do we need. On the y-axis, we would need the confirmed column. And the data is coming from the Maharashtra, which we have just created. So let me change this to Maharashtra over here. And here, let me actually change these dimensions. So I'll increase the width of this. So instead of keeping it 5, I'll keep it 10. And as you see, maybe I'll increase it even more. I'll keep it 15 over here. That might be better, I guess. So as you see, the growth of number of confirmed cases has been exponential. So from the date over here, if you look at this is 22nd of March 2020 and this is 22nd of July 2020. So from being from 0 confirmed cases, so from March to July, as you see, the growth of number of confirmed cases is quite exponential. And maybe during this particular time, so maybe from 22nd of March 2020 till over here, so till this is 1st of May 2020, there were not many cases. So during the first 2 months, there were not many cases. But then again, from 1st of May, the number of cases have grown exponentially. So this seems to be something interesting. So something during 1st of May, during that particular week might have happened in the state of Maharashtra, and this would have led to the increase in number of confirmed cases. Now, what I'd want to do is I would want to make a similar line plot for the number of deaths as well. And here the command will be same, sns.set, and on the y-axis I'll be mapping deaths instead of confirmed. And as you see, this is the trend over here. So again, you have the date from 22nd of March going on till 22nd of May. So again, till 1st of May, you do not have a lot of deaths. But from 1st of May, this grows exponentially. And this particular line which you see, so this may be, so you have June. So this might be the end of June over here, so maybe somewhere between 25th of June, you would see that the spike over here is it's enormous over here. So being from 2000, it almost, so being from 4000, it almost spiked up to 6000 over here. So till then, the growth was not so much high, but during this particular span, maybe in a span of just 2 to 3 days, the number of deaths have grown exponentially. And after this, again, as you see, the trend just keeps on increasing with respect to number of deaths over here. So this is with respect to Maharashtra. Now I would want to do a similar analysis for the state of Kerala as well. So here, what I will do is, again, I would have to extract all of the records from the original data frame, where the value in the state column is equal to Kerala. So df, and here I need to give in the name of the column. So here inside df, I need to set df dot state is equal to Kerala. And this I will go ahead and store in an object called as Kerala. Then let me just have a glance at this. So Kerala dot head, and if I run this, so here you would see that the first case in Kerala was reported on 30th of January. So you have one confirmed case. Now similarly, let me see what was the final number of confirmed cases. So Kerala dot head, I'd have to actually change this to tail and not head over here. And when I run this, here you would see that the number of confirmed cases as of 17th July, they are 10,275. And this is quite contradicting when compared to Maharashtra, isn't it? So when you look at the table of Maharashtra, you would see that the first case was confirmed on 9th of March. And from 9th of March to July, the number of confirmed cases is exponential. It's staggering. But when you look at this in the state of Kerala, so the first confirmed case was on 30th of January itself, which was 2 months before the first confirmed case in Maharashtra. But you see the total number of confirmed cases as of 17th July 2020, you would see that they are very low. The growth of the confirmed cases has been very, very less in Kerala when compared to Maharashtra. So this might tell you something interesting. So there might have been certain situations in Maharashtra because of which there has been this sudden explosion of number of cases. Now, what I'd want to do is I would want to make similar plots for the state of Kerala as well. So let me copy this same command over here, and I would want to make a line plot where I would want to see the growth of the confirmed cases. And here the data is coming from Kerala and not the Maharashtra state. So line plot, on the x-axis, I'll have the date column. On the y-axis, I'll have the number of confirmed cases. And here, as you see, so the growth again over here. So this is starting from February of 2020 till, if maybe we can say, again, this would be end of May or the starting of June, you don't have a lot of cases. So it's only from starting of June that the number of cases have started to spike up in Kerala as well. And similarly, I would want to have a look at the number of deaths in the state of Kerala as well. I'll copy the same command, I'll paste it over here, and on the y-axis, instead of confirmed, I will have the deaths column. And this time, if you see, this is quite interesting over here. So from February till maybe February, March, April, you do not have a lot of deaths, or maybe you don't have any deaths at all. And in the month of April, maybe you will have around 2 to 3 deaths, and that is not very gradual. But then again, as you see, from the end of May and the starting of June, the number of deaths have again spiked up. So this is again quite an interesting analysis which we have done over here. Now, going ahead, what I'd actually want to do is I would want to build a random forest algorithm which will actually tell me how to predict the number of deaths. So that is something interesting. So here I'll be actually using random forest regressor. So I'll be using the random forest algorithm as a regression algorithm and not as a classification algorithm. And I would want to predict the number of confirmed cases if I given a date. So let's say if I given the next date, so here we have dates till 17th of July. So let's say if I would want to predict the number of confirmed cases on 18th of July, I would want to do that with the help of this random forest classifier. And this is where the main part comes in. So let's go ahead and start doing that. And we'll be implementing this on top of the Maharashtra data frame which we have. So for that purpose, first we would have to import all of the required libraries. So here I would need the train test split method from model selection. So I will start off by writing from sk learn dot model selection import train test split, and I'll hit on run. And this is important because we would have to divide our data into training and testing sets before we actually build our model. And why is that important? Let me just give you guys a simple example. So let's say if you're appearing for a test and the situation is such that, let's say your friend comes up with you and tells you that the paper has been leaked and there will be 5 questions in the exam, and he tells you what those 5 questions are. Now, if you prepare only those 5 questions and go to the exam, and if exactly those 5 questions come up, well, you're set. You will get 5 out of 5. But what would happen if, let's say, none of those 5 questions actually come in the exam? Now, since your training has only been with respect to these 5 questions, if anything comes out of syllabus, then obviously you will not be able to answer. You will get 0 out of 5. So this is why training and testing is important. So first you would have to train yourself, then you would have to test yourself how much you have learned. And we will have the same concept when we will be using machine learning algorithms as well. So first you would have to train your model on top of the data, and only when the training is done, that is when you will go ahead and build the model on top of the test data. So that is why we would need this train test split to divide our data into training and testing sets. Now what I'd have to do is I would so as you see, now again, if I have to build a random forest regression algorithm, so here, since this is regression analysis, my independent variable, it cannot be categorical in nature and it cannot be date. So I would actually have to convert this into an ordinal value. So as you see, this we cannot have a date over here, and to use the dates in a random forest classifier, I'd actually have to convert this into an ordinal value. So ordinal value, it's just that would mean a number. So each date will have one particular number over there. So what I'll do right now is I will convert the date column into an ordinal value. So as you remember earlier during the starting of this demo, we had imported the date time library. So let's go ahead and convert this. So from the Maharashtra data frame, we have the date column. I have the map method, and inside the map method, what I'd have to do is dt dot date time, and I would have to convert this into ordinal. So dt dot date time. So again, dt is the date time library. So from the date time library, I'd have to convert this into ordinal. What do I have to convert? I'd have to convert the date column into ordinal values. And this I will actually go ahead and store back into the same column. So this will be Maharashtra date. Let me hit run now. Now what I'll do is I will have a glance at my data set. So I'll have maha.head over here. And when I hit on run, so you would see that all of the date values, they have been converted into ordinal values. So initially we had dates like these, but now with the help of this, we have converted them into ordinal. So we have one specific number for each of the date value. Here, since I would have to predict the number of confirmed cases with respect to date, this will be my independent variable and this will be my dependent variable. Now, let me go ahead and extract my dependent and independent variables first. So I will store my independent variable in x. So it will be x is equal to maha. Inside this, I'll need to pass in the date column. Then I would also need to extract the confirmed column, which will be stored in the y object. So here I will have confirmed. So I have extracted x and y. Now, since I have my independent and dependent variables, I can finally use the train test split method to divide my data into training and testing sets. So here I will write down train test split. Inside this, I will pass in x, y, then I have another parameter called as test size. So test size, let's say if I given a value such as 0.3, this would mean that 30% of the records would be in the test set and rest of the 70% records would be in the training set. And then this method will give me 4 outputs. So let's see what those are. I will have something called as x train, then I'll have x test. After that, I will have y train, then I will have y test. So here x train means that it is the training set of independent variable. X test is the testing set of independent variable. Y train is training set of dependent variable and y test is testing set of dependent variable. So we have all of the independent variables and dependent variables with respect to train and test sets ready. Now, once we have this, I would have to go ahead and build the model. So to build the model, I would need random forest regressor. Let me go ahead and import that. So I'll write down sklearn dot ensemble import random forest regressor. And here you'd have to keep in mind that R, F and R are capital over here. So R in random is capital, F in forest is capital, and also R in regressor is capital. So from sklearn.ensemble import random forest regressor, then I'd have to create an instance of this. I will call this instance as, let's say, RF. So I'll have RF is equal to random forest regressor. And once I create this, I would have to build this on top of the training set. But now I will actually show you how the training set looks like. So ytrain, what is ytrain? Ytrain is the training set of the dependent variable. And here, what is our dependent variable? Dependent variable is the number of confirmed cases. And here you see that I have all of these index values. So I do not want this index values corresponding to also my actual values over here. So I just want to remove these indices. So if I don't want to remove these indices, I would need the help of NumPy library, which I have imported earlier on. So here, what I'll do is, while fitting this, I'll just write down dtr.fit. Inside this, I will have np.array. And what I'll do over here is, inside the array, I will pass in xtrain, and I would have to reshape this. So I will have reshape. So xtrain, ytrain, they have the indices as well, and I do not want this indices. So I'll have dot reshape -1, 1. So when I give in -1, 1, this will remove the indices. And then similarly, I will have np dot array. Let me keep this properly. np dot array. Inside this, I will have ytrain dot reshape, and again I would have to give in -1, 1 over here. So this dtr.fit. So we are building or fitting the model on top of the training set. So training set is basically xtrain and ytrain, but our xtrain and ytrain have these indices, and we have to reshape these training sets without the indices. So that is why I'm using this particular command. And let me hit run. So this is actually RF and not DTR. Let me change this to be equal to RF. And we have successfully built our random forest model. So now that we have built our model, what I'd want to do is I would want to predict the values. So I will have maha.tail. Let me run this. So as you see, so with respect to a particular date, I have a confirmed value over here. Now let's say if I would have to predict something, what I would want to do is I will have rf.predict, and so when we have to predict something, it will give you the result of your dependent variable. And what do we have to pass in? We would have to pass in the independent variable. So independent variable is your date, and here this value which you see 737623, this gives you your date. Now let's say if I give something such as 737600, and if I hit on run, there actually seems to be a problem over here. So here I would actually have to pass this as a NumPy array. So inside this, I will have np.array, and I will have, let's say if I given 737600, I hit run. So seems like I'm making some error over here. So this actually has to be written in this particular format. So it'll be rf.predictnp.array. And let's say if I'd want to predict something, maybe, so this is 737623. So now if I'd want to know how many cases were there 23 days back, I'll give in a value of 600. And this gives us a value of, as you see, there were 1,39,950. Maybe if I change this to, let's say, 450. Again, if I hit on run, so you would see that this gives you a value of 7.7. So this might not be exactly accurate. So this is a very baseline random forest model which we've built. And also, let's say if I would want to change this. So let's say if I keep this as 737 and I keep it to be, let's say, 737650. And if I hit on run, so this gives you a value of 275298, which is actually less than the value of the number of confirmed cases as of 17th July. So this is quite interesting, isn't it? So again, this is a very baseline model, and this baseline model will give you inaccurate results. So this brings us to the end of this session on where we have done a proper exploratory data analysis on top of the COVID-19 dataset. Then we learned how to implement the random forest regression algorithm on top of it.
In this part, we are going to talk about regression analysis in data mining. As we already know, regression is nothing but the part of machine learning. We have talked about what is machine learning, why we need machine learning, and also we have talked about how can you build a model in machine learning. Now we are going to look into one particular topic in machine learning, that is regression analysis. In this particular part, we are going to talk about so many things, right? Like what is regression, what are the types of regression we have, and we will see in the agenda. So basically, this is one type of a data mining technique by which you can actually understand your data in a much better way. So you can totally understand data mining is nothing but how can you mine your data? How can you get lots of information from your unstructured data? How can you make those unstructured data in a structured manner, right? So let's go and let's have a look at the objective we have. First, we are going to talk about what is regression. Yes, what this term stands for, how it's going to help us in order to do the data mining. Then we will see some of the use cases of regression, how regression is actually making the meaning to mine the data. Then we will see the types of regression we have. Then what is simple regression? Yes, now under comes of types of regression, we have simple regression and multiple linear regression. We will talk about both of the type of the regression. Then we will see how regression works. So there is a whole understanding or end-to-end understanding of how regression works. Then we will see how can you implement regression using Python, and then we will do a salary prediction using Python and UBIT data analysis to predict the cab fare. Yes, we will do a total demo to actually understand regression, how can you implement them in Python, and using two different data set which can actually help you to again understand this particular concepts called regression, right? So let's start with what is regression. So first we are going to talk about what is regression. So regression is basically nothing but a technique that predicts the value of variable y based on the values of variable x. I can understand it's basically nothing but it's confusing, right? What type of variable x and y we are talking about. I will explain you everything, the maths behind regression as well. And this is very simple, trust me. So let me tell you what is regression. So in the case of this, you can understand we do have two types of variable. One is dependent variable, one is independent variable. We will talk about variable later. But before that, let me give you a use case example for that you understand what actually I want to mean by regression. So regression is nothing but who can help you to find the relationship between two different things. Suppose we have an example of as the winter comes, we try to put on jackets, right? So in that case, what we can say, as the winter comes, we used to buy more jackets. So yes, there is a direct relationship between sale of the jacket with the weather. Yes, finding out this type of relation is nothing but your regression. So we can see here as the temperature drops, sale of the jacket increases and we are getting a relationship between them. Right. Now we will have a look at one more thing. So you can totally see that regression is nothing but if you think there is a relationship between two things, then the regression will help you to confirm it. Right? Now let's go and move forward to the another example. Suppose as the temperature increases, right, as the summer comes, what we do, we used to buy lots of ice creams, right, because we love to have ice cream and it's cold, right? So yes, you can totally again understand there is a relationship between summer and the ice cream van. So as the temperature increases, number of cones sold at the ice cream stores also increases. So there is a direct relation between both of them. And regression will help you to confirm that, will help you to find that, yes, there is a relationship between these two variables, right? Yes. This is pretty much about regression and how regression help us to find out the information from the data. You can totally understand how regression is helping us to get the idea, okay, there is a relationship between these two particular variables using regression technique. Now we will talk about what are the type of regression we have, and then we will see how we are going to do this particular regression technique on the data set, using the data set, and how it actually help you to do the regression analysis as well, right? So what are the type of regression we have? There are various types of regression we have, like linear regression, logistic regression. We talk about multiple linear regression, right? So there are types of linear regressions we have. So in this particular case, we are going to talk about linear regression. Right. So linear regression is a type of supervised learning. So we talked about type of machine learning. What are the type of machine learning we have? Basically, we have three types of machine learning: supervised learning, unsupervised learning, and reinforcement learning. So we know what is supervised learning, right? So supervised learning is nothing but where you have the labeled data set. So I will show you again what labeled data set I want to mean by, right? So linear regression is a type of supervised learning. Now we are going to talk about used for finding linear relationship between the dependent and independent variable. Now let me give you one example. We have y equals to mx plus c, right? That is nothing but, again, this is a straight line formula. While we have y equals to your dependent variable. So when we are going to write in x plus c equals to y, so you can understand x is nothing but your independent variable. We will see the elaboration of this particular formula later, but yes, I can just give you a heads up on this. So linear regression works on y equals to mx plus 3. Right? Now, this help you to find the relationship between two or more continuous variable. Yes, if you have a continuous type variable, right? Suppose your salary is a continuous type variable. Suppose is your Uber care, like Uber cab prediction is again cab fare prediction. Fare is a continuous variable. But when you have a discrete variable, that time you cannot use linear regression, right? Yes, so this help you to find the relationship between two or more variables. That variables will be or should be continuous type variable, right? So yes, this is pretty much about what is linear regression. Now we will see what is multiple linear regression. So multiple linear regression is nothing but an extension of linear regression. Yes, so if you have simple linear regression, from there we have multilinear regression. It helps to find the relationship between more than two variables. When you have more than two variables, suppose you have y equals to mx1 plus mx2 plus mx3 plus c, right? So in that case, this comes under multiple linear regression when you have more than two variables. As we know, in simple linear regression and was actually has one predictor and one response variable. But have a good look over here what I am saying, and it's actually a very good point or the main essential point or the difference between simple and multiple linear regression. So in the case of multiple regression, you have more than one predictor, but response variable will be one. Right? So this is what stands for multiple linear regression. Now we are going to talk about the two type of linear regression we have talked. Right? So you can see here the single predictor we have for simple linear regression, and for multiple linear regression we have multiple predictor. Right? Can you see over here? And what I have said over here, this will be more than one predictor variable, but one response. You can see the y will be 1, but the predictor will be multiple in the case of multiple linear regression. Now, if we talk about the formula, then for simple linear regression, we write y equals to mx plus c. That is nothing but our simple straight line formula. I hope you have already idea about what is this y equals to mx plus c. Y is the dependent variable, x is the independent variable. So these things you have to keep in mind very carefully, and you have to have a very good idea about it. Right? As we already said, as a big data scientist or a data mining engineer or a data architect, the basic pillars you need to have, that is statistics, you need to know the basics of linear algebra, and you have to have an understanding of one programming language, and then you have to know, how to read the data, how to understand the data. So yes, this particular mathematical part, little bit of mathematical part comes into the picture when we do this type of concepts, right? So now we are going to talk about y equals to m1 x1 plus m2 x2 plus m3 x3. So while we have multiple linear regression, right? So in this case, what we need to do, we have different type of different independent variable, like your predictors, that x1, x2, x3, but your end reach will be y. That is your dependent variable, right? So I hope you do not have any doubt regarding this particular two equation we have for two different linear regression. But this multiple linear regression obviously comes from simple linear regression. All right. Now we are going to talk about how can you understand simple linear regression. So we have dependent variable, we have independent variable, right? Can you see over here? And from there, we try to conclude a relationship between them, right? Now, if I just move forward, we have two observation, right? So your x1, x2, x3 will be your observation. From there, you will try to find it out a relationship between these observations, right? Now you have multiple observation, right? Can you see? Yes. From there, you will try to find the regression line using that particular formula y equals to mx plus c. So from this particular using y equals to mx plus c or y equals to mx1 plus mx2 plus mx3 ... plus c. So basically it's from simple linear regression, or multiple linear regression, using the formula, you will try to find a line, right? Which is nothing but a relationship between the two different variable or more than that, right? And using that, you will find a regression line which will predict the future values, right? So here you can see we will try to find the regression line, and we will try to find the, minimize the error between the predictor, predicted value and the actual value, right? So in the red, you can see this is your estimated value, and you have in the blue, you have the actual value, right? So this is the line we have. We will try to find it out that, okay, this line will be as less as you can, because the error will be that less, right? So you can see the actual value and the predicted value is really different from each other, and the goal is basically minimize the error. The distance between the actual and the estimate value should be less, right? So yes, by using the formula, we try to find out the relationship, and we try to find it out that this particular regression line which will predict the future value points, right? So yeah, this is what about simple linear regression, and with the observation we have done. As we have understood this particular concepts in a mathematical way, then we will try to do these things in Python using different data set, trying to understand different way of doing that. And also we will do a simple linear regression in Python without any data set in order to understand how linear regression works, right? So, okay, let's see what we have next. Yes, we have the demo. How can you implement linear regression using Python? In this particular part, we are going to talk about simple linear regression, right? What is simple linear regression? We have talked about that. Now we are going to implement simple linear regression using Python and using Python library in our Google Colab, right? So if you do not know about Google Colab, please do check out the video on Google Colab. So this is nothing but an IDE we have in Python. I mean, for just to do code in Python. So this is provided by Google, right? So now we are going to talk about how can you import packages and classes. So here hardly we can import classes, so we can focus on the packages. So we have talked about NumPy. Yes, so we have talked about NumPy, and we have worked with NumPy a lot in our previous modules, right? So in this particular case, again, we are going to import NumPy as NP. So we have two types of variable here. You can see we have independent variable and dependent variable. So dependent variable is dependent on the independent variable, right? That the name suggests, and we all know. Now we are going to use a particular formula that we have said, y equals to mx plus c. But we don't need to use, or we don't need to do it from the scratch, because we have scikit-learn in Python. So what is scikit-learn? Scikit-learn is nothing but a machine learning library we have in Python, where we have all the algorithm implemented previously, right? You don't need to write a program to implement a particular algo in machine learning. What you need to do, you just need to call the particular function, and you can just make your work done, right? So the first first variable x, we are going to initialize that using np array. So we have written np.array, and then we have given 25, 35, 45, 55, 65 and 65. And we given for y viewpoints, that is 5, 20, 14, 32, 22 and 38, right? Now I have just printed. So printing x is 25, 35, 45 and y is as follows. Now the input is x and output is y, right? What I have done over here, but we have used dot reshape function. Why we have used dot reshape? Why do I need to reshape my x? So on x, because of this array is required to be two-dimensional, or to be more precise, to have one column and as many rows as necessary. So what we have done, we have reshaped our array -1, 1. right? So if you just print x, you can see this is what we have changed the dimension for x. Now if I just write x dot shape, it's 0 and 1, you can see, yes, this is how we have changed it. Now we are going to create a model to have an understanding of linear regression. So we know linear regression follows what formula? I have said so many times. Again, a quick question from all of you: what formula or what basic algebra, or you need to know, to do the linear regression? Okay, let me tell you what is a straight line formula we have talked about so far, right? How can we do that? What is that formula, right? So yes, for your answer, we use y equals to mx plus c. For all the data points you have, we try to understand y, right? So you have x, we try to find it out y. So we have done x and y, okay? So now in the case of model equals to linear regression, we have done. So you don't need to write it from the scratch. So already linear regression is implemented in scikit-learn. I have written linear regression. So basically I am calling that particular function. So I have created an object of model, and model.feed is while we are going to train your model. We talked about in machine learning, we first need to train our model, then we try to find that how our model is working with the new set of data set. But here, as we are doing the very basic things, first we will try to find it out. First we will do the training, and then we will try to find it out how our model is working, right? So we have written model.feed x comma y, right? So you have just said, please get trained my model with the data points I have in x and y, right? So let me execute that. Yes, you can see the training is really done because the data set you have, it's really less, right? So once you have the model fitted, you get the result to check whether the model works satisfactorily and interpret it, right? Now I have done the R square. So if I just go back to the presentation, and I will just show you how to find it out how your model is working. So we have came to the presentation. Now you can see we have done this particular regression line. Now we want to check, okay, our model is working perfectly fine or our model are giving some error. In order to check that, we use R square method. So R square is basically like used to understand how your model working and how much error you are getting, right? So yes, so in that case, we will try to understand our R square in order to see how our model is going to work. So let's go back to Google Colab and let's see how it's going to work. So to do that, we called a function called score. So we have used model.score and we have given our data points, that's x and y. So while we are going to give that model.score x and y, we get the output that 0.7158. So in precisely, we can say our model is working 71% accurately, right? So yes, there is lots of scope we have where we can increase this particular number. But again, as we have a small data set here, it's a very basic demo. This we can say the model is working with the 71% accuracy. Now we have intercept. How can you understand the intercept? So in order to get the intercept, you have to call the again dot intercept underscore, right? You will get your intercept for the model. Then you have slope or coefficient. Again, to understand that, you can write model dot coefficient, that's COEF underscore, you will get the coefficient. These are the, the basic, and you can say these are the core part to understand. That's why we have talked about. Now if we try to predict the values from predict the values of y, you have to call model.predict and you just need to give x, right? So you can see what you have get over here. So if you write let me show you, this is really interesting to work with. Okay, now if I just write print here actual values, right? And if I just write y, Okay, so you will have the actual value, you will have the predicted value. Okay, so as we have written that y predict equals to model dot predict x, so for the y prediction you get 8.3, but the actual is 5. Then you get 13.733 while the actual is 20. Then you get 19.13 while the actual is 14. Right? So yes, there is a few changes here and there you have. That's why the accuracy is 71%. The more data points you will have, the more your data will try to, or your data will understand, or your model will understand more precisely. Right? So yes, this is the basics of, linear regression we have done. Now we will see one demo on multiple linear regression, and then we will jump into the project, and there I will show you how you can understand your data, the thing we have done, the visualization of data, how can you do that, everything we will talk about that. So let's see how can we do the multiple linear regression using Python, and also obviously using the libraries. Right? So let's see how we are going to do that. Now we are going to do demo on multiple linear regression. Right? So we have already talked about what is multiple linear regression. When we have like data points, like the independent data points, more predictors, right? That time we go for the understanding of multiple linear regression. If you have any doubt, do let me know in the comment section for understanding of multiple linear regression. Now we will actually implement this multiple linear regression concepts in Python. So the first and foremost things we need to do that importing packages, because we are really pretty much dependent about the packages. So we have talked about NumPy, and I have already given the introduction to scikit-learn. Scikit-learn is basically nothing but we have this particular library for implementing like already implemented algorithms for machine learning, and we just need to call them, and we just need to call the function basically, and we can ready to use, right? Yes, so this is pretty much about why do we need scikit-learn. Now we are going to just declare our variables, and from there we will try to use this particular concepts of multiple linear regression. So we have x and y, right? I have just zoomed it for your understanding. If you feel like you are not able to see, that's why. I know this letters are really small. I don't have any option to increase the fonts. So here we actually write x equals to 10, 21, 5, 18, 15, 24, 25, 26, right? We have do one. We have just declared the list of list. So total one list we have, and then we have multiple small lists. So here y is our what? It's like nothing but our not independent, it's a dependent variable, and x is our independent variable. Now if I just want to print x and y, you can see x is nothing but the list of list, and y is like, okay, let me just do that. Okay, so x is nothing but our list of list, right? And y is our again the list. So suppose if you just want to print the type of x, so how to check the type of any variable? We need to use type function for that. Yes, so yes, this is nothing but class list. Now if I do the same thing for y as well, type of y, this will be again your list. Now in multiple linear regression, x is a two-dimensional array with the list two columns, while y is usually a one-dimensional array. This is a simple example of multiple linear regression, and x has exactly two columns, right? Yes, so that's why what we have done, we have just used x and y to np.array. Now if I just print x and y after we converted them to array, this will look like, right, x and y. Now we are going to do the last, not the last. First, then we have done like we will call our model, then we will train our model. After training our model, what we will do, we will try to find out the results, how our model is going to work, right? I don't want to do this at a time. I just want to show you how we are going to do that. So again, we are like we have written the variable in model equals to linear regression. So we have called our algorithm, that is linear regression, from scikit-learn, right? Then what we are going to do, we are going to write model, right, dot feet. So why we use feet function? You can see over here feet linear model, and we have few parameters like array like sparse matrix of shape like for x and y, right? So if you want to know more about these particular functions, this, just click over, like write it and just click over here, it will show everything about that function from the documentation. Right now, if I just write x comma y, so I have given my data to get trained and to get train my model, right? So let me do that. Yes, can you see it's already trained? So why it's taking less time? While we are going to use a data set, it's obviously going to take more time. The more data you have, the more it will take the time, because the compiler also needs to understand the data points, and they also need to understand how these data points are uh, connected with each other, and trying to find it out the relationship between them, right? So we actually just calling the function and that's all, but that's not all at all. In the background we are doing lots of things, like the library itself, it's doing a lots of things to understand these data points, to get a relationship between them, and also predict the future as well, right? So yes, using machine learning, we know we can predict the future, but that's not that easy, right? You have the data, understanding the data, from those data finding out the relationship, and then find out the future. It's really time taking, when and like while we will have a lots of data, right? For this basic purpose, maybe we are just using an array for your betterment of understanding. But yes, after that we will do few projects like salary expectations based on the experience, and also we will do the Uber cab fare prediction. So now how we are going to create the model, that we have done. Now we have already trained our model using the data set. Now the most awaited part, the getting results and trying to understand how our model is working, right? So I have written R square, right? R square we use to understand what is the error percentage we have, and also what is how your model is working. Okay, so in order to do that, you have to call the function called dot score, and you have to provide your data set x comma y. So your model is working with the 79% accuracy. That's pretty good, right? Yes, so this is how your model is working. Now if you want to see the intercept, you have to call dot intercept and then underscore. You will give the intercept for your this particular y equals to m1x1 plus y plus m2x2 plus m3x plus m3xt plus c, right? So here we will get the intercept. Now if you want to get the slope, again you have to call dot coefficient function, right? Now last but not the least, we will see the predict response, how your model is going to predict the y while you are giving x, right? So we will call the function called model.predict and we will give x. Okay, so here you can see this is what we have given, and we will do a really interesting thing after that. So you can see y prediction will have all the predicted value according to x. Now what I'm going to do, I'm going to print actual value, right? And also I am going to write y. Then I'm going to write print predicted value, and we will write what y print. Okay, let's see how actually it works. Okay, so your actual value is 4. For the case of first one, it's showing 10.87. So yeah, you can see this is pretty much near to them, but there are few different numbers we can see over here. That's why your accuracy is 79%, right? So yes, this is pretty much about this multiple linear regression. I hope you understood this, how to implement simple linear regression, how to implement multiple linear regression, and the most awaited part, for this next part, we are going to do a salary expectation based on the experience. I will show you the particular, uh, data set as well, and how you can understand what is a continuous value data set, how you can understand what is how to like use linear regression based on the data set. We will talk about that, right? So let's see how can we do the most awaited project of salary expectation based on the experience. So now in this particular part, we are going to do the most, wanted part, that salary expectation based on experience. That's nothing but a project we are going to do. The first, before doing that, I will like show you how to understand the data set, and from there, how can you start your project building. So guys, what are things I have said while we are going to say it, okay? We are going to make a project. So first thing that comes into our mind, we have to understand our data set. After you understand your data set, you have to go for cleaning your data. But no, there is one more step that we have just forget. That's not acceptable. That your problem statement. You have to understand what is your problem statement. To understand, after you understand your objective, you can proceed with understanding the data. First you need to collect the data, and from there you have to go for clean your data. After you clean your data, you will go for exploratory data analysis. That is nothing but few statistical terms. From there you will understand your data more, and we will use few mathematical understanding and also machine learning algorithms understanding, which will actually go with your data in order to make a model out of it. After you do that, you will train your model, and after you train your model, you will give a new data set to understand how your model is working. If your model is working fine, you will go and deploy it. But in this part, maybe we are not going to talk about the deploying part, but yes, till before that, understanding the data to predicting your data set, like predicting your model, how it's working, we will do everything, right? So I hope it's quite interesting for all of you, and you guys are really excited to do that. Okay, so in this case, first we need to understand our data. So I have taken this data from Kaggle to do this particular project. So yes, this is the dataset. We have taken salary.csv. So let me show you what is this dataset and how you can understand that what type of dataset you are going to use while working with regression. So as I have said, regression works with only the continuous values. Now I will show you this particular dataset, salary.csv. Here we have only two columns, right? Let me make it big. Okay. So we have a year of experience and salary, right? Maybe you can work with more complicated data, but here we have get the basic data from Kaggle. So here we have seen that if your experience is 1.1, then your salary near about 239343, right? Or if your experience is 1.3, then 46,205. Okay, these are based on your experience. So you can see the salary column, we see the label data set, right? What is label data set? So in order to say the label data set, your data can be continuous data, or your data can be district data. So now we are not going to talk about the district data in order to talk with logistic regression. Maybe we will talk about that. But in the case of linear regression, we use continuous value data. So you can see we have 39343, or you can say 37731 or 43525. All of them are nothing but your continuous value. From there itself, you can understand you need to go for regression analysis, right? So regression always work with continuous value data set. While we are going to do the Uber CAFE prediction, again I will show you what is continuous value, right? So yes, continuous value, the name itself saying there will be a continuous type value, right? Yes. So while you are having this, you can say, okay, I can go for using this particular data set for regression. Now let's go back to the code file and let's see what we have done. Right. So here what we have done, we have actually imported the packages. So we have imported pandas and numpy. So we know why do we need NumPy, why do we need pandas. Then we have Matplotlib and Seaborn for the data visualization, as we already knew. So here I just want to show you one thing. If you want to upload the dataset in Google Colab, you have to click over this particular button, and from there you will get option of upload to session storage. You can directly, if you click over there, it will redirect to your local system, and you can actually upload the dataset you want to. So in this case, I just upload this particular dataset, right? So that is salary. Okay, so you can do that. I hope you don't have any doubt on Google Colab. If you do have, please do check out our video on Google Colab, right? So I have imported Pandas NumPy, I have imported Matplotlib Seaborn, and now we are going to read CSV file. How can you read a CSV file? We have called .read underscore CSV from pandas. Yes, we can read lots of type of data set or data description, whatever it is. If you want to read using pandas, you can do that. There are a lot more function they have for that. Now I have written pd.read CSV, then I have given the path. How can I get the path for the data set? Let me show you. Don't be panicked for that. Everything is super easy with Google Colab, and also while you are working with Python. So you can see that salary.csv you have. If you click on this three dots, if you click over there, you will get an option of copy path. You just need to copy the path, and here you just need to paste it. It's that easy, guys, right? There is no such thing you have to do like so many ways to understand the path. No. Right, so we have written pd.read CSV and we have given the path, and our data will be stored in a data variable. Now if you just want to see your data is loaded or not, what we use one function called .head. What .head does, as the name suggests, it's going to give you the head portion of your data. So what is the head portion of your data? In default, it is going to return you the first 5 rows from your data. So data.head. Okay, right, you can see this is particularly data.head, and your data is uploaded to, or you can say loaded to data variable. Now if you want to see the last 5 variable, like last 5 rows from your data, you can write data.tail, right? It will show you the last 5 rows from your data. So total maybe data you have 34 records you have, and yes, this is the last 5 rows. Now we will see few things. Now if you want to see what are the columns I have in my data set, a sudden question pop up in your mind. So yes, it's not a sudden question. Again, to understand your data more precisely, we need to understand what are the columns we have, what are the continuous value we have, and what is the data type of all the columns. We will see how we can do that. Also, we will have a look at the cleaning data. In order to clean the data, the null value, oh my god, there are a lot of things. So we have used dot columns. So data dot columns is going to return you all the columns you have in your data set. If I just do that, what are the columns we have? Just 2 columns we have for this particular data set. We have years of experience and salary. Now let's check the dimension of that data set. What is the dimension we have for the data set? So in order to get that, what will be my answer? We have to use data.shape, that 35,2. So you have total 35 rows, right? And 2 columns. Okay, yes, this is how your shape is going to return you. So .head already we have done, and now we are going to use data.describe. What describe does? So describe is going to give you the total count of your data. Then what is the mean value, right? Maybe in the case of year of experience or in the case of salary, what is the mean value you have? Then we go for standard deviation. That is in statistics one of the most used term. Then we have interquartile range. Maybe it's a 25%, maybe it's 50%. We have talked about IQR, right? Yes. Then it comes to 75% and max value you have in your data set. right? So we use dataset in order to understand our data more precisely. Now we will go for missing value detection and treatment. If you have missing value, then you have to go for understanding the where you have, and you have to remove them, or you just need to replace them with mean or median, right? So the following values in the dataset are considered to be missing value. What are those values? Blank values, or if you have nan value, or if you have null value, right? Or one more type of value, that is some continuous columns, right, have zeros to indicate missing data. Let's see, do we have something like that? If we have something like that, then we have to have a good treatment for that for our data set, right? So in this case, we have written data.info. It's going to give you the info about your data set. So my year of experience, and there is no null value, and the data type for this wrote 64. And for the salary, we have 35, no null value, and the data type is integer 64. Now, if we want to check again to make sure that do we have any null value, we have to use one function called data.isNull. If you write data.isNull, you can see that for each and every rows it's giving you false, false, and true, right? But I don't want to see like that. I want to see, do I have any null value? Please show that, right? So in this case, what we have written data dot is null dot any. If you have any null value, it will return you true, otherwise it will return you false. So now we do not have any null value, that's why it's returning you false. Now if you just want to see the summation of the null value, how you can do that? In order to do that, you have to write data.isNull.sum, right? So summation will give you, do you have any null value? It will only give you the summation. So you can see the year of experience, the null value is 0, the salary is 0. So basically what we can say, we can easily say it, we don't have any null value in our data set. Now if I want to visualize my data based on salary and year of experience, as we have only 2 columns, but most of the cases you will have lots of columns to again understand your data more. So what we have done, we have written plt.plot, and we have given x and y, that data of salary and data of year of experience. So you can see this is what we get as a year of experience and the salary, right? So you can say for 2, this is near about to 40,000. While you are having a more experience, you are going to get a good salary again, right? Now what we are going to do, we are trying to find it out the expectations, but before that we will try to understand the correlation. So this plot will help us to understand if there is any multicollinearity in the data set, right? How we can do that? We have written PLT is basically matplotlib, plt.subplot, and we have given the figure size 20,10. Now we have given the data dot correlation to understand the correlation between different columns you have, right? Can you see, is it correlated or not? So we have used again heat map from Seaborn, and if we just execute that, you will get us beautiful looking metrics like this, right? This is nothing but your correlation tricks in order to understand is your data correlated or not. So obviously total experience and total experience will be 1 1, and this will be 0.98 0.98, obviously, right? So this is something you can totally understand how it's going to work. Experience, so year of experience to year of experience 1, salary to salary will be 1. So obviously this will be the high correlation, but in the case of this 0.98 0.98. All right, so this is what and how we are going to do the correlation. Now after we have done the correlation, we have to go for making a model in linear regression. But before that, we want to just divided our data set into 4 parts. One is training, one is testing. So basically you have 2 particular, okay, I will show you how can we actually make it 4 parts. For now, we just understand we have to break our dataset or divide our dataset into two parts. One is for training, one is for testing. Now, while it comes to training, we will give our data in the training part to see how our model is working. In the case of testing, our model will not see the data. While we are going to do this particular testing with the new data set, that time only our model will see that. Okay. Now what I have written from sklearn.model selection, I have imported train test fleet. Okay. Just don't look at here right now. Okay, let me do that. Now what I want to do, I want to split my data set. Okay, how we can do that? So before splitting our data set, I want to do one thing. So I have written data.drop. So as we are going to have the salary and the year of expectation, year of experience. So in that case, what's happening? Our data of salary, right, is your like label column. Okay, so we try to predict that only. So we will drop that particular column from our data. So we are going to write data.drop. Then we have dropped salary and we have stored it to X. And now Y will have your salary column, right? So you have understood X and Y. Now if you just write X, after doing this, if you just write X and Y, let me just print X and Y. Print X dot height. So you can see what is X and Y. So your X is year of experience and your Y is nothing but the salary. Let me just do that. So this is year of experience, right? And your Y will be your salary. Yes, so your Y is salary and X is experience. Now we are going to make it 4 parts. But we have 2 parts already. Now we are making X of train. Matlab X train is basically your experience. X X test your experience for testing part. Y train is again for salary for the training part. Y test is salary for testing part. So we have called train test split function and we have given xy. Now we have written test size equals to 0.2. What does that mean? Because you can say that training part you are going to use 80% of your data set and the training purpose you are going to use 20% of your data set. And while we are writing random state equals to 42, it will take randomly data. There is no such rule. The first 80% will go for the training and 20% will go for testing. No, it will take any data from anywhere and it will basically just mix the data, right? So that's why we have written a random state equals to 42. Now, if I just write from sklearn.linear model and if I just import linear regression, then we have called our regression model. That is linear regression. Right, after we called our model, we have written L.fit. So basically, we are going to fit the model with the data set, that is X train and Y train. Okay, and then we have the prediction. Then we have written Y pred equals to L.predict and then X test. Right, so you have given your testing data. Now I will show you what is your, predicted value and what is your actual value, right? So your Y pred will have all the predicted value. Now if you want to get the score, what is the score for your predicted value? You just need to write L.score. It will give you how your model is working and you can say 89% with the 89% of accuracy your model is working. Now if I just do one thing, print actual salary, then comma we have written Y. Y, right? Okay, or we can write Y test. Okay, now here we can write print predicted value, salary, then we can write Y pred, right? Let's see. Okay, so your actual and predicted is okay. Y test. Okay, let me check why it's showing that. Okay. Okay. So let me write y over here. I'm not sure this is uh okay, right. So here why it's taking this. Okay, fine. Right. So we have done this over here. Can you see this is your predicted value? And if I just write the actual salary here, so these are your predicted value while it's talking about that. Yes, can you see? Yes, so this is your actual value and that was your predicted value, right? So this is how we can do the salary expectations based on the experience, right? And this is how we can make a model out of it, and we can do say, okay, if you have experience like this, then my model is saying your predicted value or your expected salary will be this. In this part, as we have already talked about regression, what is linear regression? How can we actually use linear regression technique? And where are the data set you can go for? We have talked about everything. We have done one project on linear regression as well. Now, in this part, we are going to do the UBIT data analysis and we will try to predict the fair price, right? So, what are the library we are going to import for that? NumPy, Pandas, Matplotlib, Seaborn, and also we will import linear regression from scikit-learn, right? And what are the data set we have? We have data set of cabrides.csv and we have data set for weather.csv, right? So these are the data set we have. Now if you just want to talk about cab data height, right, what it will give? It will give you your cab data, right? And we have weather data. So here you can see we have distance, cab type, sorry, timestamp, destination, all these things. Now if you want to see the columns for that, okay, we will do this later. So now if you want to see the columns for that, what do you need to do? You just need to write cab underscore data dot columns. So it will give you all the columns you have in the cab data set. Now if you want to check the shape of the data set, what do you need to do? You just need to write cab underscore data dot shape, right? So you will get total how many columns you have, total how many rows you have. So you have column of rows of 693071 and you have 11 columns, right? This is pretty much big data set, you can see from here. Now if you want to check the weather data set that we have read as well, so in this case you can see let me just show you the weather data set. So in this case we need to write weather underscore data dot height, right? Okay, so you can see this is the weather data set. Now if you want to see more things about the data set, not the text one, I want to have the code one, right? If you want to see the shape of the data set, let me do that, weather dot shape, right? So the weather data underscore data dot shape, right? So yeah, what you will get 6276 data, I mean total rows you have and 9 columns you have, right? Now what I'm going to do here, you can see we have done this column shape, all the basic things is done. Now I just want to change my date time, right? So before doing that, let me describe my data as well. Cab data dot describe, right? What you will get? Okay, let me put the parenthesis. Okay, can you see? For distance, timestamp, price, surge multiplier, everything you get about the describe one. And I know you guys have idea about why do we need to use describe. So yeah, this is about the describe, this is about the info you get. Now I just want to change my cab data date time to actual date time. For that, what I need to do, I have to import date time, and then I have written cab data. From there, the column name date time equals to pd dot to underscore date time. So anything you want to change, you need to use to underscore date time, and then in the parenthesis your name, like which name and the data you have given. Now for the weather also we did the same thing, right? We have changed our date time column into actual date time, right? Now we have done the shape, we have done this. Now what we want to do, we want to go for again description. Here description, you can see this is the timestamp you get, right? The distance, price, surge multiplier you get over here, right? And this is the describe for this. Now if I want to just concat the two data set, right? We just want to concatenate two data sets like cap data and weather data. How to do that? We have just used pd.concat and we have given the two data set, cap data and weather data. And now A will consist of all the concatenation of two data set. Now I have written, now I just want to see my data set. After I concat them, I'm going to write a dot hit. Let's see. Yes, this is my data set. Here I have distance, cap type, timestamp, destination, source, price, surge multiplier. Here I have ID, product ID, name, date time, pressure, rain, humidity, right? So this is what we have done. Now if I just write, want to get the day and the hour, how to do that? In this case, time.dt.day, right? And a of hour equals to, basically we have changed, do this data pre-processing to make our data more perfect. Now if I just want to okay, no, I don't want to fill nan values. Okay, here first I want to show you what are the nan values I had. Okay, it's taking time. Right, cool. Let me just do this again because I want to do this one more time because I want to show you what are the how many nan values we have, right? Let me show that. Okay, after that I just don't want to fill my nan values with 0. I just want to show you a dot is null dot any, right? If I have, then I'm going to use the dot sum function. Yes, I do have lots of null values, then I just want to use dot sum, total summation of the null values. Okay, we have a pretty good number of null values. We can just need to fill that with 0. Let me fill that with 0. Okay, so we just cannot go for so many null values. What we can do, we can fill them with the median or we can fill them with the 0, anything you want to go for. Now I just want to group by the cap type and I want to get the count of that. So total type of cap type, so cap type is Lyft, Uber you get. Can you see? This is your cap type. Now if you want to group by cap type and count, and then if you want to plot the bar plot, yes, this is how you can do that. Dot count plot dot bar. So this is the color code you have for distance, timestamps and all, and this is the cap type you have, right? This is Lyft, this is Uber, right? So you can see this, all the parameters you get for different cap type, right? Now if you want to see the price, how can you do that? What I have written price dot value counts dot plot, then bar, and this is like what color I want. Can you see? This is the price plot, right? The value counts right here. Okay, now if you want to see the hour, like this is nothing but the data visualization we have done. For hour you can do the bar plot, and then here we want to do the plot, like what hour basis price. So this is what we get, like this is the hour, this is the price, and then we have plot them, right? And this is for rain and price. Suppose it's raining and if you want to change, like see the what is the price difference and what is the plot, it's for the data set you have the data points. This is what you get, right? And these are the columns again, you know. Now for making the linear regression model, what are the things I want to take? I want to take distance, temperature, cloud, pressure, humidity, wind, rain, day, hour, surge multiplier and clouds. And for the prediction we are going to take the price. Now from scikit-learn model.selection import 10 state split, we are going to split our data set into two parts, training part and testing part. We have 4 things like X-Train, Y-Train, X-Taste, and Y-Taste. So 25% of the dataset will be test size, and 75% of the dataset will be train size for that. Now I have just written linear.fit, and I have given my X-Train and X-Train and X-Taste. Right? So this is how we have done the linear regression, train the model. Now if I just want to predict, so linear.predict, then you have to provide Y-Train. Now, if you want to check the actual price versus the predicted price, so your actual price is 42, it's showing 32.54. Here it's 32, it's 16. Okay, so there are here and there, like it's here 7.5, it's showing 10. So these are pretty much near, right? You can see 9, 11, 8, 11, 27. This is again some here and there is there, right? So this is what we get for, like, after putting the linear regression. Okay, and yeah, so here you can see we have written the df.head, and you can see here, like, can you see, this is what we have done the data visualization, and this is what the actual versus predicted value you get, right? And if you just want to print the prediction for this, let me do that. Right, so we have done, yeah, these are your prediction values. So we have done our, linear regression concepts. We have talked about diabetes prediction using linear regression, not diabetes prediction. We have done the outlier detection using PIMA diabetes 1, right? And for salary prediction, we have done the linear regression one, right? So we have done 2 projects on linear regression. One is salary prediction using XP, like based on your experience, and one is UBIT data.
Let's talk about the program. Most of the things you've already seen. So let's look at the program now. So what I'm doing here is I'm trying to import certain packages. You all know that, so I'm not going in depth of importing the packages. Once you import the package, the next thing is I'm importing matplotlib to do some plottings. Then there is a data set called as bank.csv, which contains marketing data, right? So I've imported that data here. The next thing which I'm going to do is get some certain basic information. So if you look at the basic information, I've got 10 columns here, right? And the subscribed column is the dependent variable. The remaining 9 are independent variables that we have. And if you look at the data type, it says few are integers and most of them are characters or string, right? So moving little ahead, let's look at the shape of the data set. So it says there are 4,521 rows, and there are 11 dimensions, 11 columns here, right? Okay, let's move on to next. So let's move on to this. What I'm doing here is subscribe, and I just want to see what is the distribution of the dependent variable. Now, if you look at the dependent variables here, subscribed, people who have not subscribed is more compared to people who have subscribed, which is less. And that is exactly what I was talking about earlier, that the data is imbalanced. How will you know? Because looking at the numbers, you'll not get the percentage. So what I've done here in this particular column is that I've tried to put the decimal. So it says that more than 88% of the people have not subscribed, whereas only 11% of the people have subscribed. So data is still imbalanced, right? Okay, let's move on to next. I'm not doing anything to make it balanced here because the intent is different, and intent is to make you aware of the gain and lift chart, which is very important, right? Let's do some basic EDA. If you look at it, of course, there you can see visually that there is an imbalance. So let's move on to next. Let's put some bar plot. If you look at it, just look at the balance. There is another column called as balance, and making sure that people who have got more balance are the one who have actually subscribed to the product compared to people who have got less balance in their account, which is very good. Pretty much clear on this. Let's look at the campaigns, because how many people, how many customers from those have got campaigns done. Previous campaigns, they were part of previous campaigns. So very few, and there are outliers as well. But there are maximum customers, let's say around 4,521, around 3,600 customers or 3,500 something customers were not contacted previously for any, any campaigns. Rest are like one or maximum, then two, then three, and then there are customers who have been part of previous campaigns as well. Now let us look at the bar plot of subscribed in previous campaigns. So can you look, people who were addressed previously and were sent previous campaigns are much more susceptible, or much more, there's a huge possibility that they will say yes compared to those who will say no to subscription, right? Now let us see the distribution of the balance. Now outliers are there. There are a few people who have got huge balances, but most of the people have balances between 0 to around 10,000 approximately, right? So basic EDA, now as I said, there can be huge number of explorations that you can do basis your understanding of the business, of the domain, and your own expertise and your own intuitions. Everyone has got different way of looking at data, so you can have a look at it. I just gave you very basic EDA because that is not the intent here. Now let us build the model. Now to build the model, what I've done is I've listed all the columns and removed the subscribed, because subscribed is nothing but a dependent variable. So what I've done is I've removed that and tried to see. So apart from subscribed, rest of the columns I can see here, and this is what is going to be the columns that I'm going to use for training, right? So now let us now convert the categorical variables. Now understand this. We all know that numerical algorithms understand numerical values. Since some values which are numericals, they don't have to be converted to numbers, but those which are categorical variables, you all must have heard about one-hot encoding. Now to understand one-hot encoding, what we get is there is something called as get dummies. There is a method in pandas data frame, pandas package, where we can call pd.getDummies, and we can give the data set name, which is bankdf, and give all the features. Don't worry, you can give all the features. I'll tell you what is drop first, but you can give all features. It will convert dummies to only those features which are categorical. Features which are numerical will not be converted. And what is it drop first? True. Do you remember, if I have a categorical column called as gender, so I have, let's say, two genders, male and female. Now when I convert it to one-hot encoding, I get only male, right? Female I don't want, because if I just get one column as male, and if it's 0, it simply means that it's a female, and if it's 1, it simply means it's a male. So if there are 5 categories for a particular categorical column, you need only 3 columns for that. I hope you're getting it. So that is why drop first equals true will drop the first column, the one column, and rest will be used as a categorical column, right? So I'm assuming that you've already done it, just explaining it and revising it in a short. Okay, now the description, the dependent variable has yes or no as the values. Let's convert that to a number called as 0 or 1. Right, so there's a function called as bankdf.subscribe is the column name, .map, because you are doing it with every single value of that particular column, and you're converting if there is x equals yes, which is, if it's true, int of true will becomes 1, and int of 0 will become, int of false will become 0. So that is what at the end what you'll get is categorical columns which are converted to dummies, and there is another column called as dependent variable, which is zeros and ones. So now you are ready. You have got x, which is nothing but your training data, and your y, which is again going to be used to your which is your subscribe column. So now you've got independent variables and dependent variables absolutely built. Now we are ready to go ahead with building the model. See, you must have used what we call as scikit-learn, sklearn packages. So what I wanted to use is stats model, because that is yet another model which is widely used for statisticians. So I'll simply tell you the difference between stats model and scikit-learn. First of all, by default, people go ahead with scikit-learn because most of the data scientists are not statisticians. So people like us, people like, most of the people who are from BABI batch, they're more like applied, statisticians, applied data scientists. So if you're a typical statistician, stats model will give you a lot of statistics. But if you're if you're a data scientist, applied data scientist who don't believe much in statistics, but believes much in the values that they get and then predicting the values, of course, sklearn is a better option to go ahead with. sklearn has also got better documentation compared to stats model. But since people blindly use sklearn, I thought of using stats model so that you guys are even aware of this. So during your interviews or anyone who has questions on this, you should be able to answer this. But below I've used scikit-learn as well, so you can have a look at that as well. So let's import this package. And in this package, there's function called as logit. And then you have to first give your dependent variable here. And then there is a function called as add constant. So remember, when we talk about regression techniques, we always have a constant, right? That intercept value that we have. Y equals mx plus c, that constant, right? M is the slope, c is the constant. This c is nothing but a constant here, add constant. So in case of sklearn, it happens automatically. In case of stats model, you have to do it. So the first thing that you give is the dependent variable. The second thing that you give is the data set, the independent variables, and you call a function called as fit. Don't worry on the syntax. This method is available anywhere and everywhere. Simply call this. What is most important is to understand how the models will work. Let's move on to next. And let's talk about the summary of the model that we have, right? So as I said, your sklearn will give you less statistical values, whereas stats model will give you huge amount of values. We'll not get into all of that because we don't have that much time. I also have to take your questions. So we'll simply move on to the most important, which is p-value, right? And p-value is nothing but the significance of those variables that we have here, right? Now, what we have to do is, this is the first iteration, right? What we have to do is, any variable whose p-value is more than 0.05, they're not significant. So what we'll do is, we'll remove all of those values. So what we'll do is, I've written a function here, which you can have a look at. You'll get this Jupyter notebook. But what this does is, this actually takes all the values that we have, p-values, and it will check which value is less than 0.05, only take those variables. So if I run this function, and now what I'm doing is I'm calling this function that I've defined here and passing the model that I've built, and what I'm getting is a significant variable. So now if you see, out of these many variables that were used, what I now have is these significant variables which are actually having impact on deciding the dependent variable. So what I'm doing now here is, I'm creating a list of columns with only this many columns. Now, what I'm doing here is, I'm calling the logit function again. I'm running the logistic regression again. What I'm doing here is, I'm passing the same y, but I'm not passing all the columns here. I'm passing only the columns which are here, right? X of these features, dot fit. Now, if I run this, I didn't run this. Okay. Now what I'm doing is I'm running this. And now let's look at the summary. Now, if you see the statistics, right? All of them are less than 0.05. They are highly impactful variables which can be used. Now, see, I have not split the data into training and test. There is a specific reason in this, that I'm just trying to tell you the gain and lift. But ideally what you can do is, you can simply go ahead, the way you do it in sklearn, you can split the data into train and test. Then you can apply it on train, and then you can predict on test, and then do the gain and lift. But for the simplicity, I've just used the entire data set, and using the entire data set, I'm going to predict as well the train data set only, and give you the gain and lift curve, which is most important here. So see what I'm doing here. Actual is y, which we already know. Now what we are doing is, the model that we have built, I'm going to predict. But what am I predicting? I'm predicting the X features. And what are these X features? The variables that we have seen. So now understand. Don't look at the screen now. Just listen to what I'm saying. What I've done is, I've used stats model. ran the algorithm. I saw that many variables are not significant. I removed those variables, then ran the model again with only impactful variables. After that, I realized, okay, this is perfectly fine. Now I've got the model which I can use for prediction. But because I'm not split the data into train and test. Whatever my model has learned, I'm going to predict the train values only. So all 4, 5, 2, 1 values that I had, I'm going to predict again, but without the y variable. And let's see what happens. So in this, I'm predicting it. And now let's take a look. The probability, the predicted probability, and what was the actual values which we had at the start, right? So this is what we get. So I've still don't look at the code. This is very easy. We have got pd.dataframe function method, which you pass to variables. This is the column name, and this is the values that I'm going to have in these columns. So that is what I get. Now, I'll tell you one thing. Trust me, there is a single method which can give you gain and lift. But I wanted you to learn. So I have actually done the gain and lift work on my own. I've written functions which will calculate those values so that you understand. And then I'll tell you the one line code which can do all of that in a very easy way. So now understand now what has happened. I have got all the subscribed column, zeros or ones, actual values. And besides it, what I've got is the probabilities of all the actual values that I have got there, right? The probabilities. Now what I have to do now next is sort this data frame basis the probability in descending order. So that's what I'm doing here. What I'm doing here is I'm sorting the values in a descending order. So just take a look. I've sorted it. Now if I just print it, I'll just print it and I'll show you. Just take a look. Now, predicted probability, what I've done is I've put it in a descending order. So the maximum probability is 0.86. And if you keep on going down, the least probability is 0.000498. Now, once you put it in a descending order, the next thing that you have to do is you have to divide the entire data set that you have just predicted into 10 equal sections or 10 equal deciles. So this is what I'm doing here. So I'm getting the length of the entire data set, which is 4521, dividing it by 10. And now what I get is this. So what I'm saying is every section, the 10 sections that I'm going to get, every section will have 452 records, right? So till here it is clear. Now there is a function called as get deciles. Now what I want here is, take a look. This is a function. I'll tell you what exactly it tells you. See. Now what I want is, I want to name. See, I'll tell you what has happened. If you look at this, I've got the highest probability, right? In that form, I've got the actual values. Now I want to give sections to it, that which record belongs to which decile. So there are 10 deciles now. The first 452 will belong to decile 1. The next 452 will belong to decile 2. The next 452 will belong to decile 3. And that is what I've done using this function. So you can have a look at it, this function. It's a simple Python function which simply gives names to all those deciles. So I've just given this column as 1, 1, 1, 1, 1. After 452, trust me, you'll get 2, 2, 2, 2, 2. For the next 452, for the next 452, you'll get 3, 3, 3, 3, something like that. Now let's talk about gain and lift. So what I'm doing here is I'm creating a data frame, and then I'm doing a group by basis deciles, because what I want is, I want to check. Now listen to this carefully, because this is very confusing. Listen to this carefully. Look at this data set, right? And understand one thing. What I want is in the first decile, that is in the first 452 records, how many ones I'm getting. Is that clear? Listen to it again. In the first decile, which is in the first 452 records that I have, how many ones I'm getting. So if you look at it, 1, 2, If you keep on counting for the first 452 records, you'll get some number of ones. Now, next, I'll count another 452 and I'll see what is the number of ones. Another 452, I'll see how many number of ones. I hope you're getting it. So now let's take a look. So this is what I'm doing here. Now, once I'm done that, right, let's print this so that you understand what I'm talking about. So gain underscore lift underscore df. See, in the first deciles, there are 125 customers who have said yes. Second decile is 83, third decile 73, fourth decile 53. So if you look at this gain, right, you can see that as and when we are moving towards lower side, we are getting lesser and lesser customers who are converting to yes, which is excellent. Now, looking at it will not give you much better clear-cut indication. Of course, it is giving the idea of what I'm trying to talk about. But what I want now is, I want to see cumulative percentage. What does that mean? In the first, it is 125. By the time you have marketed 20%, which is 452 plus 452, 452 plus 452, by that time, you might have got 125 plus 83, which is nothing but around 8 to 10, 208. So just in 20% of the records, you'd have got 208 customers who will have high probability of getting converted. You're getting what I'm trying to say, right? So we want cumulative values. So at 2, you'll be having 208. At 3, you'll have 281, something like that. So let's do that. So what I'm doing here is, I'm doing that only here. So now if I just print it, you will see what it means. Look at this. In the first decile, almost 25%, 24% of the customers you've already attended, right? By the time you cover your second decile, 20% of the customers you have marketed, you have covered 40% of that. So by the time you reach fifth one, you've already covered 70% of the customers. By the time you reach sixth decile, you've reached 80%. So by the time you called 60% of the customers, you have got 80% of the revenue. So if you don't have time, you have not missed much. So as per the rules, as I said, this is little lesser compared to what we generally get. There can be a situation where by fourth itself, you'll get 80% or 90%. So if you are in a very good situation, very good shape, of course, in the fourth itself or fifth itself, you might get around 90%, 85% data. So you are pretty much sure, okay, I'll target only those first 3 or 4 deciles, rest I can ignore, right? So that is the main purpose. And that is what is gain percentage. Cumulative gain percentage tells you, which at the end becomes 100%. So that is called as gain. How much you are gaining once you keep on moving your deciles, right? Now visualize the same using a plot. So take a look. By the time you reach 6th decile, you would have covered almost 80% is what it says, right? So that's what it is if you want to see it visually. Now there's something called as lift. I'll tell you what lift means. See, what lift means is, look at the formula, gain lift percentage. What does this mean? We will keep on moving down, 23, 39, then 53. We'll keep on moving. And what we'll do is, we will divide it by gain lift df dot decile into 10. So what does this mean? In the first decile, it will be 10. So it's in simple terms, you are getting 23.99. In the first decile, it will be 10. So the lift will be 2.399 because 23.99 divided by 10 is 2.33. Come to this. Now, by the time you are done with this, you have covered 20% of the deciles, right? So 39 divided by 20 will become 1.9 something. Come down here. 53 divided by 30. So that tells you lift, which simply means that by the time you reach to 30%, trust me, by that time you would have 1.5 times more chances of getting a customer than if you don't apply a model. So if I look at this, right, 2.399, what does this mean? If you don't apply any model, I'll get, let's say, one customer, right? Example there, I'm just giving an example. I'll get one customer, but if I apply this model, in the first decile, in first 452 customers, in the first 452 customers, randomly taken, right? I have got 4,521 records in totality. Out of those 4,521 total records, if I randomly take 452, how many customers I'll get? Around 45. But because that's random, right? Probability. But if I use this model, what I'm getting is 125, which simply means that there is a strong chance that if I use this model in the random chosen for the random chosen 452, I'll get only 45. But if I apply this model in the first 452 itself, I'll get 125 conversions. What is the multiplication? What is the chances? How many times the chance of getting the customer is higher when you move the deciles compared to not moving the not using the model. So if you look at it, right, you'll get far better results. Look at this. In the first decile, there is a 2.4% chances of getting more customers. So by default, if you get 10, you'll get 24. You're getting it? If you use this model, out of those 100 customers, let's say, if there is a chance of getting 10 without using model, with using model, you get 24. Right? So of course, if you keep on coming down, here it will be lesser. But doesn't matter, right? Because that is what we want. We want to reduce the cost by targeting lesser customer, but gaining as many conversions as possible. And that is the beauty of this model, which is highly and widely used in marketing area. So the same thing can be done using sklearn. So you all must be aware of it. I'm simply running this and telling you that the predictions can be done using what we call as sklearn as well. So simply whatever I did there, I'm doing the same thing here, right? So there's no code change except that I have used sklearn. And now if you look at it, you'll also get the lift and gain. See, stats model and sklearn slightly might give little difference, but not huge difference, I would say. They both are models. They're using same data set. So definitely the algorithm will give you almost the same output. Going a little fast. Now these 3 points are important. I did a lot of things, yeah, like creating deciles, creating those gains, lifts. I wrote all those formulas. But there's something called as a scikit-plot package. If you plot it, you just have to give 2 things: your actual value and your predictions. That's it. You just have to give your Y and prediction. Your skplot matrix has a method called as plot cumulative gain, which will automatically do the sorting, which will automatically calculate the gain, cumulative gain, and will plot the value, something like this. It looks far better than the one which I used. And because this is written by proper Python developers with a lot of things keeping in mind. So, but I wanted to give you those insights so that you know how exactly that is calculated when you want to do it. But here, look at this. This is interesting, right? If the more it is higher here, something like this, the better it is. But still, it is better than this line. If you randomly go, it will be 40%, 45% exact, right? But if I use model, by the time I reach 40%, I would have covered 60%. By the time I reach 60%, I would have covered 80% of the customers. That is what it says. And simply one line for lift curve, and this is what you get. Something like this. So you can use this. Anyways, you'll be getting this notebook and the PPT. So you can pretty much have a look at it and play around with this much more. But trust me, guys, this is something which is most important when it comes to real life industry. If you're into marketing domain or highly imbalanced data set, and if you want to cater more towards the minority, you can pretty much go ahead with gain and lift curve, which is very widely used, but in a very specific area, and hence not much taught in academics generally, because as I said, not used in most of the industries, but heavily used in a specific industry, and that is the advantage of it. Why conditional probability is not applied to LR like we are using in Bayes for LDR? See, naive Bayes is something like, see, naive Bayes or conditional probability is much more used in case of text analytics, or when we are actually doing text analytics. Having said that, it doesn't mean that conditional probability is not being applied in other areas. But remember one thing, it is always the probabilities of every single variable independently that we are taking care of, right? Naive Bayes actually says that we do not consider that all the variables are dependent. In fact, they say that all the variables, we are trying to calculate what is the impact of every individual variable on the dependent variable. And then what they do is they multiply all the variables, all the probabilities of all the variables and their contribution towards the dependent variable. That is what is called as conditional probability. Now, when we talk about logistic regression, right? Anyways, we are taking into consideration all the, all the independent variables which are impacting variables and trying to see their impact on the dependent variable, how much values they're adding to it. Now, it is kind of conditional only. I will not say that it is absolutely conditional, but if you look at it in a different way, just imagine, I'll give you a very simple example to understand this. Imagine that a pregnant lady goes to a doctor, right? Just understand the conditional probability and you'll understand what I'm trying to say. When you go to a doctor, a pregnant lady goes to a doctor and she has got a lot of, dependent variables, let's say, independent variables. And now doctor has to identify whether the woman will have an abnormal child or normal child. Very simple dependent variable. The child which is about to come in the world, is that child going to be an abnormal or normal? That is a prediction that you want to make, right? There are n number of columns: sugar, head size. There are a lot of, I've seen it in real life, and I'm giving this example. Now the point here is, just imagine there are 10 independent variables. Every variable will have some contribution towards the prediction of the dependent variable, whether the child will have abnormality or not. Let's say head size is more. Okay, there is a chance that the child will be abnormal, right? But what is the percentage? Absolutely based on the huge number of records that we have now. And that is the pattern that your algorithm will learn. But understand this now. There are 10 independent variables. Now, suppose the lady goes there and asks, and doctor says, you have 0.01% probability of getting an abnormal child, right? Great. Now, there is another variable got added. Now we had 10 independent and 1 dependent. There is another variable got added called as previous child's abnormality. And there is another column got added. And if the same lady bases those 10 columns, the probability was 0.01. But the moment lady says that I have another child, I have one more child who was abnormal, you know what is going to be the probability of getting abnormal child? It will be around 51, 52%. So don't you think the conditional probability has been there? See, as I said, every variable has got contribution towards defining your dependent variable. Every independent variable has got contribution. And that is what your model learns, right? It learns for every variable, and then contribution of all those variables is something that goes and decides whether the person will have a child will be abnormal or not abnormal, right? Moving on to next is high dimensional space means how many of independent variable. See, that is something which you cannot just, there's no number as such which has been given. But if you have, sometimes you have got hundreds of variables or 90 variables or 80 variables, 50 variables. So those are there I have got high dimensions. Still, if you want to go ahead with logistic regression for some reason, then you have to reduce the dimensions by using PCA, principal component analysis, or you have to do feature engineering, feature extraction, feature selection, right? There are multiple techniques using which you will try to reduce the dimensions. Feature engineering is one of the most important things that you have to do in order to play around with the dimensions and making sure that you're not eliminating those columns which are highly impactful, and still you're able to reduce the dimensions. So as I said, 10-15 variables are good enough for logistic, which I have seen with my experience. Don't quote me for that, but basis my experience, 10, 15, 20 variables, you can go ahead with logistic regression. More than that, and if you have more than 30 or 300, 400, column rows, then you can go ahead with logistic. So as I said, most of the data sets that we get in real life, and trust me, I've worked on, many data sets in my life in data science, and then maximum data sets were messy, and imbalanced. Then what is the meaning of imbalance? Class distribution is not uniform. If you look at the diagram, the picture on the right hand side, if you see there is a two class, 0 and 1, it could be malignant, benign, it could be cancerous, non-cancerous, it could be defaulters and non-defaulters, anything. Now if you see in approximately 2,70,000 customers, along 2,70,000 customers, around 260,000 customers are non-defaulters. Only 10,000 customers are defaulters. Now, if you look at it, you'll understand there's a huge imbalance. And the problem with such kind of data sets is that when you start building a model with such kind of a data set, trust me, your model will overfit. It will try to learn. It will try to predict everything as class 0. Now, what to do in such cases? Because see, you can't run away with this kind of problems. You have to solve this because this is a real data set where you have to give some insights, something to the end user, to the client, and then you can't just say the data is imbalanced, so we can't do anything with it. Now, I've given certain examples. If you see cancer data sets, marketing data sets, where you are going and marketing your product to, let's say, 10 lakh customers, and out of those 10 lakh customers, you see only 10,000 customers are coming back to you to go for the product. Now, marketing to 10 lakh customers and getting 10,000, look at the amount of data that you get, the classes, returning customers and non-returning customers, or conversion and not converted customers, right? Huge imbalance in the data that we get. So in such cases, accuracy is very much irrelevant in such cases. I'll tell you a very simple example. Let's say cancer data set is there, and then you have 10,000 patients. Out of those 10,000 patients, you have 1,000 patients, or rather I'll say 100 patients who are cancerous out of 10,000. Now 100 patients out of 10,000 is just 1%, right? Now, if I give you a data set, if I tell you to build a model on this, and you build a model, you get 98% accuracy. You will be jumping in a joy saying, oh, wow, you know what? I've got 98% accuracy. But you know what? Even without a model, if I blindly say that all the people, all the patients are non-cancerous, trust me, I'm still 99% accurate, right? So what is the point of building a model and getting an accuracy of 98%, right? When without building a model, blindly if I say that all my patients are non-cancerous, I'll be 99% accurate. So accuracy does not hold any importance when it comes to imbalanced data sets. What matters in that situation in cancerous data set is how good are we to identify people who are having cancer are identified as cancer. We are not worried about the accuracy. We are worried about how accurate we are in identifying those people, those patients which are cancerous. If you are able to predict that well, trust me, your model will have some value because it will save some patient's life. Accuracy in such cases does not matter, and that is what the fourth main point says, right? Specificity and sensitivity is more important basis business objective, as I said. That is called as type 1 and type 2 errors that we talk about. Now, predicting algorithms with imbalanced data set will always be biased. As I said, if you build a model, simple model using logistic or random forest or anything, and if we have imbalanced data set, it will always be biased. It will be mostly predicting the values which are majority and which is your 0. So we have to do something to deal with imbalanced data set, which is not part of this session, just because this session is of 1 hour. Try to keep that aside, but there are some techniques, sampling techniques, which can be used to deal with imbalanced data set. For example, you can use upsampling, where you will increase the lower class by duplicating it, or you can use lower sampling, where you will reduce the majority class, so that there is the ratio will become little better compared to the initial data set that you get. Or you will try to use smart techniques, where you will try to synthesize data in the minority data set using KNN algorithm. So dealing with imbalanced data set is something which you will come across when you are working in industry and working on a real problem in life. Let's not get into this. As I said, I've briefly talked about it. Let's move on to next, which is lift and gain. So this is most important thing which I'll talk about today. Lift and gain, what is that? So I'll talk about a scenario where there's something called as 20-80% ratio, right? And what is the meaning of 20-80% ratio? Is that, imagine a scenario. I'm talking about this first case study, and then coming back to lift and gain, right? So understand a case study first, and then we'll go back to that slide. I have taken this case study from my own experience and a real data set. A real data set as in real use case. When I was working with one of the banks, I will not mention that because that is confidential. So I've just kept XYZ Bank. But there's a direct marketing data set that I have. So just imagine that we are marketing and the marketing calls are being made through calls, right? Just understand this case study. I'll give 5 minutes on this so that you understand the case study well. Now, the most important thing here is that I have a bank which is launching a product for which it wants people to subscribe for the product's demo or anything of that sort. Now, let's say I have to target 10 lakh customers. Now I have got 10 lakh customers with me at the data set of 10 lakh customers. Imagine how many manpower will I need to do telemarketing to those 10 lakh customers, and just imagine what will be the conversion rate. If I go ahead with 10 lakh customers, and if I make my conversion rate is, let's say, 10,000, it is so less, right? Around 1%. 10,000 customers from 10 lakh is around 1%, let's say, for example. Now, the expense that I will incur of marketing, sending an email, calling to those clients, multiple times maybe, will be, let's say, 10 rupees per customer. So I'm investing 1 crore rupees as an expense to market my product to all those 10 lakh customers, which also needs a lot of manpower, right? Now, out of those 10 lakh customers, I get 1,000 customers as the 1,000 customers. So let's say 10,000 also. I'll get only 10,000 customers. And suppose if I earn only 1,000 rupees or 100 rupees per customer, imagine the expense that you incurred and the revenue that you're getting. If your customers are buying your product, the difference is nothing but your profit. Now, is it possible or is it feasible to make calls to 10 lakh customers in short span of time? How much work power you'll need? In spite of that, can there be a model which can actually work on 80-20 principle, something like that, wherein we say that we will target only 20% of the customers. So if you have 10 lakh customers, I'll only target 2 lakh customers, where I'll get 80% of the conversions, which is nothing but, let's say, 8,000. Now, the advantage here is that I'm spending on 20,000 customers only, and I'm getting 20,000 customers only, let's say, as I said, and then getting the expense will be much lesser here because I'm targeting only 20% of the customers and I'm getting around 80% conversions. Yeah, the only loss is that the remaining 20% customers which could have converted belong to that remaining 80% of the customers. But that is fine because the amount that I was getting from those 20% customers which might convert was much lesser than the amount which I was spending to contact those 80% customers. So now the objective is to reduce the expense by targeting only those customers who are high likely to subscribe using predictive model. This is a very interesting use case, which is, trust me, highly used in case of marketing campaigns. Let's try and understand in one line. If I have to summarize this, if I've got huge number of customer base and the conversion is less, we will try to target only those 20% of the customers who are high likely to convert, and we will not target the other 80% of the customers from where 20% of the people will convert. So that is what is the ultimate target. But how will you do it? Logistic regression gives you another way of looking at modeling the things and evaluating it and putting it in such a way that you can actually target less number of customers and you can get more and more number of conversions. So let's talk about lift and gain for 5 minutes, and then we'll move on to the practical of it. So lift and gain is nothing but, if you look at the gain chart, forget about this content which I've written here, you can just read it out. But if you look at the chart here, right, if you look at it, initially the first 20% itself will give you 80% of the customers. Remaining will give you remaining 80% of the customers here will give you only 20% of the revenue, is what it says. Otherwise, if I simply go blindly, this is what is the distribution, which is equally, let's say 1 lakh, 2 lakh, because I've distributed this into 10 deciles. So if I go ahead with this, right, I'll simply get, let's say, 1,000 first 1 lakh, 1,000 another 1 lakh, 1,000 customers another 1 lakh, because that is a random distribution, right? 10,000 of 10 lakhs is 1,000 per lakh. So this is the simple, without using any model. If I simply understand based this the probability, this is what is going to be the. So if what it says is, if I call 50% of the customers, I'll get around 50% of the conversions, which is 5,000. But if I use logistic regression and proper gain lift chart, we will be doing this. 20% of the customers, we will cater 80% of the customers conversions by calling just 20% of the customers. And lift is that if I make a call to the first 10% customers, there is a 4.5% more chance that I'll get customers who will convert. If I make a call to, let's say, 20%, this between this and this, there is a 4, like, look at this, 4 times more chance of converting the customer than if you call at this point compared to this, because this is exact one. The target is very simple. Understanding in one line now. I've got huge customer base. I cannot spend a lot and calling all those customers. I want data scientists to come, do something with these 10 lakh customers, and then put these 10 lakh customers in a descending order of something, whereas the first 1 lakh customers will give you much more conversion, second will give you little lesser, third will give you little lesser. So the first 3-4 sections will give you maximum conversions, so you don't have to look at the rest of the customers, and you can pretty much bear with the minimum loss, minimum conversions that you might skip. So let's move on to the practical of it.
In this part, we are going to talk about K-means algorithm implementation in Python. How to do that? How we'll actually implement K-means in Python. So let's have a look at how we will start with K-means algorithm. So let's have a recap of how K-means works. So the first step, as we all know, need to specify the number of clusters, that is K, need to be generated by this algorithm. Then the step 2, next randomly select K data points and assign each data points to a cluster. In simple words, classify the data based on the number of data points. Right? What is number 3? So number 3 will compute the cluster centroids. We need to understand what is the centroid of our cluster. Then the fourth step is keep iterating the following until we find the optimal centroid that we have seen in our presentation, which is the assignment of data points to the cluster that are not changing anymore. Right? And there are few subpoints if we want to look into, then the first sum of the square distance between data points and the centroids would be computed. Then now we have to assign each data point to the cluster that is closer than the other clusters. Right, that we have done. That is basically we are trying to calculate the centroids. At last, compute the centroids for the clusters by taking the average of all data points of that cluster. Right, so these are the steps we have followed when we have done this particular process in presentation. Right, so K-means follows expectation maximization approach to solve the problem. The expectation step is used for assigning the data points to the closest cluster, and the maximization step is used for computing the centroids of each cluster. Right, so we know all these things before as well. Just to recap, to understand K-means in a more concise way. So now we will have a look at what are the libraries we are going to use over there. So we are going to use Matplotlib, Seaborn, NumPy, and sklearn. Now you will ask me, what are these libraries used for? Let me give you a quick heads up on that. So basically, Matplotlib and Seaborn are used for data visualization. There is one more question. If Matplotlib can do the data visualization, then why do we need to go for Seaborn? Because Matplotlib is a very basic library. So in this case, if you want to do some kind of a advanced data visualization, you have to go for Seaborn. And Seaborn is basically based on Matplotlib. Right, so you can understand for this time being that Matplotlib and Seaborn both are required for a proper data visualization, presentation. Okay, now we will have a look at NumPy. So what is NumPy? NumPy is nothing but numerical Python. We use for numerical purpose. Then comes sklearn. What is sklearn? This library is known as scikit-learn. basically for machine learning techniques. In this library, all the algorithms are implemented, and also we can use them by calling them their name. Right? So basically, you don't need to do anything and you don't need to write an algorithm from the scratch. The scikit-learn library makes our life easy. Now we will going to do few things. First, we are going to generate a 2D data set which will contain 5 different clusters. How to do that? For that, we are going to import make blobs from scikit-learn. So we have written that from sklearn.dataset.samples generator import make blobs. Right? So this is how we have imported our library. Now we are going to making our data set. But wait, we need to talk about what is make blobs. So if we go up, the make blobs is basically generate isotropic Gaussian blobs for clustering. Alright, so in sample we have few parameters on this particular function. The in samples is basically it is the total number of points equally divided among clusters. Right? Then we have in features, the number of features for each sample. Right? Then we have centers. So basically centers are nothing but the number of centers to generate or the fixed center location. If in sample is an int and center is none, 3 centers are generated. If in samples is an array, like centers must be either none or any other length of equal to length of in samples. Right, so this is how we actually decide our centers. Then we have cluster STD. Why do we use cluster STD? Because this is the standard deviation of the clusters. Right, then we have shuffle, we have center box, random state, reproducible output, return centers, all these parameters. So we can look into it and you can start using according to your uses. Now what we are going to do, we are going to do a very basic make blobs. So in this case we have written that x and y equals to make blobs in samples equals to 400, centers equals to 5, cluster standard deviation which is known as cluster STD equals to 0.60, and random state equals to 0. But what is random state? Random state is basically determines random generation for dataset creation. Right? If we do that, and then we are going to see what actually dataset we have made. For that, we are going to use a data visualization tool, which is Matplotlib we are going to use for this particular purpose. And we are going to use a graph, data visualization for dot scatter. So we have written plt dot scatter, and then we have provided our data. If you just look into it, you can see this make blob is total 5 clusters we have. The different data points you have. Now using k-means, you need to understand how you can actually make them in 5 particular clusters. Now what we need to do, as we have seen, we have 5 different clusters. By looking at the dataset, we can say next make an object of k-means along with the providing number of clusters, train the model and do the prediction. How to do that? We are going to call k-means function, which is basically where our k-means algorithm is implemented. So in this case, you can see we have used a variable called k-means, and we have written k-means and the cluster equals to 5. So we have 5 cluster. Now we have written k-means.fit x. So whenever we are going to use .fit function, it's nothing but it's actually you are going to train your model. Then what we are going to write, we have written y k-means equals to k-means.predict s. So in this part, we will try to predict our k-means, the x. If we do that, the plot and visualize the cluster center pick by k-means Python estimator. Now if we just try to understand the what actually our model has done. In this case, what we need to do, we are going to use that plt.scatterplot again. Here, if you can look over here, you can see that we have written centers equals to k-means.cluster centers. Right? So in this case, you can see what we have got. We get all the centers of the cluster, and total cluster we have total 5 cluster. So this is a very basic example of k-means clustering, how you can start up with by starting with make blobs and then try to give centers and feed your model with k-means and then try to find it out all the different cluster in your data set. We are going to do one more example of k-means using a data set. But that data set we will actually load from the scikit-learn library itself. right? So here also we are going to use Matplotlib, Seaborn, NumPy, and scikit-learn. So here what we have done, we have load the digit dataset from sklearn and make an object of it. Dataset is having basically 1797 samples with 64 features, right? So let's have a look at how can you load the dataset from the library itself. So for that, we are going to import from sklearn .datasets import load digits, right? And digit equals to load digits, right? So if you do that, then you can see your dataset will be already imported. Not even imported, it's already loaded, right? So now if we just try to understand digit.data.shape, what is your shape of the data, that time you can understand your data.shape is 1797 rows you have and 64 columns you have, right? So we use .shape function to understand our data. In this case, there are few columns will be there, the images will be there to understand our data. What actually we want to do with this? We just try to understand what are the digit it is. So basically, we will try to segregate the digit like 1 to 10, right? Using this data set. Now, if you want to check this, right, if you want to check this out, you can see this is nothing but numpy.ndarray, right? The data is type of numpy.ndarray. Now, what we need to do, we are going to do the same thing. We are going to call k-means clustering. Here, how many clusters we will have? We will have 10 clusters, 0 to 10. So total number will be 10 clusters, right? So the number of cluster will be 10 and random state equals to again 0 we have used. Now, what we need to do, we need to train our model. How to do that? Clusters equals to k-means dot fit predict then digit dot data. So why we are using dot data? Basically, it's going to give you all the data itself, right? And after that, if we just try to understand the shape cluster centers dot shape, that time it will show you that 10 clusters with 64 features. If we do that, you can see this is 10 clusters with 64 features. As we have said that our total cluster will be 10 and the feature will be 64, right? As we have few 64 columns. Now, if you just look over here, what we have done, we have used few data visualization technique to understand our data. In this case, we use fig and ax plt.subplot. It's basically we will have different plots in one plot, right? And after that, we have written k-means dot cluster centers dot reshape, and we have reshaped the cluster centers to 10, 8, 8, right? Then what we have done, we have just used dot imshow. This imshow basically we used from Matplotlib to actually see the images, right? You can see these are the images we got. We have 4, 3, 1, 1, 9, 0, 7, 6, 5, 1. This is your data set, right? With the match the learned clusters labels with the true labels found in them. Okay. Now what we need to do, we are trying to do a stats. We will try to do some statistical visualization. So in this case, we have imported scipy.stats import mode. Right now, what we have done, we have just written np.zeros like clusters. Then we have just used a for loop to check like what is the mass, what is the label, what is the data set, right? After that, what we have done, we try to understand the accuracy of our model, how our model is going to work, right? So in this case, we have used accuracy score from scikit-learn. So we have written accuracy score and then digit.target and your label. So basically what we are doing, we will try to give our data, not the label, right? So as we don't give the label, so when we try to predict, that time we understand what label our model is going to predict for this information. If it's correct, then obviously it will be counted as a correct one. Then the accuracy score will be high. So in this case, we did the same thing. You can understand our accuracy score is 0.795. So basically it's nothing but 79.5%. So near about we can say it's 80%, right? So our model is working pretty fine, but you can use this particular concepts with different data sets as well. It's a very basic data set to start with for k-means clustering. In this part, we are going to use a mall customer data set to do the k-means clustering, right? So we will try to cluster the same type of customers according to their maybe income and spending score, right? So before starting with the project, let's have a look at the data set, what we have in the data set. If we just go to the data set, you can see this is our data set, right? I have taken this data set from Kaggle itself. So it's a free open source data set. Basically, anyone can use it. Okay. So here you can see we have customer ID, the genre, that is the male or female, age group, right? We have annual income, total in dollar, right? You can see the total annual income and the spending score that we have, right? So if we look at the data, basically we talked about the data set without label and with label. So in this case, you can see in this data there is no label. So basically our k-means clustering is trying to cluster the customers according to these informations, right? So this is pretty much about the data set we are going to use for this project. And let's have a look at how we are going to do this in k-means clustering. So we are going to again use NumPy, Pandas, and Matplotlib and Seaborn, right? So we are going to use pd.readcsv function. As we know, we use this function for reading the comma separated value, that is your .readcsv. And if you are new to the Google Colab, you can see here is an option to upload, right, from uploading session storage. But be sure the session storage will stay for 12 hours. After that, everything will be deleted, right? So whenever you are going to use Google Colab, try to save your data in your or mount your data, right, with Google storage itself. Now comes this uploading data. If you click over there, it will directly automatically take you to the uploading part from your local system, and from there you can directly upload your .csv file. Now you need to have the copy path. So where will I get the path for this particular data set I have uploaded? If you can look at this sign, if you click over here, you will get the option of copy path, right? So for after that, pd.readcsv, and you need to give your path, right? Your path is content / mallcustomers.csv, right? So now you can see if I just do this, the data set will be already stored in the data set. The variable called name is data set. Now, if you want to check is your data set is stored or from the .csv file or not, you can go for using .head function and .tail function. So what is .head function? So .head function is basically going to return you first 5 rows of your data set, right? So data.head. So if you look at here, you will get the customer ID, genre, age, annual income, and spending score, and your data is already uploaded, right? Your data is stored in dataset variable, which is a type of data frame. Now we are talking about the tail as well. So basically, if you just write dataset.tail, right? So if you just do that, in this case, what you will get the last 5 rows of your data set, right? You can see 199, 198 like this. Now, if you want to check the shape of your data, how many columns you have, how many rows you have, you just need to write dataset.shape function. Right? If you just write dataset.shape function, it will return you the total number of rows and columns in your dataset. So for my case, 200 rows I have and 5 columns I have. Right? So now we are going to do the dataset.info. So what is dataset.info? It's going to give you the information about your dataset. What type of information it's going to give me? So basically, what is the data type of your each column? Do you have any null value or not? Right? So these are the things you can understand by using .info function. Yeah. After that, we have one more function called .describe function. But why do we need .describe function? We need .describe function to understand the few statistical terms in our data set, like the count, what is the mean of your data, like for each and every column, what is the standard deviation, what is the IQR interquartile range, right? We basically divide our data set into 4 parts, right? 25 percentile, 50 percentile, and 75 percentile. Right? So IQR is basically taking the third part of the that is known as third quintile and the first quartile, right? So basically we use these two to calculate IQR, right? So basically these are the basic statistical term you need to know when we talked about our data set. So that's why we use .describe function. After that, if we need to check is there any missing value we have in our data set, but why do we need to check it? We need to check it because if we have missing value and if we do the prediction with this missing value, our data is not at all perfect to go for a analysis. And if we do that, we will get a very bad result. We will end up with a very bad prediction. that we don't want, right? So that's why for the precaution, we always try to check what is the outlier. Do you have any outlier in the data set? Do you have any missing value in the data set or not? So in this case, we are going to use a function called dot is null function. And then we have written dot sum. So basically, we are going to check if is there any null value we have in our data set. Is if we have that, what is the number of that? Then you can see the sum of the null values is 0. So we can see we don't have any null value in our data set. Now, if you want to check what are the columns you have in your data set, how to do that? In this case, you need to use dot columns function. If you just write dataset dot columns, you will get all the column you have in your data set. Right? So now we are going to do the clustering based on the annual income and spending score. So we will try to use annual income and spending score, right? Not the age and the customer ID is not needed anyway. The genre and the age, maybe we can do. Let's see, maybe in the, first let's try with the annual income and spending score. What is the annual income and what is the spending score, right? So in this case, how to take it? We just use this, like if you want to take two particular column from your data set, you need to do this like this, like not the two. If you want to take many, so that time also you just need to use this particular technique, right? So in the data, what we have now, if we just look at the data, we will have two columns. One is annual income, one is spending score. So if you just try to understand your data dot shape, in this case, again, you will get the same thing, right? So 200 columns with, just let me do that, data dot shape. Okay, so if we do that, you can see we have 200 rows and 2 columns. Now I just want to only the values, not the column name. That time you just need to call dot values. You will get all the values, not the column, right? You can say this is your value. Now we always assume the max number of cluster. Now we will do the clustering. So we always assume that the max number of cluster will be 10. You can judge the number of cluster by doing averaging. But in this case, we will try to find it out what is our K for this particular data set, because we don't want to take any random assumption for that. Maybe you can do that, but in this case, if we just use this particular elbow method to understand the K value, let's have a look at now. So in this case, we are going to import K means. We will going to calculate the WCSS, and for I in range 1 to 11, we are going to say, like from 1 to 11, why we basically try to take 0 to 10, the 10 clusters, right? So we have written K means underscore clue equals to K means in cluster equals to I, right? So your I will go 1 to 11, okay? And this part maybe you can skip as well. So random state equals to 42 for 56, and then we will feed our data. So if we do that, and if we just try to plot our elbow method, you can see it's actually showing the elbow is the 5, right? So 2, 3, 4, it's not there, the 5 one. So in this case, this curve is telling you that the elbow comes at K equals to 5. So that matter, the range we select, that's why 1 to 21 also will say the same behavior, right? So basically, we try to understand this particular elbow in the curve to understand our K value. So in this case, the curve, it comes from 5. Now, what we need to do, we are trying to do the K means clustering that we have done so far. So we know our K value. So we actually prefer to finding out the K value. Otherwise, maybe you need to start from 1 to 10 to understand which one is working for you. We don't want it, right? So in this case, we are going to use elbow method. So this elbow method is basically helping us to start with K value. Now, as we see, the K means, we are going to call the function called K means and cluster equals to 4. Here we are going to write 5. Right? So as we can see, its cluster equals to 5. Now the random state equals to 4, about 42. Maybe you can change it accordingly. It's just randomly changing your data. All right. And then we are going to use K means dot feed predict X. Right? Now, as we have done this part, right? So now we try to visualize our data. How to visualize our data? We are going to use a scatter plot, and there we are going to use this. We have actually give some different colors to show our data, right? We have pink, yellow, red, orange, magenta, right? Maybe something else. Maybe you can give green as well. Maybe we are going to give green. So you have total 5 cluster, right? And the centroids we have given, that is yellow. No, which will not work. So in this case, maybe we can give the centroids will be orange or violet. Maybe it will highlight it. Yeah, you can see, right? So in this case, what we have done, we have used 5 clusters. We have 5 cluster that we have talked, and their key means dot clusters, and we have used the centroids. We try to find it out as centroids as well, and we give the centroid color is violet. So if you look at this, you can see there is a 1, 2, 3, 4, 5 clusters, and they try to separate the data points as well. This is the cluster 1, 2, 3, 4, 5. So cluster 1 is pink, cluster 2 is this one, this yellow one, 3 is red, 4 is again yellow, and 5 is green, right? And these violets are the centroids, right? So this is how our clustering, K-means clustering works when we don't have the label in our data sets, right? I hope you like this particular demo, and we have covered all the things like we have talked about what is supervised, unsupervised learning, what is machine learning, and then what is like clustering, the types of clusterings we have, and also we talked about the in-depth in K-means clustering. And we have done almost 3 demo, like the basics of K-means, then using a very basic data sets of K-means data, like like the digit data set to do the K-means demo. And lastly, we did, right, let me just change the name of it. So mall customer clustering. Okay, so basically what we have done, so lastly we have used a mall customer data set to do the clustering, right? So yeah, this is pretty much about the K-means clustering we have learned so far.
So when it comes to data manipulation, you will use pandas. Now, another important aspect of exploratory data analysis is visualization as well. And to visualize data which we have this wonderful library called as Matplotlib. And that is the library which we'll be using over here. As you see over here with Matplotlib, we can create all of these different geometries. So you can create a scatter plot, histogram, bar plot, and a lot more. Just to give you guys a context of how Matplotlib works, I'll show you how to create a simple line plot. Now, there is another library in Python which goes by the name of NumPy, which NumPy is basically, it stands for numerical Python, and it is used for most of your numerical and scientific computation. And here we are importing NumPy using this. So we write down import NumPy as NP. Then we would have to import this submodule called as PyPlot from Matplotlib. So we write down from Matplotlib import PyPlot as PLT. So this is the alias. PLT is the alias which I've given for PyPlot. Then I go ahead and create some data over here using the NumPy library. So arange is a method which comes under the NumPy library. And what I'd want to do is I'd want to create a NumPy array which has numbers starting from 1 going on to 11. And in np.arange, you'd have to understand that the first number which we give is inclusive. The second number which we give is exclusive. This would mean that when I given 1 and 11, I'll have all of the numbers starting from 1, but only going on till 10. So let's say instead of giving 1 and 11, if I given 1 and 10 over here, then the numbers would go from 1 to 9. So this is how I'm creating the object X over here. Then I'll go ahead and create the object Y. So Y is 2 times of X. So basically in X, you have 1 to 10. Then in Y, you have the value starting from 2 going on till 20. And to create a simple line plot, all we have to do is write down plt.plot, and inside this, we will pass in X and Y. So X goes on to the X-axis, Y goes on to the Y-axis, and as you see on the X-axis, we have value 0 to 10. And on the Y-axis, we have the value starting from 2 going on till 20. And this is a very simple line plot which we have created. So I'll just add a comment over here, which would be visualization. And let's just import the 2 libraries. So I'll write down import NumPy as NP. Then I would also need matplotlib. So I'll write down from matplotlib import pyplot as plt. So these are the two required libraries. So these two have been successfully loaded. Then going ahead, I'd have to create the data first. So here x is equal to np.arange. So let's say on the x-axis, maybe I have the values starting from 50 to 100. So this is what I'll have in x. Then y, let's say, is 3 times of x. Let's actually make it 3 times of x. Now let me print out x over here. So x has the value starting from 50 to 99. Y has the value starting from 150 to 300. So again, as you see over here, so this is basically 3. So 50 into 3 becomes 150, 51 into 3 becomes 153. So that is how these numbers are progressing over here. Now to make this plot, all I'd have to do is write down plt.plot, and inside this, I will just put in x comma y, then I will just show it out to you guys, which will be plt.show. And as you see, this is the very simple line plot which we have created. X-axis goes from 50 to 100, y-axis goes from 150 to 300. So this is a simple intro to the libraries which we'll be using today. What we'll be doing today is we have a data set and we'll be performing some exploratory data analysis on that particular data set. And for that purpose, we will be using libraries such as matplotlib and pandas. So let's actually start off with understanding what exactly is pandas and why do you, how is it important in the context of what we're doing today. So now if you have worked with, let's say, Excel or SQL, you would know the context of tables. What exactly is a table? A table is something which is represented in the form of rows and columns, isn't it? So if you would want to work with a table in Python, then you would need to work with something known as data frames. And these data frames are provided by this library called as pandas, which is the core library for data manipulation and data wrangling. And now, this provides you single dimensional data structure as well as multi-dimensional data structure. So when it comes to single dimensional data structure in pandas library, that is known as a series object. And when it comes to a multi-dimensional data structure, that is known as a data frame. Now, we'll not be looking thoroughly into series object because that is not something which we'll be using for today's project. So I'll just give you a quick context of what exactly is a series object. As I've told you, it is a one-dimensional object which is provided by the pandas library. And as you see, first, if you'd have to work with the series object, you would have to import the pandas library. So you'll start off by writing import pandas as pd, and you will go ahead and create a series object like here. So you'll write down pd.series, and inside this you will pass in a list. What is a list? A list, you can consider it to be a collection of different items. So here we have a list which comprises of these numbers 1, 2, 3, 4, 5, and out of this list we are creating a series object and we are storing it in this object called as S1, then we are printing it out. Then if you look at the type of it, you see that this is a series object. Jupyter Notebook over here. So Jupyter Notebook is normally the IDE which I use to implement all of these, all of these sessions. So you have a lot of IDEs to work with Python. So you have PyCharm, you have Spider, you have Visual Studio Code, you have Google Colab, you have Jupyter Notebook. And I personally use Jupyter Notebook a lot because for most of the data science or ML projects, I consider Jupyter Notebook to be much more easier to work with. So first we'll have to start off by importing pandas. So I'll write down import pandas as pd. Now I'll go ahead and create a series object. So pd is the alias which I've given for this library of pandas. And this pandas library has the series object. So pd.series, and here you'd have to remember that S is capital. Inside this, I'll just pass in a list of values. So let's say it'll be 1, 2, 3, 4, and 5. And I will go ahead and store it in an object called as S1. Then I will print it out. And as you see, these are the values which we have, and these are the index values which are corresponding to these values which I've given. Now, let's say if I actually change this, instead of 1, 2, 3, 4, 5, maybe I given 10, 20, 30, 40, and 50. Let me run this. Let me also run the cell. You would see that the values have changed, but the index values normally in Python, they start from 0. And let's actually see if this is a series object or not. So inside type, I will pass in the S1 object. And you would see that we have the result pandas.core.series.series. And this is a series object. So as you see over here, a data frame is a two-dimensional label data structure. So again, a data frame, simply put, is just a table which comprises of rows and columns. And let's actually see how to create a data frame from a dictionary. Now again, some of you folks who are new to Python who do not know what a dictionary is, just consider a dictionary to be a key value pair. And you create a dictionary using these curly braces. So as you see over here, inside these curly braces, I have two key value pairs. The first key is name. For name, we have the values Bob, Sam, and Annie. And then for marks, we have the values 76, 25, and 92. So with these key value pairs, I'm creating a data frame. So again, data frame is part of the pandas library. So I write down pd.dataframe. And here, keep in mind that D and F are in capital. So this is, you have to make sure that, you write it D and F, it is in caps and it is not in small case. Now here, if you will look at this data frame, you will see that the key has been turned into the column name and the values over here have been stored as the records. And this is how you can create a data frame using pandas. Now let me go to Jupyter Notebook and just quickly create a data frame over here. So what I'll do is I will write down pd.dataframe inside this. Maybe I'll give in, so I'm creating a dictionary. Now instead of student and marks, what I'll do is maybe create fruits and the cost of the fruits. That would be interesting. So I'll have a key called as fruit, and let's say I have certain fruits over here. And let's say those fruits are apple, then I have a banana, then I have a mango. So this is my first key over here. Then I'll just put in a comma. And let me give in my second key, which would be cost. Then I'll give in a colon. Now let me pass in the cost. So let's say apple costs around 12 rupees. Banana costs 20 rupees and mango costs 56 rupees. So these are just some random values which I've given over here. And now I'll go ahead and I'll store this in something called as a fruit basket. And let me print out fruit basket over here. And when I hit on run, you would see that the key over here has been turned into the column name. These values, apple, banana, and mango, have been stored as records. Cost over here is the column name. 12, 20, and 56 are again in the records over here. We will start off with today's session. So as I've told you, we'll be working with these two libraries. We will not actually require Seaborn. So Seaborn is also another visualization library, which we will not require today. So I'll just delete it from this command. So we would need pandas. The alias for pandas is pd. We would need pyplot, which is a submodule in matplotlib. And I'm giving this an alias of plt. Again, let's just wait for these libraries to load. So that is done. What I'll do is I'll actually remove the results from over here so that it will be much more interactive, so that you actually know what is happening over here. Now, let me start off by running this again. Now, if you'd have to load any CSV file, so CSV file is something which has the extension of .csv, and these are normally your Excel files. So if you have a CSV file, this is how you load it. So you write down pd.read_csv, and read_csv is a method in the pandas library. And we have a CSV file called as characters stats, which has all of the statistics of all of your Marvel superheroes and DC superheroes. And this I go ahead and store in this object called as Marvel. Now, I'll go ahead and have a glance at the first few records of this Marvel data frame. So I need to write down marvel.head, and by default, this head method gives you first 5 records which are present. Now you see this is our Marvel data frame, and this comprises of all of these columns. So you have the name of the superhero over here. So you have 3D Man, A-Bomb, Ape Sapien, Abensure, Abomination. Then you have the alignment, whether the superhero is good or so. Basically, we are saying if he's a superhero or a supervillain. So that is what the alignment tells you, whether he's good, bad. You also have another category called as neutral. So there are very few neutral characters which are there in this particular data frame. Then you have the intelligence over here. So as you see, 3D Man has an intelligence of 50, A-Bomb has an intelligence of 38, Abensure, Abomination. So all of these superheroes are alphabetically listed. Then you have the strength of these superheroes. Similarly, you have the speed, durability, power, combat, and total. So these are some columns which are present over here. Now, then we will go ahead and see how many records and how many columns are actually present over here. So for that, we have the shape method. So we will write down marvel.shape, and I hit on run. And you would see that this has 611 records and 9 columns. So this 611 records tells you that there are 611 superheroes or supervillains present in this particular data frame. Now, going ahead, I want to see how many of these characters listed in this data frame. So how many of them are good, how many of them are bad, and how many of them are neutral. So that information will be coming from this column called as alignment. So that is what this alignment column tells us. And this is a categorical column. So all of the other columns are numerical. So as you see, numerical columns would basically mean you have numbers. Categorical column, as the name states, you have categories over here. So if you have to do some sort of analysis on the categorical column, if you'd have to check the frequency of the categories, then we have a method called as value counts. And as you see over here, so first I given the name of the data frame, which is Marvel. Then, so we have this parenthesis. Inside the parenthesis, I given the name of the column, which is alignment. Then I use the value counts method and I hit on run. And you would see that, so out of the 611 characters which are present, 432 of them are good, so we'll consider them to be superheroes. 165 of them are bad, so we'll consider them to be villains. And 11 of them are neutral. So this is some interesting information which we have out of this. And this is a data frame which comprises of both your Marvel superheroes as well as your DC superheroes. So now that we have had a look at the different categories which are present over here, what I'd want to do is I would want to extract all of these good characters from this entire data frame. So out of these 611 characters, I'd want to extract all of the good characters. Let me explain this command properly to you folks. So what I'm doing over here is, so first when I given the name of the data frame, inside this I given the column name. So let me write down alignment over here. And when I set the alignment to be equal to good, what this actually does is this gives me a bunch of true and false values. So wherever the value is true, this would mean that the record over there is equal to good. Wherever we have a false, this would mean that the record over there is bad. So here, as you see, so you have 0, 1, 2, 3, 4. You have these index values over here. And if we go up, so we had true, 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 and false. You had trues for all of these because you have good over here. You have a false for this because you have a bad over here. So this is how we give the condition. Now, out of these true and false values, I would want to extract only those records where the value is true. So what I'll write down is, I'll give in Marvel over here. I'll cut this out and I will paste it inside the Marvel data frame. Now, when I hit on run, and if you look at this particular data frame over here, So you would see that I have only extracted the superheroes out of the entire data frame. So this is something interesting which we've done. Now, so again, good.head over here will give me only, so what I'm doing is the same command over here, I'm storing it in a new object called as good. Then I go ahead and have a glance at the first 5 records. So again, here you'd have to understand that this is alphabetical. So when we say alphabetical, again, if you have any superhero who has a number, who has his name starting with a number, so that's why we have 3D man at the top. Now, I'd want to see which of these superheroes has the maximum speed. So speed over here is a numerical column. And if I'd have to sort my data frame with respect to a numerical column, I have this method called as sort values. So I will write down good.sort values, and I would want to sort this data frame with the help of the speed column. And I will set ascending is equal to false because I'd want this data frame such that that particular superhero whose speed is the maximum, his record is at the top place and it goes in a descending order. And I'd want to have, so let's actually remove head over here. Let's have a look at the complete list of this data set. So here, as you see, Flash 3. So Flash obviously has the maximum speed. Then you have Jack of Hearts with a speed of 100. You have Impulse with a speed of 100. You have Stardust with a speed of 100. You have Quicksilver with a speed of 100. So it seems like there are a lot of superheroes who have a speed of 100. Let's actually see how many of these superheroes have exactly a speed of 100. So what I'll do is I'll again insert a cell above this. Now from this data frame, from the sub data frame good, I have the speed column and I want the speed to be equal to 100. And this I will store in an object called as max speed good. I'll actually have to, again, store this in a data frame. So let me cut this out over here, paste it over here. Now I will go ahead and insert a cell above this and I'll have max speed good. So it seems like we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. So it seems like we have 12 superheroes who have a speed of 100. So this is quite interesting over here, isn't it? So if you, so again, this is, you'd have to keep in mind that this is with respect to alphabetical. So you have Black Bolt, Flash 1, 2, 3, and 4. So again, so you have different versions of Flash over here on the basis of the comic books. So you have, again, Flash is obviously the fastest superhero. His speed is 100. Then you have Crypto, Nova, Quicksilver, Stardust, and obviously Superman. So Superman can fly. So obviously we are assuming that if Flash is the fastest person on land, then Superman must be the fastest person in air. So that could be a reason why Flash and Superman have the same speed level over here. So this is quite an interesting analysis. Now, let's say if I'd want to find out all of those superheroes whose speed is the lowest. So you have, as you see over here, there are a lot of superheroes whose speed is only 1. So what I'll do is I'll change this to equal to 1 and I will change this to min speed. So min speed good. So here, wherever the speed value in this good data frame is equal to 1, I'll be extracting all of those records and I'll store that in min speed good. Then again, I will have min speed good over here. So here, as you see, all of these superheroes do not really seem to be, that strong. So all of these values are quite low over here. Their intelligence, strength, speed, durability, and power, they are extremely low. So White Queen, Wizkid, Wondra, so all of these, I'm pretty sure that you wouldn't even have heard of all of these superheroes. So these must be just random characters in the Marvel DC universe who have extremely low stats with respect to this. So similarly, what I'd want to do is I'd want to see who is the most powerful superhero. So we have a tab called as power. So again, good.sort values. So I'll delete min speed good, and over here I'll also delete this. So now from this data frame good, I'd want to this time. So initially we had sorted this with respect to speed. Now I'd want to sort this with respect to power. So as you see, good.sort value, still here it's the same. It says that when it comes to buy, I am sorting this data frame with the help of this power column, and I'll set ascending is equal to false because I don't want the superhero who has the maximum power to be at the top. So again, let's actually have a glance at only the first 5 records. So here, as you see, we've got these records over here. So you have Zatanna, Thor, Beyonder, Beta Ray Bill, who have a power of 100. So that's quite interesting. And I'm personally a big fan of Thor. So if you've seen Avengers Endgame, then you have fat Thor in Avengers Endgame. So even though he was fat, he was extremely strong. So I personally love Thor's character in Marvel's Endgame. Similarly, what I'd want to do is I'd want to extract all of those superheroes who have a power of 100. So here, good. Again, I need to give in the name of the column, which is power. And I will set the power value to be equal to 100. Then again, I'd have to extract this. So again, this will become good. I'll cut this out. I'll paste this in the good data frame. I'd have to store this in good. Let's just say actually good max powerful. I'm just giving random name over here. I'll insert another cell over here. So let me just good max powerful, and when I hit on run, so seems like we have a lot of superheroes. So as you see over here, we have a lot of superheroes. Let's actually get the count of this. So again, I'll insert a cell about this over here. Let me see the shape of this. So Control C, Control V dot shape, and when I hit on run, so you would see we have 33 superheroes who have a power of 100, and that is amazing, isn't it? So you have all of these superheroes, and this is right now listed in alphabetical order. So let's see how many of these superheroes, are actually famous, are actually there in the Marvel or DC universe, or quite famous. You've got Doctor Strange over here, who obviously is extremely powerful. And then, seems like we also have Goku. So if some of you watch anime, so seems like, I don't know if Goku comes under why Goku has been listed over here, but seems like we also have Goku over here. Then obviously we have Iron Man with a power of 100. Then we have Martian Manhunter, we have Marvel Girl, we have Nova, Silver Surfer. Something interesting over here. So if you see, we do not have Superman. So this is quite interesting, isn't it? So let's actually go up and see what is Superman's power. So this is something we had done above. Okay, seems like we've lost that. So anyhow, so as we were looking over here, so it seems like Superman does not have a power of 100. So that is something interesting to find out over here. So let's say if I want to check, let's see, who do we have over here? Let's actually check Thor. So if I want to check only the record of Thor from this entire data frame, what I'll do here is I'll give in the name of the data frame, which is good. Then I have a column called as name. And what is the name of the superhero? It is Thor. And this is what I'll do. This is the condition. And again, I will keep it in the good data frame. I'll put it inside this and I'll hit on run. So as you see over here, I have extracted only this particular record where the name is Thor. So this is how we can analyze some specific records from the entire data frame which we have. So we have done analysis till till the power of all of these superheroes. Now what I want to do is, so till now what we've done is data manipulation. Let's actually do a bit of data visualization. So when it comes to data visualization, again, we will be needing Matplotlib, and Matplotlib again has a submodule called as PyPlot, for which we have given this alias of PLT. Now I will insert a cell above this, and what I'd want is, I would want to make a simple bar plot for the top 5 superheroes with maximum power. So here we have this particular over here, max power. I'll actually get this again. So here we have this particular record. So as you see, we have the top 5 superheroes with maximum power. Now, what I'd want to do is, if I'd want to make a bar plot of this list, so not actually power. So you see this total column over here. So I'd want to look at the top 5 list of those who have the maximum total value, right? So here, as you see, Martian Manhunter seems to be best when it compares to everything, right? So Martian Manhunter, only when it comes to speed and combat, it is less than 100. In all other aspects, he's got an absolute 100 over here. And we were talking about Superman. So Superman, it seems that he does not have a power of 100. He only has a power of 94. So this is quite interesting. So seems like Thor is much more powerful than Superman, which is quite an interesting take, isn't it? Then you have Stardust, Thor, and Supergirl over here. And these are the total values. Now, so these total values basically indicate the most powerful superheroes in the DC. And when I say powerful, that would mean with respect to all aspects, with respect to intelligence, strength, speed, total power, and combat. So obviously, if you add all of these, this is what you will get over here. So now what I'm doing is, I'd want to have a look or make a simple bar plot for all of these top 5 superheroes across DC and Marvel franchises. And to make a bar plot, first we would need to set the dimensions, and I am using plt.figure, and inside this I have a parameter called as fig size, and I set the figure size to be equal to 8,5. So these are just the dimensions of the image which I'd want to create. Going ahead, if I'd want to create a bar plot, I would have to use plt.bar, and in plt.bar you have these 3 different parameters over here. The first parameter which I give, normally when you're creating a bar plot, the first parameter needs to be a categorical entry, and that is what we are doing over here. So you have good max power. So this is from good max power. First, on the x-axis, I would want to list out the names of the superheroes, and on the y-axis, I would want to list out the total values. So first, I will extract all of the names over here. So as you see, good max power name. So obviously 0 to 5, because I only want the top 5 superheroes with the most total value. This is what I'm giving as the first parameter. Then in the second parameter, I will take in the total value. So this time from the good max power data frame, I am extracting the total column. Again, 0 to 5, because I do want the top 5 columns. And I'll give a color to this bar plot, which is basically green. So if I give in color is equal to G, that would basically mean that the bar plot which I've created is of green color. Then plt.show, and this is the result which you get. So as you see, these bars are, there's not much of a difference, but these are slightly decreasing. So Martian Manhunter, Superman, Stardust, Thor, and Supergirl. So this is a bit of visualization which we have done. We have done this basic analysis for all of the superheroes. Now let's actually do the same sort of analysis for villains as well. So this time from our original data frame, which was Marvel, I am extracting all of the records where alignment is bad. So as you see over here, Marvel alignment is equal to bad, and I'm storing this in this object called as bad, and I click on run over here. Then I have a look at the top 5 records. So you have all of these villains over here, or supervillains: Amu, Amizo, Airwalker, Abraxas, Abomination. Now I'd want to see who has the maximum speed among these supervillains. So again, it will be bad.sort values, and this time by it will be speed ascending is equal to false. So similar stuff what we've done, and as you see over here, so you see that a lot of these supervillains also have a speed of 100. So you have Zoom, Airwalker, you have Amizo, you also have General Zod over here. So then you have Superboy Prime. So all of these supervillains have a speed of 100, which is quite interesting. Then similarly, I want to see who is the most intelligent among these supervillains. So this time I will sort it by intelligence. I'll click run. And as you see over here, you have Mr. I'm not sure how do you spell this, but so Mr. MXYZPTLK seems to have an intelligence of 113, which is amazing. Then you have Lex Luthor, the villain in the Superman series. Then you have Leader, you have Brainiac, and then you have Doctor Doom with an intelligence of 100. So this is something interesting over here. Then I'd want to see who is the most, badass of all of these supervillains. So again, I would want to look at the total column over here. So bad.sort values, by is equal to total, and ascending is equal to false. So it seems that Superboy Prime seems to be the most powerful among all of these supervillains. Then you have General Zod, then you have Amizo, then you have Dormammu. Dormammu again was the villain in Doctor Strange comic series. So if you've seen the movie Doctor Strange, then you would know about Dormammu from that movie. So it was also amazing how in the end, Doctor Strange was able to put Dormammu in a time hole. So if you've seen Doctor Strange, you will find that quite interesting. So you will see that, how Doctor Strange, who is equally intelligent as Dormammu, who is able to outwit Dormammu over here. Then going ahead, what I'd want to do is, similarly, I would want to make a bar plot out of this. So I would want to make a bar plot for these top 5 supervillains over here. So again, plt.figure, fig size, dimensions 8,5. So if you want me to change this, I will maybe change this to, I don't know, let's keep it 5, 10,5 seems fine. plt.bar. So someone in the chat has asked how to give different colors in the bar. So I'll show you how it's done. So plt.bar here, the first parameter will be the name of the supervillain over here. So that is why I'm giving the name column. Again, I would need only the top 5 records. Next is the total column. Then over here inside color, I'll give in a list of colors. Since I have 5 bars, so I have 5 supervillains for which I'd have to create this bar plot. So inside this parenthesis, I'll give in 5 colors. Let's say the first color is red. Next color I'll give in green. Then I'll give in blue. Then I'll go ahead and give in, let's say, orange. And then final color, let's say I'll give in pink over here. And I have plt.show. Why do we have an error over here? Bad max bar. Okay, let me also run this first. Now let me run this, and as you see, I have different colors for each of these different bars over here. So again, this will come sequentially. So the first bar has the red color, second bar has the green color, similarly followed by blue, orange, and pink. So this was about the supervillains. Now, what I'd want to do is I'd want to make a distribution of speed for all of the superheroes. So I'd want to see what is the range of the speed for all of the superheroes. So since speed is a numerical column, what I'm doing over here is, again, setting the dimensions over here, plt.figure, figure size is 5 and 7. Then I will go ahead and use plt.hist. So plt.hist, which I'll be using to make a histogram. And here you'd have to understand the difference between a histogram and a bar plot. A bar plot is used to visualize something with respect to categorical columns, and a histogram is used to visualize something with respect to numerical columns. And as you see over here, since we have names over here, since we have categories, that is why we've made a bar plot. Now, on the other hand, if I just want a distribution of speed, so speed is only a numerical column, that is why I'm making a histogram. So I'll write down plt.hist. So from all of the superheroes, I am only making a histogram for all the superheroes. Then I'll set the title for this as distribution of speed. I'll set the X label to be equal to speed, and then I'll just print it out. So this is something interesting over here. Let me increase the width. Let me make it 10 actually. That would be interesting. Let me decrease the height. 10,5 would be better, I believe. All right. So as you see over here, most of those superheroes, their speed would be somewhere between, so you have 140 superheroes whose speed would be somewhere between 0 to 10. And there are very, very few superheroes. There would be around 20 odd superheroes whose speed is between 90 and 100. You have two peaks over here. So there are 140 superheroes for a speed of 0 to 10. And there are around 85, or you can say somewhere between 85 superheroes whose speed is between 20 and 30. So this is how the speed of superheroes varies. Then similarly, if I'd want to have a look at the combat for all of these superheroes, again, I'd have to do the same thing. It'll be plt.figure. I'll set the figure size. I will make it 10,5 actually, because it'll be better to visualize. plt.hist. So now this is actually the combat for super villains, because I'm using bad over here. So let me change the comment over here. Let me change this to be equal to super villains, and title as distribution of combat, and here X label as combat. And here you see, again, there are also we have very few superheroes, very few supervillains in general. So out of those very few supervillains, there would be around maybe at max 10 supervillains whose combat value lies somewhere between 90 and 100. And there are around 40 supervillains whose combat is between 0 to 10. And again, you have a peak over here. So there are around 30 odd villains whose combat rating is between 50 and 60. So this was all about the exploratory data analysis for the Marvel and DC superheroes. Due to the boom in social media, we have news coming up from a lot of different sources. But the problem is, the authenticity of the news coming from all of these different sources is mostly questionable. So how do we find out if the news is genuine or not, if it is fake or not? Well, the best solution is machine learning. And in this course on fake news detection using machine learning, we'll properly understand the techniques on how to detect fake news using some of the concepts on ML. So let's get started. So we have this fake news data, and we'll mostly be using Pandas, NumPy, and scikit-learn. So Pandas is a library which is used for data manipulation, and NumPy is a library which is used for numerical computing. So we'll go ahead and import these two libraries first. Let's just wait for these two libraries to load. Now that we have loaded this, let me also go ahead and load the dataset. And since this is actually a CSV file, I would have to use read_CSV method, which is part of the Pandas data frame. So I'll type in pd.read_CSV, and I'll give in the dataset inside this, which is data.csv, and I'll store it in this new object called as fake. Now, if I want to have a glance at the first 5 records of this data frame, then I'll be using the head method. So as you guys see, this comprises of these 4 columns. So we've got the URLs column, we've got the headline column, then the body column, and the label column over here. URL is basically where is this news from. So whether it is from New York Times, Reuters, or some other website. Then we have the headline, which is the basic headline which you see at the top of the article. Then you have the body, which is the entire article. Then you have the labels over here. You have 1 and 0. So 1 would mean that the article is genuine and 0 would mean that the article is fake. So these are the 4 columns which we have over here. Now from this, we would not require this URLs column. So I'll just go ahead and drop this. And to drop a column, we will have this drop method. So over here, I'll just use fake.drop and I'll pass in the column which I'd want to drop. And since I want to drop this column, I'll pass in URLs inside this and I'll set the access value to be equal to 1, which would mean that I'm basically dropping a column. So if you want to drop records, then you'll set the access value to be equal to 0. And if you want to drop a column, you'll set the access value to be equal to 1. And once we drop the columns, if there are any missing values present over there, I would also want to remove all of those missing values. Missing are basically NA values or non-existent values. I'm dropping all of those and I'm storing it back to the same object, which is fake. Now, once I do that, let me have a glance at the same data set again. So initially we had this URLs column. Now we have successfully removed that URLs column as well. Now this data set comprises of a lot of records. And I don't want to work with all of those records because that is very time consuming, and also to build this model, it'll maybe take at least 5 to 10 minutes for the model to build itself. And since this is a live session and we can't really wait for 5 to 10 minutes for the model to build, so I'm going to take only the first 1000 headlines from this entire data frame. So here to extract the first 1000 news articles or the first 1000 records, I'll have fake and it'll go from 0 to 1000. And I'll store it back to fake over here. Now that I have the first 100 articles with me, I would have to extract the dependent variable and the independent variable. So I've already explained to you what is a dependent variable and what is an independent variable. So here in X, I am storing all of the independent variables. So with this command, fake.ilog, so this over here on the left side of the comma, this means that I'm extracting all of the records. And on the right side of the comma, this basically means that I'm extracting all the columns except this label column. So I'm basically extracting the headline column and the body column, and I am storing it in this object called as X. So this is how I am extracting all of the independent variables. And once I have extracted all of these independent variables, I would have to also extract the dependent variable, and the dependent variable is this one over here. The dependent variable is label, and I'm extracting all of the records and I'm extracting only the label, and I'll store it in Y. Now let me show you the first record in the independent variable. This is what we have. So X of 0, this would basically mean we'll have this and this. So as you see, we have 4 ways: Bob Corker, Stewart, Donald Trump. So this is the first headline which we have. Then we have the body of this. So body of this is present over here. This is our independent variable. Then we'll have a glance at the first record which is present in the dependent variable side. As you see, we have the label 1. So we have done till over here. So we have extracted dependent variable and independent variable. Now to build the machine learning model, we would have to convert this text data into numerical values. So that is why we have something known as count vectorizer. So here I am importing count vectorizer from feature extraction. Now once I import count vectorizer, I will set the maximum number of features to be 5000. And what are these maximum features? This basically denotes the number of records which I'd want to vectorize. And since I only have 1000 records, and I've given the maximum limit of 5000, this will basically vectorize all of the text data which I have. Now, I'll create an object of this and store it in this object called CV. And when I use this method called cv.fit_transform. So here inside cv.fit_transform, I am basically passing in this independent variable X, which you have over here. And as you guys see, I have X, I have all of the records, and when I have 0 over here, 0 basically means the head. So as you guys see, X over here has the head as well as the body. When I given the value 0, this would mean that I am extracting the headline and I am converting this text into numerical data, and I am converting it into basically a matrix, a dense matrix. So I transformed that into count vectorizer. Then I convert it into a dense matrix. So this toDense method helps us to convert this into a dense matrix, and I store it in this object called as mathhead. Let me load this over here. I have not run this. Let me run this properly. So as you guys see, this is computationally very extreme. This takes up a lot of time over here. And if we had actually given all of the records, then this would have easily taken 5 to 10 minutes. We have imported count vectorizer and we have converted the headlines into this metric. So here what you see is this is basically the count of words. So this count vectorizer has a dictionary with it, and this what you see. So as you see, 4 ways Bob Corker cured Donald Trump. Now you have something known as a word builder over here, and this word builder, it tags a number with all of these. This basically tells you how many times the word 4 occurs, how many times the word ways occurs, how many times the word Bob occurs. And you have this entire dictionary, and for that entire dictionary you have these zeros and ones. Wherever you have 1, that would mean that you have that particular word existing over there. So we have converted all of the headline to this matrix body. Now similarly, we will go ahead and also convert the body into this matrix. So here we have transformed the body. Now we'll also convert this head, and let me have a glance at this mat head as well. And we again have this condensed matrix, this dense matrix. Now we have done this. I would have to stack the headline on top of the body because this would be our independent variable. So as you guys see, initially we had this combined into one single array, which was X, but we had divided this into mat head and mat body. Now I'm just going ahead and stacking this on top of each other with this. So when I use np.headStack, with the help of this, I am stacking the head on top of the body. And once this is done, I can finally go ahead and divide my entire data set into training and testing sets. And for that purpose, I'll be using train test split method. So I'm importing train test split from sklearn.model selection. And over here, this is my independent variable, which is x of mat. So this is x of mat over here, and in y, I am passing in the dependent variable. Y is basically this label. Let's go up. So in y, we had extracted this particular column over here. Y comprises of all of the labels, and x mat is basically a juxtaposition of this mat head and mat body. And I am storing this into now this basically gives us 4 objects, which are x train, x test, y train, and y test. X train is the training set of all of the independent variables. X test is the testing set of all of the independent variables. Y train is the training set of all of the dependent variables, and y test is the testing set of all of the dependent variables. Here we have set the test size to be 0.2, which would mean that 20% of the records would be in the test set and the rest of the 80% of the records would be in the training set. Now that we have our training set and the testing set ready, we can finally go ahead and build the decision tree classifier. So here, what we are doing is we are importing decision tree classifier from sklearn.tree. And here I am creating an instance or object of this. So I am naming this object as DTC, and then I will go ahead and fit the model on top of the training set. So here, as you guys see, I do DTC.fit, and I am fitting the model on top of the training set. Once I fit the model, I'd have to predict the values on top of the test set. So we had learnt about this during the theory phase, where we knew that first we'd have to train the model, then we'd have to build the model on top of the test set, and that is what we are doing over here. First we are training this on top of, first we are building the model on top of the train set, then we are predicting the values on top of the test set. Now once this is done, let's just wait for this model to be fit. So here I'd have to run this again. I'd forgot to run this cell. Now let's just wait. So here we have, so this what you see, this is the predicted list. So for X test, you had some values. This is what this model has predicted. This model has predicted some labels. So here 1 again would mean that the news is not fake. 0 would mean that the news is fake. And now we would want to build a confusion matrix which would give us the, let's just run this again properly. We have an error over here. Let me actually, what I'll do is I'll go ahead and I'll store this in a new object called as ypred. Now if I run this and I will have ypred over here, now we'll get the result. So this what you see over here is known as the confusion matrix. This left diagonal will give you all of the correctly predicted results, and this right diagonal will give you all of the incorrectly predicted results. And if you want to find out the accuracy of the model, this would be correctly predicted results divided by all of the results over here. So I'd have to do 98 plus 87 divided by 98 plus 87 plus 8 plus 7. And this would give us a result of 0.925. So this would mean that the decision tree model which we built has given us an accuracy of 92.5%. So this is the entire fake news detection project, guys. This is a very simple project. All we've done is taken the fake news data set and we built a model which would basically predict if the news is fake or genuine. This brings us to the end of this course on fake news detection using machine learning. Thank you very much and have a great learning ahead.
Today, we are going to solve a problem on predictive maintenance for car rental. Why I took car rental, why I'm specifying car rental, because this data set that I procured is from some free source, as you can't use it, your company data or your work location data. But this is a problem that I have real-time worked in supply chain analytics with Infosys, and Infosys has published this solution in public on YouTube. So I'll walk you through first that video so that you can understand it, and then we will see how to solve this problem. Okay, this problem lies everywhere, irrespective whether you have supply chain, you have car rental company, you have own fleet maintenance company, logistic, whatever it is. This problem lies everywhere, and by 2030. This is what they want to achieve in each and every sector, each and every supply chain. They want to achieve this predictive maintenance to lower down the downtime. So let me just first show this video.
Fleet business must operate at peak efficiency and high utilization for better ROI. But for that, improving fleet uptime and reducing maintenance cost is essential. It is tempting to delay maintenance when maintenance cost is high, but running your vehicles until breakdown is costlier and increases the downtime. Fleet Maintenance Manager is also used preventive maintenance or PM on OEM guidelines, though it avoids unscheduled repair. The high cost of PM and undesired vehicle downtime remains. To avoid these, you can adopt the Infosys Vehicle Maintenance Workbench. It is an integrated platform for fleet maintenance efficiency and safety. Based on artificial intelligence with machine learning and optimization principle, the Infosys Vehicle Maintenance Workbench can predict vehicle failure in advance. It helps maintenance managers to auto-schedule vehicle preventive maintenance in their respective garages. The Failure Prediction tab of Infosys Vehicle Maintenance Workbench shows the complete status of fleet. It indicates which vehicles might need immediate service versus the vehicles that are still safe to drive. It gives you alerts on engine and transmission failures, battery life, brakes, tires, axles, and steering issues also. Based on these alerts, relevant maintenance activity can be undertaken. Once the vehicle arrives in garage for inspection based on predictive maintenance alert, it undergoes a thorough checks based on alert types and necessary repair works are carried out. In case of no issues with the vehicle, the technician or planner updates plan or override flag as no, with relevant comments in remarks section and save the details. This will ensure the machine learning model uses this information to adjust and improve the accuracy on future failure prediction. The Vehicle Scheduling tab of Infosys Vehicle Maintenance Workbench is used to auto-schedule the vehicle's maintenance in their respective garages. Its built-in algorithm can auto-schedule 5,000 plus maintenance jobs within few seconds. It shows the average garage utilization and downtime hour of the vehicles during the maintenance period. You can switch between daily and hourly views. Daily view specifies the date and the garage where the maintenance job is scheduled, and the hourly mode shows hourly activities to be performed. Use the Infosys Vehicle Maintenance Workbench to protect your fleet from any unseen failures and reduce fleet downtime and repair costs.
If you torture the data long enough, it will confess to anything and everything. That's what we are going to do today. We are going to do rigorous EDA followed by machine learning models. But unless your EDA or your data pre-processing is not done rigorously, your model will not come out good. Whether you are a MTech, you are a PhD, whatever you are, it won't work. So the very first thing is that we will do a rigorous EDA, get our instances, and then we will move towards the machine learning model. One word of caution over here, guys. Our aim is to understand the problem, to think analytically about it, how you can solve it, to know each and every aspect of it, stitch it together for your machine learning model. Never make your code or your coding efficiency a barrier for your learning. Code you can find online. If you know what you have to do, you can find the code online, whether it is Python, R, C, Java, whatever it is, you can do that. Don't worry about it. But your thinking capability should be always out of the box. You should think from end to end as a data scientist, how you can achieve it. And that is my agenda for today. Overall, what we are going to do is we will do rigorous EDA, we will do machine learning, code part. Already all these files would have been shared with you. If not, then it would be shared after the session. Don't worry, you can go through that. If you have any problem, you can search on internet how this code is written. But if you don't understand the concept, you can't find it on internet. Okay, so focus on understanding the concept, why and how it was done. Okay, this should be your motto every time. Anyhow, so let's proceed further. What is the case study? It is predictive modeling for fleet maintenance. What is the business objective over here? Business objective is that I have to reduce my downtime. How can I reduce my on-road downtime? And why I need to do this thing? First of all, because whenever, let's say a car rental company, whenever, or everybody would be using Big Basket. Let me take that very simple example. Sometimes you will get to know your order is delayed. How that order is delayed, we are facing surge in demand, our maintenance is going on, our vehicles are not available. Might be one of the reason could be that their maintenance, their vehicle is down, right? On road, it went, something happened and it went down. So what is that? If they would have predicted that, because these are trucks and all, or lorries, or even your cars or whatever you have, they are on, either they are on premise or they are third party, whatever they are. But what they want to do, they have to be predicted correctly whether it will break down in the journey or not. If it breaks down, you have a problem, right? Customer will not refer you. So all these things is that you need to reduce that downtime. Can we anticipate what failure may happen in the next 3 months? If you are able to anticipate that, because there are n number of failure reasons. When you talk about an industry, there is a code given to that. There are failure code, RC, something different nomenclatures, different terminologies are there based on different companies. We will see some of them. Which action can we take to prevent these failures? Now, how we can predict it? If we know that engine failure is the one that can happen, then what can I do? I can either, whatever is the solution, I can do overhauling, or I can get it serviced, or I can, if does engine replacement is required, some part is missing, what all things I can do over here. So I'll show you This is my first notebook on EDA. Also, one more important thing that we can cover from this predictive maintenance is each reason for failure has some parts associated with that. Okay, any vehicle is made up of different parts. Now, what you want to do over there is, if one reason uses 10 different parts, and sometimes you will give your vehicle for maintenance or service, and they will say it will, or suppose it has met with an accident and you're giving your vehicle, they will say it will take 10 days. It's quite easy, it's just a bump or something like that and you can get it replaced. No, they will say we can't tell you until unless we check the spare parts available in the workshop. That is the inventory management of the parts. If you know which are the top reasons, okay, if you know which parts are required for that top reason, you will always, as a company, as a car rental company or a car maintenance company or anything, what you will make sure that part is available, which is highly likely to fail. That part should be available in the inventory so that your customer can have a good experience. If you are giving back the vehicle after maintenance, after repair, in 3 days, what will happen? A customer is happy customer, whether another garage was telling that I will give you in 10 days. So this is for the car maintenance company or the car servicing companies. They can look at it from an inventory perspective also. So exploratory data analysis we are going to do on this. This is all the table of content. Wherever you want to go, you can go. All this is shared with you. So what is the objective? This is a case to illustrate not just EDA, but also to build predictive model from end to end. We will do that, as I told you, and make a direct impact on the client's bottom line. These are some of the terminologies that you use always in your reports. That's what is the terminology that I have placed over here. You can even use in your business reports when you are working on your assignments. Now, business understanding. Let's understand first the business. Already I have discussed it, but let's read this out so that if anybody has further doubts, it could be clarified. This exploratory data analysis of a car rental company for predictive maintenance. The client is the director of a car rental company. Everything is client based, right? Among other tasks, he manages the car fleet and deals with the scheduled maintenance events, but also with the unexpected problem that can prove very costly because of the associated repairs and unavailability. That was the inventory part that I was talking about. To prevent these issues, you may advise to use a data-driven approach since they already have some historical information. Every company will have about past failures as well as data about car usage and maintenance. So these were the points that I have mentioned. What are the causes of failures? Can we anticipate what failures may happen in next 3 months? Which action can be taken to prevent it? We have 3 data files available. One is usage data, second is maintenance failure, third is maintenance part consumption. I'll go through each one of the file. Let's just go to first usage data. Information about how the cars have been used in the past as measured by the number of miles collected at certain point of time. So your usage data looks like this. This is the car asset. With you won't have the direct name given like it is a Toyota or it is the Renault Driver, Renault Quid, or it is Swift, whatever it is. Names won't be given. They will have some code associated with that assets. And this could be repetitive because any number of same vehicle could be present, right? So if you see this code is repetitive over here. You have different assets. This is car type or car name, time, how much time it has been with the car rental company. And this is the usage. It is in terms of miles, how much it has gone through, what is the kilometers or miles it has traveled. Okay. Maintenance failure. So this file, maintenance failure file, again, you have assets over here and you have failure, which whether it has failed or not. 0 means it has not failed. 1, it has failed. So data that you are having historical, this is what you have. This is your target variable over here, but you have it in different file. In real time, this is how data would be provided to you from data engineering team. You won't have it in a complete structured format. That is what you as a data scientist have to do. They might provide you in that format. They might not provide you also, but yes. Maintenance part consumption stores which parts are serviced by asset and reason. All the cars are identified by asset number, which is available in each of the data files. This is the joining key that you have. So this is maintenance part consumption. You have again each and every asset, time taken, okay, so, means how much it has been associated with. Again, reason for failure. This is a code. For this, you need to have domain knowledge. I'll walk you through few of the codes. This is the part that for which reason, for that asset, which reason, what part has been used. Again, this is what? This is a code that is provided for each and every part. Might be it is a screw, it is an engine, whatever it is. These are different codes that are provided. Nobody will give you a data directly written that this is a screw or this is a bonnet or whatever. This is the mirror, whatever. This is the quantity for this asset. When it failed with this reason, this part was used and one quantity was applied. You can find some high quantities also. Like for this asset, if you see, this asset has failed with reason 193 also. This asset has failed with reason 565 also. With 565, you have two parts that have been added over here for this asset. One part, 150 pieces were used. Another part, only 4 pieces would be used. Might be this is a very small part, but very important, like your screw, your nut bolts and all those. Definitely the numbers would be high. That also should be available in your inventory because each and every part will have different kind of screw and nut bolts available. Okay, so this is about data. We are importing Python libraries. You guys are pretty much aware of all these: NumPy, Pandas, Matplotlib, Seaborn. This is iterable tools. I'll walk you through that when we are using iter tools. Might be few of you who have gone through the machine learning course or machine learning module have known this library also. Style, this is just your plotting style, Seaborn poster, 538. Again, this all things how I got to know internet. I might not have used it. You also might not have used it. You might know it from here. You can use it further anyhow. Okay, perfect. So suppress the warnings. This doesn't look good. That's why we always filter and suppress the warnings over here. So I have already executed this piece of code so that we don't spend much time in execution. I'll walk you through the code piece everywhere because this is time limited session. Okay. Adjust Jupyter views. This is just what I want to say. Display max rows. Otherwise, what happens if you will just show the data frame top 5, then ... will come and bottom 5 rows would be coming. This is to adjust your view. Okay. Reading and understanding the data. First thing, whenever you are working on anything, you want the data in Python, then only you can work with that, right? So what I'm doing is importing all the files. You guys are pretty much aware of it. Okay. This is display that we are having, how your Python will be import display if you have any image. So for that, it is there. Okay, so let's see what are the head and all this stuff. This you guys pretty much know. Now, is this Python display helps you to display all this thing in one go. Otherwise, you have to run 3 cells. What I'm doing, usage data done, maintenance data done over here, and then your maintenance failure data done over here. Everything is in one go that you are having. Okay, this package helps you with that only. Okay, proceeding, this is the head. Now inspect the data. So again, shape, size. What is the difference between shape and size, guys? Shapes give you number of rows and columns. Size gives you memory consumption. Okay, size gives you memory consumption over here. How much memory you have consumed. And remember, guys, as a data scientist, it is not always that how much ever data you will get, you want to use it. What you have to do over here is you have to be at optimal in cost parameter also, because everything in production or everything at client source comes with a cost attached. How many, what is the size of the data, how many redundant columns you have, what all these things comes with a memory size, right? You pay a price for that, whether you are on the cloud environment or however you are. So that's what you do with all these things. Okay. So this is giving you info and all that stuff. So in a data set, what we are seeing, we don't have any missing values. We have one object, one int, one float. So there's no need to change according to the data. All columns are good over here. Time, use, asset, 0 null values. We saw all these things. So these are the pretty much things that you know. In maintenance data failure, you have 195 missing values. So all these things you can see normal, describe, info. I will skip this because it is you guys are pretty much aware of it. Okay, I'll come to the main points over here. Getting unique counts of all objects. That is the asset. We have 1894 assets in with usage data set. I have 1819 in maintenance failure, 1913 in my this as maintenance part consumption asset. Now all have the different unique counts. Now what we have to do? We have to clean our data. There's some, I don't know how many of you know, there's something known as a package known as missing no. Okay, missing no, it is also to visualize your missing values. In this data set, I don't have any missing values, thus all black boxes are coming. In this one also, if you see, you have some of the boxes as lines are there, which means you have few missing values. In this one, if you see failure bin, you saw, right? Many missing values are there. So this would be more clear to you. You have more missing lines. These gray lines are telling you you have missing data. Over here also you have gray line. Over here you don't have any gray line. So you don't have any missing values. This is good to use when for visualization of your missing values. Generally, we use it to get a quicker view than just the sum and the value. So you can give a visual representation also. Okay. Now what I'm going to do is that I will get the percentage of failure. Okay. What is the percentage of failure that I'm having? Why I need to know the percentage? Generally, we have been taught if it is a missing value, continuous, impute it with mean and median. If you don't have outlier, impute with median. If you have outliers, impute with median. If you don't have outliers, impute with mean. If it is a categorical, impute with mode. But why I'm checking the percentage? Never you guys would have checked it. Why over here? What it will give me? So in fleet failure maintenance, there is 10.72% missing values in failure bin when compared to asset. Asset doesn't have anything. This is a graphical representation that I created based on asset and failure bin, how many missing values you are having, just for the sake that how we are doing this thing. Data frame, number, again, that percentage thing only that I calculated. Same thing, I'm creating a data frame over here. Column names and null value percentage. This is what I change into data frame. And then I'm plotting a graph. I'm giving a benchmark over here, which is a 40% line, that if it is less than 40%, then means this is a benchmark line. If it crosses this one, then definitely it is more than that. You can go ahead and delete that column or drop that column. Okay. These are good for your business report perspective. It gives you an edge over there. These are some of the things that you should do, that we do in any of our EDA. EDA is not that only you have to study. Your senior level management will also need to have all these graphs and everything. You need to explain them. If not management, at least the senior data scientist on a very high note would like to see all these things that you have to do. You don't need to give counts. You can go with visual representation. Okay, again, I'm going with maintenance part consumption. Okay, this is what I am having. All the bar charts for each and every parts asset that I am having for each and every part. I'm creating maintenance part consumption sort on ascending order. Okay. Based on above metrics and bar chart, it is evident that maintenance part consumption dataset has no missing values. It is 27 lakh. Yeah, 27 lakh 832 data points in each and every column we have. We don't have any missing values. So we are good over here also. Now let's do some analysis. Guys, I'm moving on a faster pace over here because you guys are well aware of these things. We have to reach to the core because this is a time-bound session. Still, if you have any doubts, please let me know. Okay, we have time and use column. What I'm going to do with this is I am getting the maximum values. Why I need the maximum value is that because this time and use alone is not providing me any insight. What is the time alone I am having or use? So I want to benchmark everything. Okay. How will I benchmark that? I can calculate max or min. Over here, I have calculated max for time and and max for usage data, that is use only. Use and time. So what are the maximum? Now, how you will get the maximum values from the math library I have used? This is the function that I have created. Input is time and use over here. Use argmax. This is the command syntax, and return my value for this one, time and usage. Okay, use basically. After this, I'm grouping by based on each and every asset and getting the sum total of time and use, because I want to understand based on each and every asset how much total time it has been available with us and how many what has been the use in terms of miles, that I want to know. So I have grouped by on the asset and did a sum over here. Okay, fine. So using group by function to group asset to find the sum of time and use is not useful, because time and use variables have information where whenever an asset came for maintenance, that's what is the whenever the asset came for maintenance for service, the time and use means how much miles it has traveled by that time when it came for maintenance. Therefore, we have to analyze the data by creating a new variable and use the existing data in an insightful manner. Everything won't be useful. That's why this total is not adding any value over here. Okay, so what we are going to do is usage data groups. What I'm doing, analyzing the time and use data by creating new variables. What are those new variables? This is nothing but your feature engineering. I'm creating min and max over here for time, for use. How it will help me? How will minimum and maximum help me over here? Can anybody help me out? How will this, think analytically, how min and max will help you? Getting the min value of time, max value of time, and same for usage, to get a good range over here. Okay, so that's what I am doing. Now, with that, I created the new column, age initial, what was when it came, and last known, what is the max value when that same asset came. So how much it has, what is the age for that vehicle till now, right? Now, distance initial, how much when it came first time for maintenance, what was the minimum? Of course, that would be the minimum value. So what was the minimum miles traveled when it came for first maintenance? Whatever is the latest one, that is the maximum. So how much distance it has traveled, you can calculate that. Distance last known, distance initial, age last known. Car service count, how many times it came for service. This is based on time, means how many times it came. So unique values I'm getting. If you see this one, this asset came for 16 times. First, it came when it was very basic. Might be initially only some hit happened or some problem was there, it came. When it came for latest one, the time when it came, it was 641, means it is in months, or it is not known clearly what is this time aspect. Let's say it is months, 641 months it came later. Distance initial, this is the minimum distance it traveled. Distance last known, it is minimum distance. Now, how is it possible that age initial is 0 and distance initial is high? How is that possible? Is it incorrect data or is it possible? Remember, it is for car rental companies, guys. This is a car rental company. They will be having a second hand asset, and that's the reason that it is coming again. Means it has data initial, distance initial, but age initial, when the car company owned that, it is 0. It is a second hand car. Okay. So we are grouping by on all these parameters and checking the describe. You guys know this command. What are the inferences from that? Age initial, it is the time when the asset reported first for maintenance service. It is the time when the asset reported last for maintenance. Using the unique time count, we are finding the asset visits to the maintenance service, the distance traveled by the asset when reported for the first maintenance, distance traveled by the asset when they reported for last maintenance as per the data. Using the above information, we would further investigate the total time spent and total distance traveled by the asset for maintenance services. So I'm creating the total age, time in service and distance service. Okay, so this is the lifetime values that I'm creating, time in service and distance service. Okay, this is my new data set that I am having. How many times it has been serviced, and all these parameters. So what we can say, time in service is the total time asset spent by the asset for maintenance service. Overall, how many ever maintenance it has derived from the difference, this thing. Distance, total distance traveled between the different maintenance. Suppose 10 maintenance for this car, 15 times it went for maintenance, and the distance traveled is, total distance that is traveled is 1763 between the initial and 15 maintenance. 0 till 15, this is the total distance. This is the time and service that it was there. Might be that this is a car that they need to dispose of, right? If 15 maintenance and only this much miles it has covered, which is pretty much low, it might be affecting on their cost, so they can dispose it off. But yes, let's take that call later on. Okay, inspecting use of this, all your info and all this part. So I'm skipping this part. So, okay, both in-time service and distance service variables, we got min value as 0, which cannot be the real-time scenario. Which one? Time in service and distance. That can't be the real-time scenarios. How many you got with 0 values? Min values is 0 over here. Min value is 0 over here. So this is definitely some error in the data. How you can remove that? Let's first see how many different values you are having. These are the counts which have 0 in usage data groups, which have 0 age initial, time in service, and distance travel. Age initial could be there. We already discussed this thing. But time in service can't be 0 and distance service can't be 0. That's not possible. So what we will do, we will impute these values. How you can impute these values? We can impute it with median if the distribution is skewed, mode if the distribution pattern is preserved. I'm not taking mean into consideration. We impute 0 values in continuous variables. We plotted the distribution of the columns and used it. So this is, I have written for your categorical also. But yes, let's see over here. This is the KDE plot that has been created. These are the 0 values. So what you can see, what kind of a KDE plot it is? What is the full form of KDE, guys? Kernel density. And what this plot tells you, what can you infer from this plot? Left skewed, perfect. So this is left skewed, correct. So in the above kernel density plot, it's negatively or left skewed. Therefore, we impute 0 values in time service variable using median over here. So we will impute it. I have left it right now. We will impute it. Let's see for distance service. What kind of skewness is there? Right skewed, perfect. So we will again impute it with median. So what I'm doing is I am calculating the median for all the variables, okay? For time in service, I'm taking all the non-zero values only. I won't consider 0 values, taking all the non-zero values in usage data groups. For time in service, I'm getting the median. So these are all the medians that you have. For each and every column I'm creating where my time in service is not equal to 0. So this is median value for each one of them. Now, definitely how you ever replace that median values. With that, for non-zero, I have replaced this in place is equals to true so that my data is intact. So somebody else, can't we drop the 0 values? Then I'll remember one thing, dropping is your last option. As a data scientist, we always worry about more and more data. Imputation will take you somewhere nearer to the real-time data, but dropping is totally removing that data. So that is not considered a good practice in industry. Clear? Okay. So always remember, it is for everyone. This is your last option of dropping. First, always try to impute it. But yes, if I have 80% missing value, that doesn't make any sense. I can drop. So this is a subjective call, but dropping is always the last part when you have very less percentage of data with 0 or missing values. Okay. So now this is median. Again, based on distance, I'm calculating these different medians and imputing the value. All these are imputed apart from the age initial. Age initial, I can leave like this because we already discussed it could be a pre-used car. So we are good with this. Everything is imputed. Now, these columns, we have already created time in service and distance service from these distance initial and all this. I can go ahead and drop few of them, right? So you can take a call whether you have to drop it or not. but this could be a redundant data. Already I have a calculated column from here. Okay. No more records in time service and distance service value as 0. You don't have minimum value. Minimum value is 1 over here. So we are good. Now let's identify the outliers. So usage data is something which is very essential. We have done it for all of them, but over here right now we are talking about the usage data because it has usage data, then your maintenance one. Of course, that failure one is your target. It is just for joining sake. So these are the two important data sets that we are bothered about. Right now, we are just doing it on usage data. So yes, we have outliers. Okay. So we can impute the outliers. Again, we can see outliers in distance service and maximum value is this, and therefore we have to treat the outlier because that is way too high. Again, based on your domain knowledge, you can use it. If you know that no vehicle can have this much high distance travel, it will go in scrap because of the pollution and all this thing. Definitely you have to treat the outlier. We will also treat the outlier in time service. Time service is having 730. It might also be high. So we will treat it, but again, it is based on your domain. If you think that it is something legitimate, you can keep it like that. Car service count and maximum value is 41. Okay, this one is 41. In real scenario, it is possible. Therefore, we would not treat this outlier. A car can come for servicing 41 times. That is quite possible. Same way of treating the outliers, how you guys have learned. I have not used any other way. Same way I'm treating it. So I'm skipping this part of code. Outlier treatment, same upper, lower than upper bound. Okay. Is in my box plot. So all outliers are treated over here. Let's check for the duplicate rows based on the columns. No duplicate rows are there. You can do it previously also, but that's fine. Anywhere you can do this stuff. We don't have. Okay. So let's do some data analysis. This is on time service. We already saw this curve. It was left skewed. Same thing you are seeing over here also for different variables. Okay. Your car service count is almost normally distributed with slight right skewness. This is your pairwise, your pair plot for each and every variable. Can you see any correlation? Distance service and car service count looks correlated. What else? Time service and count also looks somewhere correlated. Let's check the correlation plot. This is relation between time service and distance service. That's what we saw over here also. Where's time service? Distance service and time service highly correlated, which is obvious. If your time is more, your distance would also be more. If the difference between servicings, the time is more, the distance would also be traveled more. It won't be in the case when the vehicle is standing idle, which won't happen in the case with car rental companies. So we are good over here. Same thing, all whatever we checked on top, we are doing it again. Let's see the correlation. If you see distance travel, time service, 0.72, high correlation. Car service count and time in service, 0.67, moderate correlation. We have moderate to high correlation over here. So positive correlation, all are positive, but these are high, and this one is, I would say high only for this one. This one is moderate correlation between distance service and car service count. Fine. Let's analyze. So this is the analysis that we have done on usage data. Now let's analyze another one, that is maintenance part consumption. This is very important. I'm skipping all this describe and all this part. Okay, so let's see the unnecessary column. Unnecessary column over here is time. No null values are there. Data types are in accordance over here. So why I'm saying time is a unnecessary column. So deleted the time column for maintenance data set as the same time column is present in the usage data set. Therefore, we will use the same time column and its calculated field for usage data set. Over here, it was thus not relevant. Unique values, these many unique values I have. I have 14 repair reasons and spare parts. These many unique spare parts are there. Okay, so quantity, I'll get the absolute quantity. Converting negative quantity, there are few negative quantities also. I'll convert it into the positive quantity. If you see, I have this negative quantity, which is not possible, right? Might be a human error. I can convert it to absolute value and make it positive quantity for all of them. So this is how you have to understand your data and work along with that. Okay. So now if you see the minimum value has changed, it is 0. Might be no parts have been done, some oiling or this has been done and it went ahead. So let's see. This reason is the topmost reason. I created a bar chart over here, okay, a column graph over here, a count plot, which is telling me R707 is contributing to most of my failures, followed by R565 and so on and so forth. So this is here comes your domain knowledge. So what is this R705? Transmission range sensor circuit low input. This is industry standard. R565 engine canister per solenoid circuit failure. You might not be able to understand, but who work on automobile sector, they would understand these terminology. So that's where your domain knowledge comes in handy. That's where you need business analyst and functional analyst. Okay, grouping the assets. Again, grouping the assets to get this is what I have done over here. Just grouped it based on the reason count, which are the different unique reason for which asset has failed, how many parts in total has been used in count, what is the unique type of parts and total quantity of each and every parts that has been used. Okay, so I created a new data set, reasons, although there are 14 reasons, but maximum reasons, unique reasons associated with an asset is 9. Maximum reasons associated with any asset is what? The number is 9 over here. So unique reasons. Okay, maximum is 9 over here. So although reasons are 14, but at a time for one asset, maximum reasons is 9. One asset has failed with 9 reasons. Maximum unique parts for maintenance service is 314. This is what I have. Quantity that has been used in total maximum is 5509. Okay, fine. So now we will check for each and every reasons, what is available reasons and all this thing for each and every asset, how many times it has failed. These are different reasons. I created a pivot table, how many times, what is the count also you can take, and you can also give the quantity. I'm taking this quantity field over here, that how many different parts have been used. Okay, how many different parts have been used. You can put numbers also over here. All 14 reasons are placed in columns. The values under every reason, again, assess is the sum of the parts quantity. So what it says is, this asset failed with this reason, and over here 88 means whatever parts were used, quantity was 88. For this reason, it was 106. For 707, 194 it has been used. Okay. So now if you do describe and all this, you will get the values. For all the 14 reasons, maximum value is in different number ranges. If you see, the max values are in different ranges. This could be a real scenario. Why it could be a real scenario? So this is what a top 3 maintenance reasons that I have over here is. I created a pivot table. What are the top 3 different maintenance reasons for each and every asset? Okay, I took only 5 assets over here. If you see 50707, which was the top reason for failure, it has come in 4 of them. This is taking the second position, but yes, it is overall present in all the 5 assets we have. So just by looking at the snapshots of the top reason by assets, we can infer that there are 3 top reasons that is related to the maintenance service for all the assets. This already we spoke about. These are the top reasons. How I created this? I created a pivot table. I use a temporary function using lambda over here. Okay, aggregated, sorted my, removed my first column and third column I took it, sorted it, took just 3 columns only I took, top 1, top 2, top 3. And that's where I created what is the count that I am having for each one of them. Based on that count, I am giving you the top reasons. Okay, so this has failed most number of time with R707. This has failed second most number of times with this reason. Like that, we can see that what are the reason failures. I'm not going into the code, guys, because again, code is something that you can get from internet that is quite easily available. Okay. So max values, total quantity parts by each and every region. This is what we are having. Okay. Each and every region, how many different parts you have. If you see, these are the top regions, and definitely they would have consumed more parts. So 89% of the total parts quantity have been consumed with these three regions only. Okay. Now what we are going to do is that I'm going to create the bins over here. What are these bins for? Low and high bins, two bins I am creating. Parts quantity equal to 1, quantity more than 1. Okay, this is the bins that I created, quantity categories. And then how many high I have? 30%. How many low I have is 69%. What insight will this high and low will give me? Normally, you have seen this in your PDS Python for data science, the cut command. I'm using that command only. How it will help me? Portions of low and high categories in total parts consumption. Low category, almost 70% of the total parts consumed are those parts where the quantity used is only one. That could be the big sized components or the critical components. Based on that, based on reason, you can maintain your inventory. And based on that, your costing will also depend. High category, almost 30% of the total parts consumed are those parts where quantity used is greater than one, probably small size or non-critical components, which will always be available in your inventory. This is what you can look at from inventory management perspective. Based on this, I created another view of the pivot table, low and high, like this. Top reasons for failure in low categories. These are the top reasons for your failure. In high categories, these are the reasons for your failure, top reasons for your failure. This is not in ascending order. Over here also, this is the main reason. And over here also, this is the main reason, that is for failure, R707. So you can have it in ascending order also in pivot table and see how your values are coming. So reasons, 70, these were the top three reasons. Low quantity, these many parts are required. High quantity, these many parts are required. So like that, you can see that parts quantity, how much is required from each and every asset, or each and every reason for failure. These are low, these are high quantities. Okay. Now I'm merging my usage data and part consumption data set. Okay. This is fixing the number of assets. We will use the maintenance failure data set, whatever we got over there unique, because that is the one on which you have to do this thing. So I'm merging my data. Okay. So dropping the failure bin column that I don't need as of now. Right now, I'm not needing it because I just want to have the assets, unique assets over here, which I can use to merge my both the tables, that is usage as well as maintenance. You can definitely, I have used it later to get the failures also, because that's my target column. So got it, left join and all this thing. I'm getting all the variables over here. Each and every column, this is number of times it has failed for each and every asset. Now I have unique rows over here. So data set is merged and we get the new data set. R782 has 0 parts. We can drop this thing. We already discussed. So we are deleting this thing. And after this, you can do analysis on your joint data set. This is your correlation analysis, how each and every component is related. 17 variables, only 7 variables have better correlation. We will choose the 7 variables for further analysis. 7 variables are listed over here. Okay, they are having better correlation. So based on that, I removed it. I'm analyzing based on this. Further, you can analyze. But when you're doing modeling, you can consider all of them. You can do PC I won't suggest. You can do some feature engineering based on your cart model, come up with the best features, and then you can take a call which one I have to select. So these are my features that I selected. This is the correlation plot. Now I don't see any much high correlation except for the service count, time in service that we already know, distance service that would be there, which is legitimate. I can't remove. I need to handle this. Okay. This is the different correlations that I created for each and every variable. Same thing, same table. You can see that way also, getting the top 10 correlations. These are just few ways to view all this stuff.
Welcome to this case study session on used smartphone price prediction. In this session, we will analyze the data for used phones and build various regression models to predict the price of a used phone and identify factors that significantly influence it.
So during this case study, we are going to understand an application of regression techniques, which is to build various type of models. And we will also be performing an extensive EDA on it, right? So the case study is about, as I said, the refurbished phone industry, wherein, these days during COVID, everyone's trying to save some money, be it on any of the unnecessary costs that, people generally do. So there has been more focus on refurbished items, not just with mobile phones, but with also the automobile industry, we can say. It has been growing at a rapid pace. And this type of problem you can relate to any of the services wherein, it is coming from market, from some other owners, and people are buying it now just to save cost and to look for some more viable options and in a cost effective manner. So there is a startup, let's say, who's trying to settle into the market, who's going to deal in smartphones mostly, and they are trying to understand the various factors which influences the price of a used smartphone. And we have some sample data for it, which we'll use in order to build various algorithms and to help that business price the phones effectively so that they don't end up with losses, right? So we want to look at the various features of a smartphone and then price them accordingly. So the data dictionary that we will be following today has 15 variables. Namely speaking, it starts with the brand name. So what is the make and model of the phone, right? Then the operating system. Then you have the screen size of the mobile phone. It's in centimeters. Is the mobile phone 4G supported? Is it 5G supported? Yes or no? Then what's the resolution for the main camera, the rear camera? What's the resolution for the selfie camera, the front camera, right? What is the internal memory? So the ROM, right? If it is 32 GB, 64 GB, 128 GB, what is the capacity? Then you have the RAM, the processing power of the phone, right? The battery in milliampere, weight of the phone in grams, the release year, in which year the phone was released by the manufacturer, then the number of days the phone has been used, right? The selling price of a new phone of similar make and model, and the prices are given in euros. So this is the data from the European nation. So you can say new price is the price at which a new phone is being sold, and used price is the price of the phone in the market for the refurbished one. So we're going to take a look at all these features, and this is going to be our dependent variable, which is used price that we are going to predict. So we have already gone through the data dictionary. Let's start by importing all the necessary libraries first. So as you can see here in the libraries, we are going to use linear regression. Then we will also fit decision tree regressor, random forest, AdaBoost, gradient boost, and then something called a stacking regressor, right? Stacking regressor is basically a heterogeneous ensemble of various models. Just like random forest, you can say is an ensemble, which is all the models in the background is cut, a decision tree, right? Similar kind of models. But stacking is, if I want to combine, let's say, a random forest with the AdaBoost with a gradient boosting. That's how a stacking regressor works. So we'll take a look at stacking as well, which is a combination of various models to see if one of the algorithm is not giving result. Can I combine all of them to get a good result or not? Then we are also going to look at neural network and XGBoost, which is based on boosting techniques. So let's read the data, understand what is the shape and size. So there are about 3,500 observations we have with 15 variables in total. These are the variable names as we just discussed and the data that is available within those variables. So you can see the brand name, all of names available here, which say Samsung, Sony, others, Vivo, LG, Apple, Asus, Realme and all. Operating system, mostly you'd find Android, iOS, Windows, others. Then you have the screen size in centimeter. Is the phone 4G supported or not? Yes and no. Is the phone 5G supported or not? the resolution for the main camera and the secondary camera, which is your selfie cam, then the internal memory in GB, RAM again in gigabytes, battery in milliampere, then you have the weight of the phone in grams, the release year, number of days the phone has been used, what is the price in euros for a new phone of same make and model, and what is the price of the used phone that it is being offered for. So we have this sample of about 3,571 observations, which we are going to use to build a model and deploy this model. If let's say if I get a good accuracy on it, I want to deploy this model too in order to get future predictions, appropriate prediction based on these features. So let's quickly look at the structure of the data. So we have in total 9 floats and 2 integers. So 11 numeric variables and 4 objects. 4 objects relates to 4G and 5G, 2 which are binary. So instead of yes and no, we can say this is ones and zeros. We're going to convert them into ones and zeros. And for brand name and operating system, maybe we can go ahead and create some dummy variables towards the end. So that's how we'll convert everything to numeric and then put model on it. If you look at the number summary, so for the numeric variables, let's suppose for some of the important aspects of a phone, like the resolution of the main camera, we have a minimum of 0.08 megapixel and a maximum of 48 megapixel. So it clearly shows there are some phones here that are available, which are feature phones, not really smartphones, right? Just like you have some featured phones which are available within 1,000, 2,000 rupees in the market, where you don't get much of a clear camera, right? And these are budget phones, we can say. Same with the memory. So you have some phones which does not have any internal memory. You have to add a memory card in order to use those phones, right? And phones as high as with 1 terabyte of memory. For the RAM as well, these basic feature phones does not have any sort of RAM. And the maximum we have here is 16 GB, right? With battery 80 mAh minimum and a maximum of 12,000 mAh, right? The least year is 2020. So let's say if we are in 2021, so the earliest available phone is 1 year old at least, and the maximum is 8 years old. Where the newest phone available is 91 days used, and the maximum is more than 3 years. The average price of a new smartphone is 109 euros. And the average price of all the new phones in this data is about 237 euros. So we can get an idea that the phones are approximately priced 50% or less, right? If you look at the describe of the object variables, so we've got 34 unique brands in this data with 4 unique operating system, majority of the observations being Android phones, with most of the phones are 4G supported and majority of the phones are not 5G supported because 5G is not yet available in all the countries. So let's say if 5G is available limited areas, then there will be only a couple of phones which are going to be using 5G. For that matter, in India, let's suppose in India also, we don't have a 5G band available. There are a lot of phones that are 5G supported already, right? So similarly, we can say that this data might be for that duration when 5G just announced or is going to launch in future in those countries, and people are expecting to buy a 5G phone too. So by looking at this summary, we get some idea about the distribution and about some of the outliers, if there are any. Let's go ahead and analyze them in a univariate, bivariate scenario where we plot and understand what are the most significant factors that affect the price of a phone. So what we can do is in the bivariate standpoint, I can use price as one of the variables and I can compare it with the rest of the independent variables to understand the impact of each one, whether they are going to be a significant predictor or not. But before we do that, I'm replacing the yes and no in 4G and 5G with 1 and 0. So I'm replacing yes with 1 and no with 0 in both the variables. So now if you look at head, there are only 2 variables which are strings. Everything else is already numeric. So let's go ahead and look at the distribution of these 2 categorical variables, which is string. So first of all is the brand name, which is 34 unique brands, and we can see others is dominant, which means not categorized in the list here. And the most available phone after others is for Samsung. and then Huawei, LG. So we can say these are the top 3-4 brands that captures most of the market, right? But you can see there are a lot of other brands as well. And the minimum ones are OnePlus, BlackBerry, Microsoft, and all. Probably because these phones do not have much wide range. They have like a couple of models only. But coming to Samsung, Huawei, or LG, they have a lot of models to choose from. So people prefer to choose from different models, and that's why they have a higher market share, right? Related to the operating system, majority of the phones dominant on Androids. Then you have others like some OEM specific softwares like Huawei. Google has banned Huawei to use Android. So they have come up with their own operating system. Similarly, Samsung also, for some of the phones, they use their own operating systems. They don't use Android or Windows. Then you have Windows predominantly used in Microsoft phones and also used by Nokia a lot. iOS used by Apple only. So there are only 56 phones in the market out of 3,500, which is Apple, which shows that people are not ready to sell out their Apple phones that easily. They are very satisfied with that phone and they want to keep them and using them. Okay, so let's go ahead and look at visualization. First, I'm going to compare the used price against the new price to understand the relationship between them. And this plot giving us a very good idea that if I'm going to buy a new price or I'm going to buy a phone with a higher new price, the used price of that phone is also going to be higher. So there seems to be a very good linear relationship between the two. This would turn out to be a significant predictor. Now, when we say we want to build a model, generally, one tip that I want to give you all is analyze and use those features which you are going to see in testing data. Now, there will be some data sets where some of the data points will be added post the prediction, right? Let's say I take a different example, let's say of a loan default. I'm going to analyze the customer's information like their credit score, their age, and their transactions, their previous loans and all. And then I'm going to decide whether I want to give them a loan or not. Let's say I decide to give them a loan. Now I also am capturing what is their tenure of the loan because I've given them a loan. What is the amount of loan that I have given them? Now these two variables, if we have in the data set, are you likely to see those in the test set? Test set means in future, if you want to screen an application for loan, are you likely to see the tenure and the approved loan amount? No, because that will be added post the decision has been taken to give them a loan. So those two variables, although a part of data set, are not going to be very useful for building a model because you will not get any observations for it. So you need to identify such kind of variables in the data and then remove them from the data set first because those are not likely to be present in your future observations. And that is where you have to think about the data a lot that, if you have 15 or 20 features, which are the features which you are likely to see in coming future and just keep them only, right? So new price is one of the features we can say that will always be available. So if I'm going to market to buy a used phone, I would know what is the price of the same phone for a new one. So this is going to be a very significant predictor in order to understand for the used price. And we have already seen the relation, right? New price or the used price is almost half of the new price. And we'll validate that once we do the prediction. Let's go ahead and look at some of the other features. So if we compare the used price with the number of days the phone has been used, we see there is no such relationship, right? There's not much of relationship within the price bucket of 250, we can say. So this range, if you look at this highlighted range, there's no such relationship. But if we look at the relationship here, above 250 euros, there seems to be some bit of positive relationship. That if the number of days used is increasing, it seems that some of the price is increasing, some of the price is decreasing too. So there seems to be a mixed trend, right? We can identify the relationship directly by just calling out a heat map or saying what is the correlation between these two values that will give us a better idea. But from the plot, it looks like a mixed relation. More or less, we can say it's not going to be that significant as we have new price because it clearly shows a linear relationship between the two. Similarly, for the year of release, we can see there is some trend with the most recent phones fetching a higher price, phones from a very past fetching a lower price, right? Understandably, newer phones will give you a higher price and old phones will give you a lower price. Then if you look at the weight of the phone, not so much of great relationship here. We can say it's kind of a random scatter. Doesn't matter what is the weight of the phone, the used price might not be related to weight. If you look at battery capacity, again, the same thing. Seems like some of the positive relationship. If the battery is increasing, used price is also increasing, but slightly, not that great. This is from the RAM. Again, doesn't seem to have that much of relationship. We see that the highest prices that we've got is for these three buckets. If the phone is from 4 to 8 GB, we can say maximum number of phones fall into this bucket and you get higher price for them with respect to the others. If you look at the internal memory, again, the same. Most of the concentration that you have is within 200 GB, and some phones which offers a very high memory as well. Selfie camera, most of the concentration you can see within 10 to 25 megapixel, right, which has a higher price for used phone. Not good of a relationship, we can say. It's kind of a random scatter too. With respect to the rear camera, the main camera, we see some bit relationship. So the price is more when the rear camera has a higher capacity or has a higher resolution. With respect to the screen size, again, we see some positive relationship going on where the screen size is increasing, the price is also increasing, right? Some bit of relationship. And finally, the operating system. So we see that the price is almost similar in case of iOS, others, and Windows. We can see like the normal range is from 0 to 750 with some outliers in Androids. Whereas Windows phones does not fetch you higher amount of money. So if someone's selling a used phone which is based on Windows, it will not give them the value for their phone, probably. With iOS and Android has a good distribution. And with respect to brand, so we can see here, Apple being one of the brands is getting the highest prices for the used phones. Huawei is also one of the market leaders wherein they are dominating the market in the used phone space as well with a higher price range, right? Then you have Oppo and Samsung also getting good price. The ones that are not getting price is all the local brands. With Microsoft adopting Windows, you can see the used price phones are very less. Let's look at an average price of all the brands. So we see the average price available in the market for all the phones is the highest for OnePlus, which is above 300 euros, and followed by Apple and then Google. So the highest value that on an average a phone is fetching is highest for OnePlus, followed by Apple. And the same case with operating system, if you see, the highest average price is for iOS, which is above 250 euros. Android on an average is available within 120 euros. Windows is available within 50 to 80 euros. And the other phones, other than these three operating system, is available in less than 50 euros. With respect to 4G, if the phone is 4G compatible, the average price of all the phones is about 140 euros. When the phone is not compatible with 4G, it's only going to fetch you about 50 euros. So there is a very big difference if the phone is 4G supported or not. There's a big difference in the price. And similarly for 5G, you can see the cost went up to 400 euros when the phone is 4G, 5G supported. And if it is not, then the average is about 100 euros. So for 4G, the phone is available with within 150 euros. But if the phone is 5G supported, it is available for more than 400 euros because these might be the latest ones in the market. And the most recent phone will give you a higher price as compared to the old phones. Okay. So if you look at which brand offers what type of operating system, this gives us a very good market share. That Microsoft is one of the brands which has adopted only Windows operating system, with Apple adopting iOS and others. So in some earlier versions of maybe Apple, they might have used some of the other operating system, or might be this is some data entry error. But if you look at some of the brands like Coolpad, Gionee, Google, or let's say Infinix, Carbon, these are all Android-based phones. They do not adopt or they do not have any model which is for a different platform. With Nokia has an equal share of Android and others, and with some share of Windows too. So this gives you a market composition of what brand is accepting what type of platforms for their phones. Finally, if you look at the correlation between all the numbers, because this is where we will be most interested. If you are going to build a regression model, probably for linear regression, you don't want our data to be highly correlated because that will lead to a problem, multicollinearity. So if you look at the relationships within the data here, the maximum that I can see is maybe 0.74, which is battery and screen size. If the screen size increases, battery increases. The next best is available under release year and selfie cam. So the more latest phone, the higher the resolution of selfie camera. And then there is 0.93 as well here, which is between new price and used price. So this was the first of the plot that we saw, right? 93% correlation between new price and old price. So the most significant factor that influenced the price of a used smartphone is going to be the price of new phone of that same make and model. So if I'm going to buy, let's say, an iPhone 10, and it is available in some euros, the price of the new phone at that time for iPhone 10 would highly impact it. So we can say this is one of the major criteria of identifying the price of a used phone, right? New phone price. This is going to skew the result a lot. And then we have battery, screen size, selfie cam, and all. But there is no such multicollinearity issue as we can say, right? Relationship with the dependent variable is fine. Within the independent variables, we don't have anything above 0.75. Even we have only two pairs, which is 0.7. So you can say the data is still good. There is no problem multicollinearity here, right? Now moving on to some data cleaning steps. If you look at the number of missing values, we have 180 missing values in the main camera and small number of missing values in some of the other variables. This is the major one where we have 118 missing values, which is contributing to approximately 5% of the overall data. 5% is a significant number, so we can't really calculate a mean or median of the overall data and replace it, these missing values with it. So what I'm going to do here is first understand where are those missing values and which brands, and then probably take a brand-wise median. So if I group by brand and look at the median of the main camera. So for Acer, the median resolution is 5 megapixel. For Alcatel, it is 5. For Apple, it is 12. So I've calculated a median for all the brands. And then what we are going to do is for wherever there is a missing value, that brand information is available because it has zero missing value. And based on that brand, I'm going to replace it with the median of that particular brand rather than just taking a median of overall. I'm going to look at brand-wise information and then impute it accordingly. So I group it by brand name and then transform. Basically, I'm filling in a Lambda function to fill in the missing values based on the different brands we have. And then if you look at the missing values, there are still 10 missing values in the main camera. And the reason could be that for Infinix, as you can see here, they have models in the market which do not have a camera available, or maybe for all the observations of the Infinix brand, the main camera was a missing value. And that is why we still have some missing values here. Now, since this is going to be a very small number, as you can see, it is less than 1%, right? 0.2, 0.3% and all. I'm going to replace them with the generic median now. So I say, go ahead and replace it with the median of the overall data. And then if you look at the number of observations, it's all 0. If I want, I can also remove these observations because there are very less number of observations. The main point of concern was replacing the missing values with their respective brand names, right? I have not taken a standard median value, but grouped it by a brand name. And then based on those brands, I have imputed the missing values. Right? That's one of the good ways to do it, right? Whenever you look at some data, rather than having a standard operation on missing values, in the last industry session, I showed you how you can use pipelines and avoid data leakage issues. So you can use that to fill in the missing values. And if you want to do a quick analysis, this is also some of the other ways that you can use, right? Now let's look at the distribution and outliers for all the numerical variables. So I've selected only the continuous variables from the list. So it seems the screen size is right skewed with a lot of outliers on both the ends. With the main camera has some outliers, which is why the data is skewed. And again, it looks like a multi-model data. Selfie cam, again, there are some outliers because of which there is some skewness. The internal memory, there are huge outliers, right? RAM, again, we can say this is one of the discrete value, really not a continuous value. Battery, there are some outliers again in battery as well. Weight of the phone, days used is probably one of the only variables where we do not have any outliers in it. But the distribution is skewed and it's kind of a bi-model data, as you can see. And the new price is also skewed. Let me also include the used price just to understand the distribution of the used price too. So if we run it again, the dependent variable, which is used price, is also heavily skewed towards the right. Now, you might have learned that during or while building a linear regression, if your dependent variable is highly skewed, you are probably not going to satisfy all the assumptions related to it, right? Like the residuals will not follow normality. Maybe the residuals are also not going to be homogeneous, or you can say it will not follow homoscedasticity, right? There might be a good pattern between the residuals and the predicted values. So in order to avoid all of that situation, we transform this generally whenever we are trying to build a linear regression. So we can transform it using a log scale, an exponent scale, or we can do a Box-Cox transformation. But since we are going to fit other type of models too, we are going to look at the application of linear regression with comparison to the other modeling techniques, right? That do we really have to build a linear regression if the data is not supporting linear regression facts? Because if we also look at the correlations here, there is not much of correlation with the dependent variable. For the used price, which is the dependent variable, the independent variables does not have a high correlation except for the new price. After new price, the highest correlation that we see is for days used, which is 47%. And that's a negative relationship. The more number of days the phone is used, the lower the price is. And then everything is less than 0.5. Probably 0.5 is RAM and 5G. But we see that there is not much of relationship, right? There's no significant relationship as such. So linear regression might not be a good fit for this kind of data because there is no significant linear relationship between the dependent and independent variables. So we'll see that if linear regression gives us a good fit or not. But let's just quickly remove these outliers first. So we have outliers in almost every variable except for days used. So what we are going to do is cap the boundaries. So I say wherever there is an outlier outside the upper whisker, cap the value at upper whisker, or if there is an outlier below the lower whisker, cap the value at lower whisker. Right? It's a standard outlier process that we will follow. So I create a user-defined function to calculate the first and the third quartile and then calculate the upper level and the lower level at 1.5 IQRs. And by running a loop on all the variables where we had outliers, I'm going to cap it there. So all the outliers now being treated with all these values that you have are capped at whiskers. So two of the most important data pre-processing steps or data cleaning step, which is to impute the missing value and outlier treatment, has been done. Let's go ahead and now prepare the data for modeling. So we create our X and Y's, which is a list of all the independent variables and the dependent variable only. So I'm going to use these 14 variables that you have here as independent variables and one variable which we are going to use for dependent variable. For brand name and operating system, because these are still characters, I'm going to create dummy variables for them. So the data now looks like this, which is dummy for the brand names and the operating system and some of the numeric features that were already there in the data. And then I go ahead and split it into 70-30. Right? Now, this 70-30, we are going to build various models on. I'm going to fit the training set to build the model and will validate it on the test set. So starting with linear regression, right? Let's see how it performs. So we fit the linear regression on the training set here. And if you look at the coefficients of all the independent variables, you'd find that coefficient of some of the variables is very high and for others is very low. For example, let's say 120 for 5G. So if a phone is 5G supported, it automatically, based on this coefficient, fetches you 120 euros more, right? With every gram increase in weight, it's saying that the cost or the price of the phone also increases by 0.16 euros. For every release year increase, the price increases by 5.7 euros. For every day use of a smartphone, the price reduces by 0.10 euros. So you can read the coefficients and understand which are the most important coefficients here. If you look at the intercept, it's minus 11412. So it's a negative. Intercept is just a constant. We don't really read this number just like we do for slopes. If we go ahead and predict it on the training and the testing set both, let's look at the R-square value. So the R-square value that we are able to achieve on the training set is 73% and on the test set is 78%, which seems to be an okay model because anything above 0.75 is considered to be a good model. And we are able to achieve 75% on the test set, and the difference between train and test is still within 10%. So I can say it's not overfitting or underfitting. It's a valid model where we are able to achieve close to 80% accuracy or 80% of variance explained in the used price with respect to all the independent variables we have. Let's evaluate on the basis of RMSE. So what is RMSE? It is root mean square error, right? So read it backwards. Error first. What is error? Error is nothing but the difference between actual and predicted value. And then you take a square of those errors, because if you take a mean of all the errors, they will cancel each other. That is why we take a square of all those errors and then add all the errors to calculate a mean. And then we take a square root of that number. So RMSE in general represents what is the average error in your model. How far is your actual value and the predicted value on an average? So it says the error in the training set is about 63 euros and in the test set it is 53 euros. So which means if the price of the used smartphone is 100 euros, I'm predicting it with a variance of 53 plus minus euros on the test set, which seems to be a very high value, right? If we look at the model diagnostic, this is predictive analytics. Now we are moving on to diagnostic analytics. What is diagnostic analytics? Basically, whatever you have built as a solution, you validate it. But then now you want to understand what is the impact of your model on the data that is there. That is diagnostic analytics. So I create a data frame of only 3 variables, which is the actual data, the predicted data out of the model, and what is the residual, the difference between the two. And then I'm comparing the predicted data against the residual, which gives us an idea if the model has homoscedasticity or not. So here we can see a clear trend that as the predicted price increases, the residuals or the error in the model goes down and the predicted price is below 0 as well. You can see there are a lot of observations for which the predicted price is less than 0, because this is a coefficient based model. Based on the coefficients, you are likely to see negative values too, which is not true in case of real world scenarios. Can you have a smartphone with 0 or less than 0 price? Which is not possible. It should always be greater than 0. And this is where the dependent variable that we had the skewness in it, right? There was a lot of outliers on the upper end, and because of which there was a skewness. This is the result of that. That linear regression is not giving us a good fit. And also we also saw from the heat map where there was no correlation as such between the dependent variable and the independent variables. Although we are able to get a good R-square value, RMSE is also a good way of understanding the accuracy, which is very high error at the moment, right? And the plot also says that we are predicting okay within a price range of 100 to 200 mostly, right? The residual is very close to 0, but post 200, if the price of the predicted phone increases, the error in the model increases a lot. So one of the assumptions that the residual should follow normal distribution. If you plot the residuals, see, it's not following a normal distribution. Because of the skewness in the original data, you see a skewness in the residuals too. So linear regression is not able to satisfy the assumptions here, we can say. And that is why, even though it has a good R-square value, I cannot use this as a production model. And that's one of the shortcomings of linear regression always. So being the oldest concept available, being the first predictive model to be ever built, linear regression is not that applicable to real world scenarios these days because of the complexities in the data. The relationship is not linear anymore. You'll find weird patterns. You'll find nonlinear relationships for which you can do regularization using L1, L2 penalty terms, which is lasso and ridge regression. That might give you a better result than linear. But again, if you don't have that correlation between the variables, it's going to be very difficult to get a good result in regression terms. That is why we have those other algorithms that model the data in a different way, like decision trees. It doesn't look at the absolute values. It discretizes the data in the background and then builds a hierarchical structure to model it. So within decision trees, you can say it's a parallel processing, might have a higher prone to error and overfitting. That's why you can also try boosting techniques, which is XGBoost, AdaBoost, gradient boosting and all, which works on sequential processing and gives you better results than what a parallel processing does, because it optimizes the results automatically, right? And the same case with neural networks too, because of the back propagation, which is optimizing the model by adjusting the weights and biases again and again. It gives you the most accurate model that is possible, right? So now after linear regression, let's go ahead and compare all those models on the same data and see what are the results. So I'm going to start with random forest first. I've taken some of the randomly chosen hyperparameters. So I'm saying that the max depth of the tree should be 10 levels, 10 branches. And the minimum sample split as 50, which means I should have at least 50 observations in a node in order to consider it for a split. And I fit the training set to it. Let's look at the predictions for random forest. So if you look at the score, which is the R-square value, we've got a very high R-square as compared to linear regression, which was around 75%. Now we've got an R-square, which is around 85%, which is a 10% improvement, a big difference, more than 10% improvement in random forest as compared to linear regression. Now, with this improvement that we have, let's see if we are able to reduce the error. We have been able to reduce the errors too. With 58 euros as a root mean square error in linear regression, we have dropped down to 41. And with the difference between two, we can say this is a valid model. Right? And there are no such assumptions that we need to validate when it comes to random forest. Just like in linear regression, you have a lot of assumptions that you need to validate. There is no such assumption in random forest. Again, random forest is also not impacted by the noise, which means it doesn't have any impact of outliers. It doesn't have any impact of the relationships in the data. So it's one of the most preferred models when it comes to real life values because it models the noise very easily. It is up to us to tune the model properly. If you don't tune the model properly, then it is a, hungry model, or we can say this is a greedy algorithm, which means it overfits very easily, right? So optimization of the hyperparameters is very important. So you can define some of the random numbers, look at the accuracy, and then probably also use grid search in order to optimize it further, right? Try different values and see how the result changes. And then pick the one that is giving you the highest accuracy. If you look at the same pattern that we saw in linear regression in case of random forest, this gives us a very good result as compared to linear regression, where we see that the price is more than zero. First of all, a good check that at least we are predicting a positive value. And then up to 200 euros, it seems the error is almost negligible. Up to this point, right, there is the residuals are on zero line, which means for low cost phones, this model is very accurate. There are not a lot of residuals. Then up to 400 euros, there are some residuals which are close to the zero line. We can say up to 50 or less than 100 euros of difference. But post 400, which is for higher end smartphones, the price is getting really high, or the error we can say is getting really high. So whenever we are recommending a model to the business, we are not just going to say, okay, I've achieved an RMSE of 40 euros. I'm also going to give them this insight that the model works very accurately up to a point of 200 euros. From 200 to 400, this is my error range. And post 400, it's not good. So ideally, I should be using this model in order to predict prices for low-end phones, not for high-end phones. Because for high-end phones, there is a high variance in all the other parameters. That's why we have a lot of noise in the data and high errors. But for normal range phones, it's giving us a very accurate result. So you can probably use this in predicting the price for low-end phones. If you look at the feature importance, because random forest has also one of the good thing that it can give you the variable importance. Now, based on this variable importance, if we see the highest important variable is the new price, which is about 80%. So 80% of the splits that has been taken, or 80% of the overall Gini gain that you have in the random forest is because of new price. And from the ED as well, we understood there was a very good linear relationship between the new and the used price. Also on the correlation matrix, it was 93% correlation. So understandably, this is going to be the most important variable. And then the number of days used, which is 15%. So combine these two is 95% of importance, which means if I exclude everything else and just look at what is the new price, what is the price of the new smartphone currently, and how many days it has been used, these two variables should be able to give me the price of the used phone. These are the two most significant factors. Doesn't depend on brand, doesn't depend on operating system, doesn't depend if it has a 4G or 5G, but it depends on the number of days the phone has been used and what is the price of the same phone in the market currently. Those are the two most significant variables coming out of this analysis, right? Let's try and fit some of the boosting algorithms too to see if we are able to further improve the results. So I'm fitting AdaBoost again with some random hyperparameters and predict using the same. So the R-square value that we've got here is even better than random forest. On the training set, we've got 98% R-square, and on the test set, we've got 89%. It's approximately 10% difference. We can say it's 9.7%, which is very close to 10, but still considerable. Random forest gave us an 88% R-square on test. This is giving us 89%. So a bit of improvement. But let's see if this improvement also improves the RMSE or not. The RMSE drops down to 38 euros or from 41, which is again a significant dip. If you look at the same residual predictions, right? Now you see it is also predicting price greater than 0, which is good thing. Up to 200, this also has a very low residual. All the residuals are close to the 0 line. And up to 400 as well, it does not have much of a residual. As in random forest, we saw there was a residual of 100 euros and there was a higher scatter. You see, there is a lower scatter in the higher end models. If I scroll back to random forest, you see the highest residual that you have is going up to 600. And on the lower side, it's going up to minus 200. Here, there is one outlier which is going below 400, but on the upper side, it's mostly within 400 euros or mostly within 200 euros on the positive side. So most of the observations, most of the smartphones you have here is within plus minus 200 residual range. So you can probably say slightly better than random forest, if not extremely better, but at least something better than random forest. If you look at gradient boosting, another form of boosting, the R-square drops. And if the R-square is dropping, understandably, the RMSE increases, right? And if you look at the same plot, it's giving you a pattern, which means it's not one of the good models. If you fit a MLP regressor, which is an artificial neural network, so let's say I'm just using one layer. Within one layer, there is 8 neurons, and then I'm using ReLU as the activation function, rectified linear unit. So you can see here, at every step, this is optimizing the error in the model. At the first iteration, second iteration, it is adjusting those weights and biases. And it will keep on reducing it for the number of iterations we have defined. So we have said build 20,000 iterations. And if there are no change in 1,000 iterations, then stop the process. So it is going to check for 20,000 iterations and keep reducing the loss. We started from a loss of 21,349 units. And we have dropped down to 400 and still optimizing, right? So while this is running, let me take one of the questions. Should we treat outliers and null values before doing univariate analysis? So the answer is no, because univariate analysis is done on the data as is. Univariate analysis gives you an idea of what should be a data preparation step. It helps you understand the distributions and everything that will help you to take a decision of what measures to use in case of understanding missing values or how to use outlier treatment. Because there can be various ways in which you want to do that, right? So univariate will give you a better understanding of it. In the meanwhile, this algorithm has converged. So it has taken 10,000 iterations and the loss has been reduced to approximately 425. Let's go and look at the performance of this model. So the R-square value is pretty high, but you can see here the R-square for train is very high as compared to test. This is overfitting, right? We can reduce the overfitting by adjusting the parameters here. but in the interest of time, I'm not doing it. You can run a grid search in order to optimize the parameters, use different solvers. Instead of Adam, use stochastic gradient descent. Instead of ReLU, use the other activation functions like 10H. You can use linear, right? Change the iterations, change the tolerance level, and see if you are able to get a good result. And since it is an overfit result, you see the RMSE is also very high. And if you look at the patterns, pattern-wise residual is almost the same as we saw in the boosting algorithms, where the price prediction starts from negative values. So some of the observations you can see is breaching the zero line. So some of the values are predicted negative because this is overfit model, it is not fitting the data properly. But on the residual side, almost everything is up to 300 euros is very close to zero, on a negative side mostly. And up to 400, there is like similar kind of scatter that we saw in the boosting algorithms and random forest. But residuals goes as high as more than 600 euros on the negative side and on the positive side too. If you look at XGB, which is your XGBoost, a 99% accuracy on train and 89% on test. Again, close to 10%, we can say, we can consider this as a valid model, but almost 100% accuracy on train, which means there is a lot of scope of optimization on the hyperparameter side. Let's look at the result. So this also gives us an RMSE of 38, which is what we also got with AdaBoost. And if you look at the residual analysis here, see for XGBoost, up to 400, the residuals are very close to zero line. For the rest of the algorithms, we saw up to 200, it was close to zero. And then after 200, there was a lot of errors between -100 to +100. But with XGBoost, this is probably the best of the result that we have received so far, right? Where we see that up to 400 price range, we are getting a good prediction, which is mostly zero residual. Post 400, again, for higher price points, higher error. And mostly on the negative side, which means we are predicting high when the actual value is low. So this probably has the best result so far in terms of the residual analysis. Now, since we have understood the performance of individual models, let's quickly go ahead and build a ensemble, which is to combine all of these models together into one. And the most popular ensemble is a stacking model, where we say that from a data set, we build individual models first. So I'm going to create a base learner. This is called the base layer, right? This is where I've fitted random forest, AdaBoost, XGBoost, gradient boosting, linear regression, 6 different kind of models. What we are going to do with stacking is we take the first layer, which we already have, predict out of those layers, put the predictions into another model, and then use that for final model as the predictor to predict the values. So I'm going to create 2 layers of models here. One is called the base layer. This is layer 1 and this is layer 2. So the first layer is the individual models that we have fitted now on the original data. The second layer is going to be fitted on the output of the previous layer. This layer will not be built on the original data. This is going to be built on the predictions from the previous layer. And then I'm going to use this layer 2 model as the final model to predict the actual values out of it. This is called stacking ensemble. Right? You can have more than 2 layers if you want. And the number of algorithms in the base layer can also be 4, 5, 6, whatever you feel, right? So what we are going to do is on the base layer, we are going to consider these 4 algorithms, which is the gradient boosting, the neural network, AdaBoost, and the random forest model. And since XGBoost gave us like a very good prediction on the residual side, I'm going to consider XGBoost as the final model. So the output of all these 4 models will go into the XGBoost model as an input, and from XGBoost we'll get our final predictions. Right? So I'm creating those estimators, and then from the stacking estimators or the stacking regressor that we call from sklearn, I'm going to fit this data. Right? So this is going to create this structure where it will first look at these 4 models, predict from the 4, use those predictions as input for the final layer, and from the final model we are going to finally predict the values. So it's going to take like a couple of minutes in order to fit it, because we are also doing a 5-fold cross validation here just to make sure there is no kind of biasness in the model. In the meantime this is running, I can take a couple of questions. So one of the questions that I have is, can you tell us when and how to impute missing values with mice and KNN and how it will differ from mean median? So theoretically, when you're using a mean or a median approach, you are generally imputing only a single value, right? If the number of missing value is more than 5%, that's what I personally use as my benchmark. Wherever there is a variable with more than 5% values, I will not impute it with mean or median, like a standard. In today's case study as well, you see for 5% missing values, I looked at the missing value brand wise. For respective brands, I imputed the missing values differently. I did not take a standard median of that variable and imputed it directly, right? So out of all those 180 missing values we had, there were different values imputed, not a single value. So mean and median it can be preferred when there are very less count, probably less than 5%. If it is more than 5%, then it is preferred to use techniques that I showed today, which is to look at group-wise median or mean and impute it using that. Or you can also use KNN for that matter. KNN, I showed you in the previous industry session too, that you can use it on both numbers and categories, right? And you do it after you split the data in case of train and test split, right? So there is not much of a difference that you will see as far as the overall result of the model goes. If the number of missing values is very high, let's say 20%, 25%, in those scenarios, you would find some differences. And it is always preferable to use KNN when there are very high count of missing value. If it is between 5 to 10%, still I can use mean median grouped by the other data points we have. But if it is more than 10%, probably an algorithm like KNN is going to give me a better result. Why are we removing outliers? So this is a standard process, right? Even though a random forest does not have any impact of outliers, so we do data processing only once, right? So we've taken a best practice of standardizing the data so that it can be fit to any model. So the objective was to fit multiple models. That is why we treated outliers. Otherwise, we could have taken 2 copies of the data, one only for linear regression where we have done outlier treatment, and another one which is no outlier treatment done for random forest or for the boosting algorithms, right? Any approach is fine. There's no problem with imputing outliers for random forest too. Can we treat outliers in dependent variable? No. So dependent variable, do not ever do any type of treatment on the dependent variable. If there are missing values, go ahead and remove those observations. Do not impute missing values in the dependent variable. Do not do any sort of treatment or outlier treatment on the dependent variable. If it is skewed, you can try transformation, like convert it to log scale, convert it to exponent scale, do a Box-Cox transformation. That is something that you can do on dependent variable, but no outlier treatment, no missing value treatment. If there are missing values, remove those observations. That's the only rule. Do not try to impute it. If there are outliers, try transformation, not outlier treatment. In stacking, are there any considerations to choose base learner? Similarly, what are the considerations to choose the final meta learner? So in stacking regressor, as you see that the base learners are very important, the first layer, because based on the result of the first layer, the final model will be created, right? So you will follow the same approach that I did today, wherein you fit the model to 7-8 algorithms, understand which ones are working the best on that data, and then choose within that. Choose maximum, let's say, of 4, because if you take more, then it is going to be more complicated and your model will be easily overfit. So try to take 3 to 4 models in the base layer, the first layer, depending on which algorithms is giving you a good result while analyzing individually. Take them as the base layer. The best performing model, you can keep it as a final layer. Right? Choose like the 5 best performing models. The best one, keep as the final layer. The 4, you can keep it as base layers. Right? I'll just wait a couple of more minutes for this to finish. It's about to finish, I guess. It is still optimizing the neural network, as you can see, because on 5-fold cross-validation, it is running the process iteratively. Can you explain again when to treat outliers and when not to? So for outlier treatment, algorithms like random forest or decision trees are not impacted by the presence of outlier because it discretizes the data in the background. So the magnitude of the values does not impact the outcome of the algorithm, right? But for algorithms where a distance calculation is involved, like say KNN model or even if you're doing k-means clustering, right, where distances are calculated, algorithms like LDA, which is linear discriminant analysis, again based on distances. So these type of algorithms are going to be impacted by the presence of outliers, right? Coefficient-based algorithms like linear regression, logistic regression, these are also going to be impacted by the presence of outliers, right? For that matter, neural network too will be impacted by the presence of outliers because of the calculation of weights and biases. It takes into account the magnitude of the values. So for these type of algorithms, you will always do an outlier treatment before building the model. And for decision trees, random forest, kind of boosting algorithms, they are not that impacted by outliers. So you can leave outlier treatment for these algorithms. Right? It's about to finish, I guess, last iteration. So for the diamond example here, it is not going to distort your equation for a very simple reason that how many observations will be like that? It is going to be probably less than 4 to 5%. And if you have such anomalies in a very small percentage of data, it's not going to skew the result of the overall analysis, right? So take it from those point of view. Can we remove outliers instead of capping it? So ideally, yes, you can do it, but then depends on how many observations you'll end up removing in that case, right? If you want to remove outliers from the data, then you will have to check multivariate outliers. What we did was univariate outliers. We looked at individual variables and identify outliers only in that particular variable. There are also ways in which you can deal with multivariate outliers, right? So multivariate outlier treatment is done using a lot of algorithms that are present. One of the algorithm names that I'm going to give you, you can explore on your own, is isolation forest, right? Go ahead and search for isolation forest. It is one of the best algorithms available to identify outliers in the data and remove them. So it gives you an observation-wise detail that which observation is an outlier as compared to the other observation. It doesn't look at one variable, it looks at all the variables at once. Okay, so the model has converged here. Let's go and look at the performance of the stacking regressor. The RMSE is pretty good. The R-square value is pretty good. 94% train, 87% test. Within 10%, we can say the model is valid. If you look at RMSE, it's 41, which is again similar to what we got with random forest, but not as good as AdaBoost, where the RMSE was 38. If you look at the residual analysis, it also gives us the similar kind of result, wherein up to 200 it says that the residuals are very low. Up to 400 there's a little higher scatter, and above 400 it's very high. So it's similar kind of result that we also got with AdaBoost, with XGBoost, random forest. Now, if I have to compare all of them, so what I am going to do is create a data frame from the accuracy of all the models so that it can be compared at a single place. So all the accuracies that we have been seeing so far, I was saving them in a separate object. As you can see here, I'm saving the RMSE in an object. I'm saving the R-square value in an object. And similar to this, I've been saving it for all the algorithms. And finally, I'm comparing all of them in the form of a data frame. So this gives me the summary of everything that we have done today. We have fitted 7 different models. This is the training and the testing R-square values. This is the training and testing RMSE values. And then I've calculated the difference in score, which means what is the difference between the R-square value of train and test. And this is sorted in the ascending order of the differences. So we see the difference in the random forest model was the least, which is about 1.5%, where the test set was 87% R-square and the RMSE was 41. Even the difference between RMSE of train and test was more aligned. Followed by linear regression, where the test R-square and the RMSE was very high. So we can exclude this from our conclusion, right? The next best was 38 RMSE and 89% R-square, but the difference was approximately 10%. Now, if I have to take a call between random forest, AdaBoost or XGBoost, I would prefer random forest. For the simple reason, it might be slightly on the higher side of RMSE. The R-square values are almost comparable. We can say 87, 89, there's not much of a difference, just of 2%. But the difference in the train and test set is very less, which means this is more consistent on seen and unseen data both. AdaBoost and XGBoost is performing with a range of 10%, almost. on the words of overfitting or underfitting. Random forest is more stable, we can say, more aligned and on both the sets. So out of all the algorithms here, I will pick random forest as my final model. And if I have to recommend this to the business, I'll go back to random forest and say that this model is giving us a very good prediction up to 200 euros phones. From 200 to 400, there is slight bit of error, which is less than 100 euros. And after 400, we cannot use the model because the error is too high. With this predicted values from the random forest model, I have just looked at the residual analysis. I can also go back and see what is the impact on each of the independent variables. When I predict the price, when I'm predicting it very high, how is it the predicted price is compared to the actual price of the phone? How is it related to the number of days used? So you'll see all of those as a diagnostic analytics. And basis whatever is the result, you go back with the recommendations accordingly. So this was like a case study on regression analysis based on different models to predict the price of a used smartphone. So we identified two factors which are most important. One is the price of the same phone which is in the market right now. And second is how old that phone is, how many days it has been used. Those are the most significant factors in deciding the price. And if we know this, we should be able to predict the price with a 95% accuracy. That's what random forest is saying. These two are 95% important. After that, you have the internal memory, the weight of the phone. The only brand name that is coming up as a higher importance, which is less than 1%, but still with respect to everything else, it's Xiaomi. Probably Xiaomi is because it's the world's leading smartphone company right now. And then 5G, because obviously people want their phone to be compatible with the upcoming technologies, right? Some of the important factors that decides the price of a phone. And I specifically explained how to do diagnostic analytics today.
Now we are going to use what? We are going to use salary expectations based on experienced project. But here we have used one Kaggle dataset, that is salary.csv. Right. So here we are going to use basically 3 to 4 libraries. One is pandas, one is numpy. Numpy and pandas is basically used for numerical Python numpy, and pandas is nothing but the data manipulation tool. Let me just execute that. Now, if you just want to upload a data set in your Google Colab, how to do that? Just click over, let me just make it little big. So just click over these files and here you will get the option. Just click over this upload option. If you click over it, you will get the option whatever the dataset you have in your dataset, in your local system. If you already downloaded from Kaggle or if you already downloaded from Great Learning Academy, you can directly upload it from over here. Right. So I have my dataset salary.csv in my system. So I have uploaded that. Now, after uploading that, you need to read the CSV file. What is CSV file? CSV file is nothing but comma separated value. Okay, so in this case, what we need to write, data equals to pd.readcsv. PD is nothing but your pandas, right? Pandas.readcsv function is going to help you to it's going to help you to read the comma separated file. Okay, now if we just look at that key, if your data is already stored in the data variable or not, what you need to do, you just need to write data.head. What is data.head? Data.head is nothing but it's going to give you the first 5 rows of your data. So now, as we have seen that what is we have in data.head, we have year of experience, we have salary. So basically, if you have experience of 1.1 years, you can expect a salary of 39,343. Right? Or if you have experience of 1.3 years, then you can expect a salary of 46,205. For if you have a experience of 1.5, then maybe you can expect a salary of 37,731. Right? There are few few experience are there, and with that salary, respectively salary. Now, if you want to see what are the columns you have in your data, you just need to write data.columns. It will return you what are the columns you have in your data set. Now, if you want to go for some statistical, when we talk about the exploratory data analysis, right? So if you want to go and check the what is the data dot describe, it's going to give you the total count of rows you have, what is the mean for every column, what is the standard deviation for every column you have, right? And what is the minimum value you have in your data set. You can see for the minimum we have 1.1, for salary I have 3773 1.0. So in this case you can say, okay, so I can conclude I don't have any missing value, right? We will talk about that. So for most of the data set, if you go for using the practical data set, you will get the two main thing. One is the missing value, one is outlier, right? We will talk about that. For 25%, 50% and 75% is nothing but your IQR, that is interquartile range, right? So yeah, these are the described. Now if you want to check is there any null value you have in your data set or not, what you need to write, you just need to write data dot is null. So if you just write data dot is null, it's going to return you boolean value, true or false. You can see for all the rows it's giving me false, 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 false. But in this case, I want to check for each and every column, not for each and every row. That time you just need to use one more function called dot any function. In the dot any function, you can see data dot is null dot any. It's giving me false for all the cases. For year of experience and salary, I can say or I can conclude that okay, maybe our data has no null value. Now if you want to see the sum of it, you can use dot any or you can use dot sum. Dot sum is nothing but it's going to sum that what is the missing value you have in your data set. Okay, now we are going to use again two library for matplotlib and seaborn. Both matplotlib and seaborn are used for data visualization. So we try to visualize our few data from the data set. How to do that? For that we are going to use dot plot function, and we are going to use two particular column for two particular columns. For X we are going to use salary, for Y we are going to use year of experience. So when we have plotted it, you can see the curve is not at all smooth. There are lots of variations are there. For 40,000 to experience 1 to 14, 2 to 14 we have, and there are lots of variation you can see in the data intergraph itself. So yeah, it's not going to help you a lot for this particular data set to look at the data visualization, but yeah, there are lots of data set you will get where actually you can understand your data in a more precise way when we go for using data visualization. We are going to make a model, right? How to make a model and why to make a model. So for the model itself, what we are going to do, we are going to drop a particular column, that is salary column, right? And we are going to also import sklearn.model selection import train test split, right? So it's basically nothing but it will split your dataset in train and testing. Now what we are going to do, as we are going to see, we have actually imported import train test split. And guys, one more thing, that is for machine learning we use a library called scikit-learn. So sklearn we use for machine learning. For all the cases there are lots of functions are there. There are lots of, if you go for using linear regression or if you go for using logistic regression, everything is there, right? So you don't need to take care, you don't need to take tension for that. You need to write everything from the scratch. No, right? So in this case, what we are going to do for the X, we are going to take all the dependent variable, right? So if you just look at here, right, for X we are going to take year of experience. For Y we are going to take this salary, because for X I just want to take all the independent variable. So what we have done to drop a particular column from the data frame, so in that case we are going to use dot drop function. So when we have written data dot drop and we have mentioned the column name salary and X is equals to 1, it will automatically drop the salary from your data frame. Now if you just print X, you can see all the experience. Can you see the years of experience? You don't know the salary. So now you can see that what X consists of. Now Y will have only the salary. So you can see Y, I have printed Y dot height. So you will get the first 5 rows of your data. That's nothing but your salary. Now we are going to split our data. How to split our data? We are going to write x train, x test, y train, y test equals to train test split, and we are going to provide x and y both. And the test size we want 80-20%. Train test split is something we are going to split and like our data. So in this part, test size equals to 0.2. What does that mean? Okay, so you can see for x and y, I have written test size equals to 0.2. What does that mean? So basically your training part will be 80% and 20% data will be unseen data for your model, and the 20% data will be shown after your model get trained, right? So this will be your ratio. Now random state equals to 42. So what is this random state equals to 42? So there is no hard and fast rule that first 80% will be used for what? The first 80% will be used for training, for the last 20% will be used for testing, and vice versa. There is no hard and fast rule. So when you put the random state equals to 42, it's basically take data from anywhere for testing and they take data from anywhere for training, right? So this is all about training and testing and splitting the data. So okay, now what we are going to do, we are going to make a model. How to make the model? We are going to import linear regression from sklearn. So for that, what we are going to do, we are going to write from sklearn dot linear model, we are going to import linear regression, right? So when we are trying to import linear regression, because we are going to use linear regression algorithm. Okay, so in this case, we are going to call the linear regression function. You can see we have written L equals to linear regression. Then when we are trying to fit our model, basically train our model, we will call a function called dot fit. So L dot fit, and we will provide x train and y train. You can see after that, if you just do L, let me just do that. Right, you can see your model get trained. Now if you just try to check the prediction for the classes, what you need to do, you just need to provide x test, that is your experience, right? Not the salary. When you write that ypred equals to L dot predict and you give x test, that time it will give the prediction. And if you see the prediction, let me just show you what prediction you will get. Right? So this is something you get 1,10,576 according to the, if I go for writing this, then if you just write x test, right? Let me just check, not x test, y test. If you can see, your y prediction is 110576 and y test is 116969. Not a bad prediction here, right? And here you have 64251, here you have 57081, right? Here you have 109431 and here you have 103713, right? So yeah, so you can actually solve the, you can see your model is predicting pretty well. And if you want to check the score, accuracy score for your model, you just need to call the function called L.score and you have to provide x test and y test. Then you will get the total accuracy. So total accuracy for your model is 89%. So it's not working bad. So if you add few more things, obviously you can add them. So when you have a data with outcome or with class with 0 and 1, you cannot use linear regression. But when your data have a scores like 10, 15, 16, like grade like that time you can go for using linear regression because it's a continuous type variable you have. Right? So you can say it always works with continuous value, not with the binary data or the discrete data. Now there is a formula for linear regression. We have that formula known as y equals to mx plus c. So I think you guys have idea about y equals to mx plus c. That's the normal straight line formula it is. So where n equals to slope of the line and c equals to intercept. Right? Main target for linear regression to find the base value of k and base value for x and y, right? So this is pretty much about linear regression. Now we will start with our project. Let me tell you, we are going to use Google Colab. So we are going to use one particular ID for this. This is nothing but Google Colab. We don't need to install anything because there is a reason for Google Colab is supported from Google for AI developers, and you will get lots of new features in Google Colab. I will show you how to start with Google Colab. Just write Google Colab in your browser. Click on the first link, and here you just need to go to new notebook, right? When you create this particular new notebook, it will automatically give you a workplace where you can actually start with your Python, and you can see this is your notebook place, and here there is a box sign. If you just click over here, right, you can see this is your kernel is connecting. When it will be connected now, you will get an option to upload, right? Here you will get an option to upload to session storage. So if you want to upload your data set, you can click over here, and where you have your data set in the local system, click and enter, right? And one thing you have to remember, that 12 hours thing. So you have your code, your data set for 12 hours in your Google Colab. After that, it will be removed. So whatever you are working with Google Colab, be sure that is saved. Don't forget to save that. Google Colab is not paid. It's free of cost by Google. Yeah, so this is pretty much about Google Colab. Now as we have taken this particular data set from Kaggle, and here we are going to talk about what are the columns we have. So before start with that, we are going to import two particular library for what? For doing this particular project. So first we are going to do a library for Panda, and we are going to use a library called NumPy. So Pandas is nothing but known as data manipulation library, and NumPy is basically numerical Python library, right? Let me just execute this. So NumPy and Pandas is basically for if you want to manipulate your data, if you want to, load your data, everything can be done using NumPy and Pandas. So now we will talk about the 33 columns we have in our data set. So first we have column called school. So in this case, student school. Right, so you have the student has school for whom you are going to trying to predict the grade. Okay, so binary is GP. Okay, let me just make it little big for you guys. So school is basically student school. You can see these are the two types of school we have here. Then we have the gender, right, the female or male. Then we have the age for the student age, the numeric from 15 to 22. Right, from there we have address, we have fame size. Fame size is basically family size, right? Then we have P status, then parents cohabitation status, right? They are living together and they are apart. Okay, then Medu, that is something called as mother's education, right? That is numeric. 0 means none, 1 means primary education, that is 4th grade. Then we have 5th to 9th grade, then we have 3rd grade, right? So this is something about the student's mother education. Then we have Fedu, that is father's education. Then we have mother's job, then we have father's job, right? Then we have guardian, the student guardian. Then travel time. So we will try to understand that a student is traveling how much home to school travel time, right? Then we have study time, that how many time they are going to study in a week. Then we have failures, number of past classes failures we have, right? So these are lots of things we have, you can see about the student. And lastly, we have the grade of G1, G2 and G3, right? So if we try to read our data, we will going to use a particular function called pd.readcsv. So when we are trying to call pd.readcsv, we need to give the dataset path. How will you get the dataset path? If you go over here and if you just see, if you can see 3 dots over here, if you click over here and just click on copy path, right, then your data will be copied. Now I try to understand our data in a more precise way. How to do that? We are going to use a function called .head function. This .head function is going to give you the first 5 rows of your data, right? So in this case, you can see we have our data over here. Okay, So you can see this is something data.height. So you can see this is all about the dataset loading we have learned about. Now we will see the final grade. So what is our final grade? G3 will be our final grade, right? So if you try to get only particular column from your dataset, what you need to do? You just need to write data G3. This column name is G3, then dot describe. As we have talked about the EDA part. EDA was something like exploratory data analysis, right? You can see dot describe we use to understand our data. What is the mean of our data? What is the standard deviation of the particular column? What is the minimum value you have in that particular column? Then what is IQR? That is nothing but interquartile range you have in your data, right? For this particular column. Let me just do that. So for G3, you can see the total count you have, that 395 rows you have. Then you have mean value 10.4. Then you have standard deviation is 4.58, right? Now what we need to do, we try to understand our data set in using Matplotlib and Seaborn. So this is nothing but your data visualization. Now you can see what we are going to use. We have used this SNS. What is SNS? We have used two particular library. One is Seaborn, one is Matplotlib. Right? For Seaborn and Matplotlib, we are going to do a count plot. What count plot? The final grade. Right? We try to understand what are the students we have and what is the major, up and downs for this final grade from 0 to 20. So what we have done, we have used a count plot. So count plot is automatically count the same grade and it will give you a bar graph for that. Right? So here you can see the final grade we take, that is data of G3, and we have written the distribution of final grade of students. Right? And font size we have given 35. You can make it 25 as well, as it's very big. Right? Can you see? This is the final grade, and you can see the most of the student you have the grade in 10 to 11. Right? Can you see 10 to 11 student you have, they have the final grade. The most of the student have 10 to 11. Right? So this is how you can read your data using this particular technique, that is data visualization. Now, if you try to understand what are the columns you have in your data set, right? So in this case, if you just write data dot columns, it will return all the columns you have in your data set. Can you see the 33 columns we have talked about? All the column you will get over here. Now, if you say, hey, I want to check the shape of my data set, shape is basically going to return you what are the columns you have, what are the shapes you have, basically rows you have, like the total count of that. If you just write data dot shape, it's going to give you the total row count and then the total column count. Okay, now if you want to check, is there any missing value do I have in your data set? Because from basically you will understand why do we need to understand the missing value. You need to understand missing value because we don't want to work with a missing value data set, because that will not going to give us a good result out of it, right? So in this case, we have used two particular function. One is isNull function, one is dot any function. So basically when you try to give dot isNull, is going to give you a true or false. Okay, and if you give dot any, it will try to find it out for each and every column. Do you have any null value in your data set? You can see for all of them it's showing false. So basically your data set is really good and you don't have any null value in your data set. Now if you just use dot sum instead of any, it's basically going to give you a total sum of the null value you have in your data set. So all of the cases you can see this is 0. Right? So now I just want to understand the total male student, right? Total male student and total female student. We try to use a length function, and where we have used the sex equals to male, when it's sex equals to female, it will give the length out of it, right? So if you just write male student and female student, right? If you just do that, you can see the number of male student is 187 and number of female student is 208. So basically it's going to give you, you can see the female students are high in number in your data set, right? So now if we just try to understand a few other things, right? So in this case, maybe we will try to do a average of the grade average. How to do that? So you have G1, G2, G3, and you can just directly do the average out of it. The data of G1 plus data of G2 plus data of G3 divided by 3, right? You will get the average out of it, right? Now, if you try to make a data, like, if you try to map your data, okay, using this particular one, you can do that. Basically, you can write that 90% above, you need to give a grade A. If it's 70% and 90% above, you will get a grade B. And if it's 70% above, you will give a grade C. You can do that, right? Using this mapping, this particular grade average. And if you don't want to do that, you can actually skip this particular part as well, right? So in this case, what you need to do, we are trying to drop two particular column. What are these two particular column? We are trying to drop school and age, right? School and age is not at all useful maybe for our particular model making. That's why we are going to drop these particular two column, right? Okay, it's already dropped. That's why it's giving me error. Cool. After that, if you just do this particular data dump dot head, you can see, and if you want to check what are the columns you have, you can see this particular dot columns. If you just write this, right, what the columns you will get this, all these things, right? So we have dropped school and age. So school and age is not there over here. You can see. Now we are going to do the mapping. What type of mapping we are going to do? If you can look over here, you can see we are going to map with 0 and 1. Why? Because this all the data we have in string, that's not going to work with our model. So we try to make it in a categorical value with 0 and 1. Yes is 1, no is 0, using dot map function, right? For all the cases, we just need to do this particular data encoding. You can say this is categorical value. We are changing it to categorical value. Lastly, when you have done this, we try to use our data in X. We are going to use all the data except G3. We try to find our G3 for the student. And you can see we are going to use scikit-learn over here. So why do we need to use scikit-learn? Scikit-learn is the library for machine learning. You can use all the machine learning algorithm using scikit-learn, and where all the things are already explained, implemented. You just need to call this particular algorithm and your work is done. So now if you look at xtrain, xtest, ytrain, ytest, we will going to divide our data set in 4 different forms. One is for training, one is for testing. So you will have 4 parts of your data. Now we are going to actually import linear regression from scikit-learn, right? And we will call linear regression. Okay. And if you just try to train your model, you have to call l.fit, right? If you just call l.fit and if you give your train data set, and then if you just write l.predict, it's going to predict, right? What will be the G3 for your students for the testing data. Now you can see, if you just want to check the score of the linear regression, you can see 77% your model is working accuracy with the new data. So you can say your model is working really pretty fine, and you can actually make more, you can do some other techniques like data normalization, missing value treatment, outlier analysis. If you do all these things, your accuracy will obviously increase. So guys, I hope it's actually help you to understand to get started with machine learning, one particular project in machine learning, that's student grade prediction. Google Colab, I hope you all know how to do Google Colab. So Google Colab, I'm not going to show you how you are going to use Google Colab, right? Okay, so what is this data all about? As we know, beer is one of the most democratic and consumed drinks in the world. Not without reason, it's perfect for almost every situation, right? From happy hour to large wedding parties. If you just think about it, you already feel like having a beer, you are not alone, right? The truth is that around the world, thousands of people consume drink regularly and also in different situations. But have you ever stopped to think about which countries are the most consuming beer in the world? Did you? Okay, the first one of that came to your head was Germany. Well, no, that is not so. The answer to the question is resounding that according to the research by the Japanese beverage company Kirin, the country has topped the per capita beer drinking table for 23 consecutive years in 2015. The most recent years for these statistics are available. Right, the seasons drank 142.4 liters per person. Can you even imagine? Right. Yes. So that's the equivalent to 250 pins, right, on every 35 hours. But given that minors are unlikely to be contributing to the figure, it's safe to assume the average beer drinker probably guzzles quite a bit more. Snapping at the Caesar Republic's hills are the usual pretenders. Australia and Germany come third and fourth. Poland sixth and the Ireland seventh. There are some surprises, however, in the second place in the Alofi ranking, which we will put down to the hot climate and the larger number of hallmarks. Right. So this is the whole data set is all about we are going to talk about, right? So in the data sample were collected from in Sao Paulo, Brazil, in the university area, and where there are some parties with group of students from 18 to 28 years of age. So this is the data set we are going to talk about. Okay, the data set used for actively 7 attributes being targeted with a period of 1 year. Okay, right. So this is the data set we are going to talk about. So this data set you will get in the Kaggle itself, right? Beer consumption or beer data set in Sao Paulo, right? Now we are going to use some of the libraries. We are going to use NumPy, Pandas. Why do we use NumPy? NumPy is a numerical Python, right? So we use NumPy for numerical purposes. We are going to use Pandas for data manipulation. We are going to use datetime to make our data into converting to datetime. So yes, now what we are going to use? We are going to use Seaborn and Matplotlib. Why we are going to use Seaborn and Matplotlib? For the data visualizations. And scikit-learn we use for confusion metrics and machine learning purposes, right? Now what I have done, I have taken this data to the Dropbox and I have already saved over there, and I am just fetching from the link, right? So for that we are going to use wget function. So wget function we are going to use because it's help us to fetch the data from any given link. So you can see over here, let me just execute this and this. Okay, so in the beer data, we are going to make a variable called beer data where we are going to use pandas, and we are going to use .read CSV function to read the CSV data. So as you can see in the beer data variable, we got our data. If we can use .head function. So when we use .head function, what we do in the .head function, we get first 5 rows. It will return you first 5 rows of your data set. Let me just execute this. Okay, so this is our data. Now if you want to see what are the columns we have, right? So just to try to see what are the columns we have, just put dot columns, right? If you just write dot columns and then you will get what are the columns you have. I have data, temperature media, temperature minima, temperature maxima, precipitação, final day semana, all these things, right? So yes, we have these columns. Now if you want to go for doing the dot shape, this dot shape is going to say how many rows and how many columns you have. We have 941 rows and 7 columns. Now comes the data evaluation, or you can say exploratory data analysis part. Now we are going to use .describe function. In the .describe, what you will get in the .describe, it's going to give you count, min, standard deviation, maximum, 25% IQR, 75% IQR, 50% IQR. So this is the what we are going to use .describe function to describe your data set. Okay. Now what we are going to do, we are going to check is there any NaN value is there or not. Fine. So we are going to check is there any NaN value or the missing value is there or not. To check that, we are going to use .isNA function. So we have our data beer data, then we are going to use .isNA function to check is there any NaN values is there or not, and then we are going to use .ini, right? Let me just execute that. They say no, there are no missing values are there. Your data is actually good to go. Now there is for the null columns, again if you want to see what are the null values you have and the percentage, right? So number of null values and percentage you will get over here. Now if you say, hey, if I have any non values, then please drop that. How to do that? Beer data dot drop any, then in place equals to true. It's basically we use drop any function to if you have any rows with non values, then please drop it. We don't want that. Now we are going to, as you can see, there are lots of strings are there, right? If you can see, there is a comma, right? What we can say, hey, I don't want comma, I want to make them as dot, right? So we use dot replace function to make those comma to point, right? So this is how we are going to use beer data dot replace comma, that is going to replace with dot. Regex is equals to true. These are the rejects we called as, and in place equals to true. Let me just execute that. Now as we have data, in that data we are going to make those data as a, let me just print that beer data dot height, right? What's gonna give you? It's gonna say when you have data, these datas are basically date, right? So we just change those data to a date. How to do that? Called pandas dot, okay, we are going to do pd dot to date time, right? So we are going to do what? We are changing our data columns. Okay, we are changing our data columns to date time, right? So for that, pd dot date time, and which column, which particular column you want to change to date time. Now as we can see, the date time is we are going to use to date time. Now as we are saying that days, what do we have Monday, Tuesday, Wednesday, Thursday, Friday, Saturday and Sunday, and we are trying to figure it out that in what day the beer consuming is high. Okay, now as we can see the days, okay, days is like Monday, Tuesday, Wednesday. We are going to make a column called days, right? Okay, now in the day, what we are going to do? We are going to use a lambda function. What lambda function we are going to say? We are say beer data, that the data one that we have make this to date. So we are going to say days dot weekdays, right? So whatever date, as it's already a date, so if your date is saying, okay, this is a date, so what are the weekdays? Make it weekday. What are the weekend? Make it weekend. Okay? So if you go and check this out now, let me just execute this. Yes, if you can see that, I don't know if you can see the full one or not, because of my picture is coming in the corner. So maybe I can do one thing, beer data dot columns, right? So you can see there is a data is there and there is a day is also there. So 2015, this a little one is coming one. If you can see, 20150102 was a Friday, right? So what you have done with the lambda function, you make those data or the day into the weekdays or weekends, right? So this is how we are going to do that. Now, okay, now what we are going to do, we are going to say, hey, we are going to use a Seaborn, right, to visualize our data. So in the Seaborn, what I said x will be x, we need to give the data. So x will be day and y will be consumer day cerveza. What is consumer? Is basically how much consuming you are beer, how much beer you are consuming. And here you are giving the data is equals to beer data. Let me just execute this. Okay, can you see, if you just look at this graph, you can see the Saturday and the Sunday has the most consuming beer, like if you can see in the graph. So can you see the Saturday and Sunday has the most beer consumed, right, as it's the weekends. And if we look at the Friday, Tuesday also there is a little high, maybe after Monday the still is there. So yeah, Saturday and Sunday is the highest, right? So this is how you can understand that, okay, beer consuming in Saturday and Sunday is really high. Then we are going to use a machine learning concepts. Before that, we are going to drop data and day, right? Okay, and we are going to make it numeric. This data and day, we don't make this two is as a numeric, but other whatever we have, like maximum temperature, like according to temperature, if the temperature is too high, you don't want to have beer, right? Okay, right. Now what we are going to do, you can see we are going to make it numeric because we are going to use all the data. Now what we are going to do, we are going to say train, trace, split from sklearn. Sklearn is basically a scikit-learn where we are going to divide our data into training part and the testing part. In the training part, whatever the data we are going to show, we are going to use our train our model. Our model will not know about the testing part. So what we are going to do, to do that, we need to write scikit-learn.model selection import train, trace, split, right? From there, we are going to drop one column, that is the liters, right? According to all the attribute, we are going to try to figure it out how much the liter, what will be our consumption, right? So we are going to drop that particular column. So after that, X will have all the attribute, Y will have only the beer consumption. What is the total beer consumption? So this is our label data. This will be your label, right? What is the total consumption? From there, if you can see, we are going to make 4 parts. One is X train, X taste, Y train and Y taste, right? From there, we are calling a function called train, taste, split, and we are giving our whole data, X, Y. And you said, I want 20% data to be test data. And random state equals to 42. What is random state? Random state is basically, it can take any random data. There is no fixed point. First 80% will be your training and the last 20% will be your testing. Any data can be taken for training, any data can be taken for testing, right? This is why we use random state. Now we are going to import linear regression. As you know, the consuming beer liters can be a the continuous number that will not be 0, 1, true, false, right? So it will be linear regression. So we import linear model from linear regression, that is from scikit-learn, and we call linear regression function. Let me just execute that. Then we feed our model. So we are going to feed our data using X train and Y train, right? So in that case, let me just feed means you are train your model with X train value of X and Y. If you can look at here, we are going to predict the X taste. We are going to give only the attributes. According to that, it's gonna give you, okay, you gave me X taste. So if you can look at it, Y rate, right? This is the beer consuming array you got, 25.60, right? And if you look at the Y taste, right? No, Y taste. So what Y taste will have? Y taste will have the actual beer consumptions. Can you see our model is working really good? It's saying for this is 25.6. This is also giving 25.64. For the next one, it's giving 27. For the here, it's giving 31. Right? So basically, X taste is like the prediction is basically going to give you what will be the beer consumption. And if you look at the score, I mean the accuracy with the new data, that is 74%. You can increase that as well. Right? So this is our full demo. How can you predict beer consumption using machine learning? As we were talking about linear regression, so linear regression is basically a regression type where you can, the way we did, right? Independent variable, dependent variable, and we talked about that. Now, as we already talked about the prediction of beer consumption, I hope you like this demo. So let's have a look at emotion detection using Python. This is the most interesting part, and we are going to do this on Google Colab. So if you want to start with Google Colab, just write Google Colab and just hit enter. You will get the first link over here, right? Click over there and just go for new notebook. So this is how you can start working with your Google Colab. Now, if you see at the runtime, I am going to use GPU. But why GPU? So emotion detection, we are going to use some of the images, right? So whenever we are going to use images, that time basically we need to actually like our computational power will be very high. Okay, your deep learning model needs a high computational power. that time we need to go for using GPU, right? So the Google Colab basically gives you a free GPU. That is why Google Colab are actually getting the popularity. It's giving you free GPU and free TPU. Okay. Now just change runtime type over here. Click on the drop down menu and just click on GPU and save. Right. Whenever you are going to use any deep learning model, whenever you are seeing that your model is, your data is very high dimensional data, you have to go for using GPU, right? Now what you need to do, it's already ready. I have made my notebook and I'm gonna show that to you, but I cannot train my model over here because it's going to take a long time. But yes, I will show you everything over here. So first we are going to use pandas. So why do we need panda? Panda and NumPy is basically a data manipulation library. Now we are going to use Keras. So whatever the thing I have shown you about CNN, you don't need to write the code from the scratch for all of them. So already we have some predefined APIs that already predefine those functions. So we are going to use Keras. Keras is one of the most used API. And from there, we are going to import sequential because all of the deep learning model are quite sequential. So from there, we are going to import keras.layers, the layers we have in CNN, the fattening. So dense is basically your fully connected layer. So in library, fully connected layer is known as dense layer. Then we have dropout. So what is the dropout walk? Because this is something technique we use when we don't want our model to be overfitted. So I get some of the questions that what is actually GPU and TPU? GPU and TPU is basically, if I go for a technical term, better I just give you a layman idea. GPU is basically if you have a high computational data set, if you have a big data set and if you want to process them, that time you need to go for using GPU and TPU. Now what we are going to do, first we have imported all the libraries. Okay, now I have uploaded my data to Dropbox, and if I want to fetch that, how can I fetch that? Using wget command. Okay, so in Google Colab, if you want to use any command line command, you can go and you can use that. Okay, from that I have unzipped my data set. So you can see FAR 2013 data set. So go for doing that. After I have unzipped my data, then I am going to divide my data set into 4 parts. One is X-train, Y-train, X-trace and Y-trace, right? So why do we need to do that? We need to do that because I want my data is in a 2-part. My data is in a label data. So in Y-train, I will have all the data that is basically the class, that is the label. And in X-train, I will have all the features, right? Now what we are going to do, we are going to use 4 part. One is train test part, and the which train part has all the features, and the one will have all the labels, right? Now I am going to read the CSV, that is FAR 2013 CSV. Now what we are going to do, we have already read the data. Now I just want to check our data. Okay, so there are 3 column we have, right? One is for uses. What is uses? In the data itself, we are saying, okay, this data is for training data and this data is for testing data, right? So now if we see the users equals to training, then please append those value in float 32, that is for emotion. Okay, and for Y test, again append the feature in X test and append the label for emotion in Y test, right? So this is how we are actually going to divide our data into testing and training. Now what we are going to do, now we are going to say, okay, number of features we have, that is 64, number of labels we have, that is 7, and batch size I want 64. So what is a batch size? So if you have a big data, from there you can divide your data into few batches. Okay, after you divide your data into few batches, it will haphazardly take any batch from your data, and if you give epochs like 50 or 60, that time it will keep on training your model using those batches, right? So this is how we are using this batch size and epoch concepts. Okay, now if you see width and height, what is width and height? So this will be your image width and height, right? So your image width and height will be 48, 48. If you want to go for taking 128, 128, you can go for doing that. Now you can see in my X train, I have all the features, that is float 32, that is the data type will be float 32. And in Y train also we have the same value, X train, Y train, X test and Y test, right? We have converted them to an array. Now we are going to use a categorical. So as we see, if I can show you that, I think that will be okay. FAR 2013 is taking time. So if I can show you the raw value, that time you will understand what is this. Basically, we have classes. Okay, so we have few classes. So we have 7 classes. Okay, so we have 7 classes, and from those 7 classes, I want to change them to a categorical value. Right? So how can I change them? Using 2 categorical class. Okay. So after I change them, then I normalize my whole data. If you don't normalize your data, there is a chances that you will get some error. Okay. After doing all the pre-processing, then I am going to make my model using convolutional neural network. So if you look at this, so first I have used convolutional layer. Then I said 64 is my neuron. And then this kernel size is basically your filter size, right? Then the activation function is equals to rel. Okay, this is how we have convolutional layer, we have max pooling, we have dropout. So basically dropout we use, suddenly it will drop any neuron from your model. Okay, then for the second convolutional layer, we have made this. For the third, it's up to you what are the layer you want to add. But before go for the fully connected layer, you have to sure you have flattened your data. If you don't flatten your data, you cannot go for doing the fully connected neural network. So after flattening my data, I have used a dense, that is a fully connected layer, where we will have 1024 neurons. Then we have a dropout of 0.2. I want my dropout will be 0.2. Right? So lastly, we have a dense layer, number of layers, and activation is equals to softmax. Okay, this is how we make our model. Now we need to compile our model using loss categorical cross entropy, optimizer of like SGD, and matrix is equals to accuracy. Right? So these are the basic terms. Then we feed our model, and you can see I have fitted my model for 50 epochs. Right? 50 epochs. So here my validation loss is 1.1 and validation accuracy is 0.5. As it was taking a long time, so for that we actually take a less epoch. So if you have time, so you should go for taking a high number of epochs. Okay. Then what we do, we actually give a image to our model. Okay, this is our image. You can see this is our image, and please predict the emotion for that particular person. So if you look at this, so these are the OpenCV part. I have already done a video on that. How can you do that? So if you have still doubt on this, you can go for doing that. And lastly, we got a result that this particular man is happy, right? So this is how our emotion detection are working. Now we will go to our demo part and we will have a look at how can we do gender detection using Python, right? And using this convolutional neural network. So go to your favorite browser and write Google Colab, and I will get the first link over here and I'm going to click on that. Okay, so I'm going to click on this Google Colab, and here you can see there is a new notebook called. So I'm going to click on there, right? Okay. So what you need to do after you get your first notebook, so I will just suggest you guys, whenever you are going to use any emotion detection or you are going to use a convolutional neural network or deep learning algorithms, I should have suggest you guys go for using GPU, right? If you are not using GPU, it will take a long time to train your model. And why I prefer Google Colab for that, there is an inbuilt GPU, right? This is provided by Google, and it actually help you to train your model very first. But be sure there is one constraint over here that Google actually remove all your data after 12 hours. So whatever the thing you are going to do in Google Colab, be sure you have saved them. So you can see here, if you want to use a GPU, how can you do that? Right? Go to runtime, and over here you can go to change runtime type. You can see there is a drop down you will get. You will get GPU and TPU both. So in my case, I am going to use GPU and save. So basically, when you put the GPU, it will automatically transfer your kernel to GPU, right? So this will basically help you to train your model with more first, right? So otherwise it will take a long time. So I have already made my notebook, and in this project, whatever the data we are going to use, I made my own data set. So basically what you guys can do, you guys can make a folder, and I will show you how can you make your own data set. So if you start doing these things using your own data set, there is a plus point that you can change them according to your users, right? So I did not take my data from anywhere, like not from Kaggle, not from anywhere. So in today's video, whatever the data set I'm showing, this is made by me. So you can see in this, here you will get this symbol, right? So you need to click over here. You can see already I have stored my data into Dropbox, right? And if you want to fetch your Dropbox data, how can you do that? Write wget and then your Dropbox shareable link. Okay, so from that it will directly fetch your data. Now what I'm going to do, you can see I'm going to unzip my data writing this. But how can you get the path for that? You can see over here there is a 3 dot, click on there and call the copy path, right? So this is how you can do that, and just paste the path over here, right? Control V, just do that. Okay, so it's going to unzip my data, whatever the data I have put in. So here it will be N, so I don't want that. Yeah. Okay, so you can see what I have over here. Now I am going to write my image width and image height. So in my case, whenever you are going to, not in my case basically, whenever you are going to do any image processing, you need to provide your image width and image height, right? So for my case, I took 150 and 150. Now I just want to mention the directory I have for my training data. Okay, so if you can look at over here what I got the problem. So you can see when I'm trying to do the unzip part, so that time my data is unzipped, right? So already as my data is unzipped, is going to ask me that, do you want to just replace all your images? So I said yes. So it's trying to like replace all my images, right? So basically it's taking a lot of time there because I have almost more than thousands images in my data set. So if you look at my data set, you can see I have two parts in my data. One is training set, one is testing set. From there, if you can see, I have two folders. One is main folder, one is women folder, right? So main folder, I have lots of main images, and for women folder, I have lots of, you can see, these are the images I have. I will show you, and there is a woman image I have. So this is how I make my data set, right? Now what I am going to do, I am going to fetch those data. So I have already said that we are going to mention our image width and image height. Okay. From there, I am going to take, say, this is my directory. So you can see from gender dataset phase, I have training set, right? And I also have testing dataset, right? So this is how I have cleared my directory. Now I said for my training sample, I am going to take 10 for each batch. But what does that mean? So basically, when we talk about epochs, epoch is basically the how many times your full data set will be trained using the algorithm, right? So it's basically, it will try to take batch wise. So now we have batch. So how does this batch works? So you have, suppose, a batch size of 5, right? So it will take different type of batch, like one batch will have 5 images, right? So it will take each batch and it will just keep on training your model, right? So in that case, how many times it will train your model? It will train your model for 50 times. So this is the actual concepts of epochs and batch size. Now we are going to use a channel first. So what does that mean basically? So when I was talking that, okay, my image is basically going to have a dimension of 3. Then it will become image. Then you should have image width and image height. That is 150 and 150. Right? So first check my image is already channel first or channel last. There is 2 options we have. right? So in any one option you can take for your images, right? So this is the format we want our data to be in, that channel first or channel last. Now I am going to import some of the Keras like libraries, but Keras is basically a API that is based on TensorFlow, right? And it already have this predefined algorithms we have for our convolutional neural network. Maybe this is come under GAN or whatever the algorithm we have under deep learning, right? This is already predefined and we just need to call those things, right? You can see over here, I said the convolutional neural network is always a sequential model. And you can see we have dense layer. Dense is basically the fully connected layer we have talked about. Now this is convolutional 2D. See, this convolutional 2D is basically, you can see it's already came convolutional layer, right? Then we have flattened layer that we have seen over there, that flattening your data to 1D array in the before you put your data into a fully connected network, right? Then we have max pooling layer, the pooling layer we have, right? Lastly, we are going to use an activation function. So this is all the layer I have imported from Keras. Now what I need to do, now I am going to write our image generator. But what is this image generator stands for? So basically this image generator helped us to make different type of images, right? So rescale equals to 1 by 255 is basically normalizing your data, okay? So basically this is something normalizing your data. And then there is called zoom range. It will going to zoom your like images, right? So why do we need that? Horizontal flip. So basically it will make one image into different type of images, right? So one image will convert into 3-4 images, like maybe one image will be more zoom, one image will be horizontal flip, someone is like the different flip, right? So basically why this is we are going to do it, basically taking the feature from an image, right? From one image you will not always get the proper high featured portion. So this is why we need to use image generator, right? So this is, you can see from here we found 1641 images we have belonging to two classes. That two classes are our main and woman class, right? And the same way we are going to do for our taste datagen as well. This is basically we got how many from the taste data set, that 666 images that is belonging from two classes. Now let's have a look at how this basically this zoom in range and this train generator works. So what I just said, let me just execute that. So you know, just to do that, what we do, we use a matplotlib, right? So matplotlib is basically used for like visualizing our data, right? Okay. Now you can see over here this one image is more zoomed, right? You can see most of the images are zoomed and some of the images are flipped, because this is something we use to get, okay, what are the features we have from our image? Try to read those images, right? A computer basically try to do that. Now comes the building your model. So how can you build your model? You can see I have written model equals to sequential. You need to call the function. So basically sequential, we know our convolutional neural network is a sequential model. Now we are going to add the layers. Now you can see I have written convolutional 2D and then this 64. But wait, what is this 64 stands for? This 64 is basically how many neurons you want to have, right? So I want my output should be 64, right? Now this is 3 cross 3. This 3 cross 3 is basically your filter, right? The filter we are using 0, -1, 1, -1, right? So this is how your parameters works for convolutional 2D. Okay. Lastly, I said input shape equals to input shape. This is basically the channel first or channel last, that what way you want to use your data. You can see for my case it's already coming 150, 153. Now from here, what you need to do, now as you get it, now I'm going to use a ReLU layer, right? So ReLU layers is our activation function, right? So I'm going to call our activation function, and under that in the quotation I'm writing that what activation I want a ReLU layer. Then I am going to use a max pooling 2D. I hope I am doing the same thing I have shown in the presentation, right? You guys are actually understanding what we have. Now I say pool size equals to 2 cross 2. So you got it. In the pooling layer also we have a matrix, right? So for my case, I given a size of 2 cross 2. Okay, so this is how our max pooling is working. It's actually help us to reduce the size of the data. And lastly, we have flattening way. So we also talked about, now as you get your most featured indexes, now you need to flat them to 1D array, right? That is 1D channel. And lastly, I need to put those data into fully connected layer. So this fully connected layer is known as dense layer. So what is the 64 basically? The 64 neuron you will have, if you can see over here, I have 64 neuron over here. If you want to change, you can change it, right? So I am going to put the 64 neurons with 3 cross 3 filter, right? Now again in the hidden layer, I am going to use our activation function ReLU. So this is optional. If you want to use, you can use it. So I used it because I don't want any unwanted value in my data, right? Lastly, you need to have a output layer. So that output layer will also be a fully connected layer. But in that case, you need to write how many neurons will be there. There will be only one neuron, right? So this is how our output layer works. Lastly, you know what? In the last layer, you will get a probability, right? In that time, you need to use a activation function again. So I use sigmoid for activation function. If you want, you can use ReLU layer as well. And lastly, I have a model summary. If you look at over here, so you can see I have 148, 148, 64. So what is this? This 64 is your neuron, right? After using activation function, again you have a 64 neuron. You can see I will constantly have 64 neurons. And lastly, I will get my output, right? That is 1. Okay. Now I am going to compile or train my model. So when we are going to compile, we need to use some optimizer. But why do we need to use optimizer, right? So optimizer is basically used because we need to have an idea how can you optimize your model, right? And loss, I say this is binary cross entropy. Why? Because I have 2 classes, right? So let me just do that. Okay. Now what I need to do, I need to feed. Basically, I need to train my model. How can we do that? Using, first you need to give that train generator your data, then your epochs, right? You can see your epochs validation data, and these are all the things you need to have when you go for train your model. It will take few time because training model is actually taking few time. Yes, let me just check. Okay, you can see for per epoch it's getting trained. So our model got actually trained and the accuracy is kind of a 68%, right? For the training data set. Now let's have a look at what is for the testing data set. Let's just, okay, so model accuracy is not bad. So you can see over here, yes, so this is the model accuracy is not that bad. You can still improve your model. Now I am going to take a picture and I'm going to check if it's going to work or not. So if I need to check my picture, so maybe first I need to go for printing my image, right? So let me just do that. img is equals to, or maybe we can do it over here. Okay, so let me just show you guys if I can show you. Yes, there is a sad.jpg image I have. Yes, you can see I have this image for the prediction, right? So I want to predict this picture and the gender for this particular image, right? So let's have a look at that. So this is my image, right? So that is sad.jpg picture I have. And let's see what my model is going to say. It's a man or a woman. I don't know. My model is going to say this is a woman as well. Let's see what's my model is going to say. Oh my God, my model is actually giving a good answer. So let me give you an answer like what is actually working over here. So image dot load image is basically just to read your images, and my target image size will be 150 and 150. Why? Because I have trained my model into 150 image width, 150 image height, right? Then I have changed my images to image to array. You can see image dot image to array is basically changing your image to array, right? Now I am going to write that if my result is the array is equals to 1, the prediction will be woman, otherwise the prediction will be men. So lastly, I have printed my prediction. That is, my prediction is main. That's quite right. Now I want to just print that to my image itself. Let me do that. Yes, in my image, when I have give that image to my model is saying, okay, it's a main. You can see it's already coming over here. It's a main. But how can we do that? Right? So we are going to use CV to put text. Right? So some of you are asking about OpenCV. So this OpenCV is basically it's a computer vision library we have under Python. So if you want to do any kind of a computer vision, you can use this OpenCV. Right? So here we use a .cv2.putText method or the function basically just to show our prediction. So we got our prediction over here. You can see that is main. I just put that in my image, right?
Now, here we are at the last section of this video, that is summary. Let's have a quick recap. First, we understood what is machine learning, which is a subset of AI, and also it will enable systems to learn from data, and it can also make decisions for us, and it will help the user in order to have a perfect program according to their requirement. Then, we spoke about supervised machine learning, which involves training models, and also with the help of labeled data, this particular training is being done. Then we spoke about linear regression, which is a statistical method in order to work with the models and their relationships. Later, we also learned about logistic regression, which is a classification algorithm basically. Unsupervised machine learning always identifies the patterns in data without labeled responses. That's the specialty of unsupervised machine learning. Later, we started with the demos, that is the case studies. First, we ensured how does the Marvel superhero analysis happen, and we examined superhero attributes like powers and affiliations to uncover the insights about their characters and popularity. Followed by fake news detection demo. Here, it utilizes machine learning to classify news articles which are real or fake. That is the overall picture we understood from this particular case study or demo. Then, predicting fleet failure in car rentals. It uses the historical data of the vehicle, its risk failure, and it also enhances the maintenance scheduling and efficiency. This was discussed in the demo of predicting fleet failure in car rentals. Later, we saw the demo on how smartphone price prediction is made, followed by a prediction project using machine learning. It involved creating models, forecast outcomes, various domains using historical data. Then, we spoke about IPL winner prediction, which leverages the historical match data to forecast outcomes of IPL matches by using machine learning. Here, we saw the demo on emotion detection using Python, where the models are built to classify the emotions. At last, we saw the gender identification in photos. If you upload a photo, it will classify according to the gender, whether it is a man or women. So, by using the deep learning algorithms, this could be achieved. Hopefully, this particular video was very informative and all the hands-on projects help you to enhance your knowledge. We'll meet you in the next one. Thank you.